guys, greetings from Bulgaria. This will be the first module from a new series dedicated to creating a comprehensive test automation framework. Before we begin, hit the ring bell so that you get notified about any new videos published on the 𝐓𝒏𝒕𝒐𝒏 YouTube channel each week. Also, check the 𝐓𝒏𝒕𝒐𝒏 blog because there are many advanced test automation tutorials to help you become a much better test automation engineer. Let's quickly review what we will cover in the upcoming modules. This is just a group. Each group will contain multiple videos. First, in this particular module, we'll start with pinpointing precisely what we aim to achieve with our framework, exploring open source tools for inspiration, and setting a solid foundation for innovation and effectiveness. Create a list of requirements, parts we want to include, and features. Then, in the sequential models, we will start with creating a web project containing core components and services for web automation. Then we'll proceed with mobile test automation module and API project where we will use some web APIs for test data management and performance checking. Also, after that, in the complex component mastery group, we will create some more advanced web components for handling, for example, data grids or modules such as online editing like Word. Also, we will integrate some third-party integrations for email, SMS testing, handling two-factor authentication captchas, of course, integrating into the 𝐓𝒏𝒕𝒐𝒏 cloud. After that, we will proceed with configuration management for handling different test environments, implementing logging, supporting responsive testing. After that, we will handle and improve our test automation framework to integrate more features like bidirectional APIs, CDP. We'll integrate some reporting solutions, handle some like security best practices, like key vaults and others. And we'll focus after that on execution and scalability. But more about that later. Now, in this particular module, we'll begin by talking about what is the problem that we try to solve. We'll discuss some steps and phases during this initial assessment and evaluation of different solutions. And we'll decide later, I will give you some hints how to decide whether you want to pick an existing test automation framework or to create your own. Of course, the whole course is about teaching you how to create your own. So we'll create at the end a development plan based on the requirements that we developed and picked, and using the assessment criteria that we defined. So let's get started. What is the problem that we try to solve? Many companies at some point decide to start automating their QA activities and regression tests. And for some new projects, or whether you want to establish a test automation from the start or later. So these companies, they have to pick the right tool or solution for doing that. And we're going to discuss this approach for selecting the tools to evaluate, compare them, and decide which is best, maybe. And in the end, you will know whether to pick an existing test automation framework or whether to create your own. The first phase is first you need to create a list of requirements that you want to achieve. For example, automate the login page, create new accounts, submit tickets, create new purchases, run the test nightly, etc. And how to do that, you can brainstorm with your team. Maybe you can ask another division for if they have a very strong QA architect, to borrow the architect for a week or two to help you with this particular research. Maybe you can find and hire for a while a consultant or consulting agency. and maybe you can do stakeholder interviews. Just remember that stakeholders, such as business owners, often don't have the technical expertise or understand completely the testing process. But you can ask them, interview them, so that you can find what is important for the business to define those requirements. Now, during the second phase, we need to research existing solutions. There are many of them. I will, in a minute, we will review and I'm going to show you how to do that. But maybe we need first, in order to be able to filter all of the different solutions, because there are so many of them, we want to pick just 3 up to 5. So we need to define the so-called hard requirements that in a minute we will discuss, and ignore for now the nice to have stuff, right? So based on these hard requirements, we'll filter among the tens of thousands of the hundreds of solutions out there to pick just a few, these 3 up to 5 more serious candidates. And this will be the solutions that we'll further use for creating the proof of concept and later to assess. So first we need to define those hard requirements. You can ask for some recommendations in user groups or in LinkedIn, or if you have some kind of meetings in your country or town, or you can just search. I'm going to show you another way because our framework will be based on WebDriver, so they have a good list with official frameworks that are part of the ecosystem. Now, some hard requirements, at least for me, that I usually use, because many of the enterprise projects that I'm part of, they have a web interface, they have a mobile interface, so we need to be able to automate both. It needs to be an open source solution. We don't want to pay licenses. This doesn't mean that it will come for free, as we'll discuss later. We want a community support. We want to have very good documentation and tutorials if we pick an existing framework, so that we can learn how to use it. And we want frequent updates to support latest devices, browsers, handle some security flaws, etc. These are our hard requirements. And later we need to define some, the next phase is to define some criteria which you use to compare the solutions. Since all of them are more or less subjective, we will provide later a rating from 1 to 5 for each of them. Again, a little bit later I will show you an example, but let's first discuss them, right? And again, this is just an example. You can put whatever you believe is important for you. For me, usually it's the solution to be a programmatic one, not to use some kind of a no-code solution, right? But it will be up to you generally. So some of my assessment criteria are again to be able to automate web, maybe with WebDriver, but it might be Playwright if you choose. Maybe automate mobile. Again, my preference is to use Appium underneath, to have a good documentation. Maybe to be really easy to create new tests and to start very fast. Again, this is a little bit subjective, and it will be depending on maybe the coding skills of the different team members. This is why, as we'll discuss later, it will be good to integrate more people into the process of evaluating the different solutions from different seniority of your team. Testability. Most of the frameworks that we're going to pick to research offer such capabilities, like internal weights, etc. For me, really important is this failure troubleshooting analysis, because after you create the tests day to day, when the tests are executed, it should be relatively easy for you to understand whether when the test failed to understand whether there is a product bug, problem in a test, in the test environment, in the test data, etc. Also, test readability. Again, this is a little bit subjective. As you'll see, some frameworks that we're going to discuss use font interface. For me, this is not so readable, but many people prefer it. Again, this is a matter of choice and preference. This is why, again, more people should be included, not just the QA architect or QA lead. Quality execution support, like executing the test in platforms such as Lambda Test. Easy integration in your existing continuous integration tools. Reporting tool support. Most of the tools, whether they use the standard tools usually, like Allure or Report Portal, or the reporting tools of their continuous integration systems, but still some solutions, they offer their own reporting, and this is important for you. Also, for me, in order this to be a real framework, it should allow you to customize it and extend it, and it really depends on how much time is needed to understand how to do it. Some of the frameworks that we are going to research lack of documentation about these more advanced capabilities, even if they offer it, or just provide, I don't know, a GitHub example without much explanation. For me, another important thing, no matter whether this is mobile or web, is to be relatively easy to support multiple environments through some, for example, JSON configuration files, to support responsive testing, secrets management, very important, this security stuff. Specific tools integrations, I guess some frameworks come with pre-written integrations instead of allowing us to write new ones. And maybe one of the most important criteria is to have different options. For example, if your application and your development team is using .NET or C#, probably the framework itself should be written in C#, and you need to use the same technology stack, or Java or JavaScript. It will depend on your team or company. Now, before we proceed with the phase 4, implementing the proof of concept, I want to show you how we need to do this initial type of research of existing solutions, how I usually do that. For me, the easiest way, especially if you pick WebDriver for the web part, is to open Selenium website, and when you go to About, there is a link to the ecosystem. Under the ecosystem page, you can find the different drivers, the different bindings, and there is a section about most of the available frameworks out there. As you can see, even you can see my name with the 𝐵𝒐𝒐 framework. It won't be fair to use it in this type of evaluation assessment, so I will skip it. I will use some other frameworks, like for example, Atata framework, Selenite. Maybe we can see some examples from this Shaft engine. I found it really interesting. So I opened Atata. This is one of the popular C# frameworks beyond 𝐵𝒐𝒐. It's really cool. I use it. It was created before 𝐵𝒐𝒐. For me, it's relatively complex at places. I always start with looking into the getting started section. Even if you don't use the framework directly, and at the end, if you decide to create your own framework, this type of research is very important, because you can all of these solutions, they are open source. This means that you can pick some parts of them and integrate them in your own thing. Usually I'm against reinventing the wheel and every time writing your own thing if something very good exists, but it really depends on the context. When I was writing initially 𝐵𝒐𝒐, I researched all of the frameworks out there, no matter the programming language, and I picked the best part of them and, rewrote in a way some of their features. So Another thing that you need to consider is how you are going to use the framework. For example, this particular framework, it's used via NuGet packages. My preferred way, and we will include that into our high-level development plan, is that I prefer to use the framework as a Git submodule. Maybe in the next video I'm going to explain that in more details, but this means that you're going to create your own repo and use the framework as a subrepo of your own. And this means that all of customizations, etc., will be out of the original framework repo. And this way, it will be easier for you later to pull the latest changes and updates from the framework, right? If you use NuGet packages, it's really tricky when you want to debug the framework, and this is why this is important. Instead of just cloning the repo and directly creating a new project inside the solution of the framework itself, it will be really hard for you later to create pull requests or to do some updates. So another thing is that Atata, for example, they have an installation plugin, I think, and they provide some templates, which is cool. Another thing that it's important about Atata, as I said, we use it as a NuGet package. They heavily use some generics. For example, this page object here. Let me zoom a little bit. For me, this is a little bit trickier. This type of syntax with generics and underscores, I don't get it. For me, it's a little bit harder than it should be. But another good thing about this framework is that it gives you different web components for the different elements, similar to 𝑣𝒏𝒕𝒐𝒏. Instead of having just like Selenite, they have Selenite element, like iWeb element in WebDriver. And usually I prefer this approach because it makes our test more readable later and gives just the specific properties or methods. For example, instead of having just a generic method like send keys, you have here a method set password, or here set text, etc. Or it doesn't make sense to click in the password, but instead you have just click for the button, right? Another thing is that this framework is using fluent interface. Again, it's a matter of choice. For me, it's a little bit more verbose and harder to use. Again, I'm not completely against fluent interface, but as you can see right here, just let me zoom out here. This is the fluent interface. This is just a single line, right? And you need to, using enter, you need to move it to the next line. You cannot use, for example, Visual Studio formatting feature. I don't know. It's a matter of choice. Many people prefer it. There are many popular assertion libraries that are using this syntax. It's fine. So little by little, you can go through the documentation and see all of the examples. This framework, it has a very nice documentation, which is very good, which is very rare for a framework. And it has a lot of demos and tutorials and blog posts, which is good. They have their own here syntax for assertions and aggregate assert, which is awesome. Again, it in some places it's a little bit more verbose and hard to understand how to use it. They have many examples and different packages for example, Kendo components, Bootstrap components, etc. I will skip 𝑣𝒏𝒕𝒐𝒏 as I said, but you can check it. There is a very nice documentation and examples. The second framework that I want to show you is Selenite. It's a framework in Java. No matter whether you pick, for example, another language besides Java, it's good to check, for example, C# and Java, maybe JavaScript. It depends whether you understand it. Here are some tutorials. You can use it as a Maven dependency and directly start using it. from the little time that I use it, it's much more lightweight. It's completely the opposite of a Tata. You use syntax similar to jQuery in JavaScript with this $sign to find the elements. And as you can see, you don't need this. You don't need every time to provide this by some locator, right? And you have these built-in weights, which is good, a good thing. They have some nice tutorials. My personal opinion is that their documentation is, as you can see, it's not so good as a Tata. It's not so detailed. They have, since this framework has been developed a long time ago, it's still maintained, and there are many examples and many articles, which is fine. But it lacks some features that more advanced frameworks have. Still, it has some examples again on GitHub as well. Also, they have, for example, a plugin for APM for mobile testing. I can say that it's a little bit more verbose how you can set it up instead of using configuration. Maybe they have, I don't know, but here in the example, from what I see, you need to define it as a regular RPM test. So I'm not sure the complete benefit of the framework. Maybe you can still use, as you can see, this $sign, etc., and the tapping and everything. It's not my thing, but many people prefer this framework because it's lightweight, which is good. And lastly, the Shaft framework. Again, it's maybe not really my thing, but it supports both not only web but also mobile and desktop. So here is the syntax. This is regular WebDriver code, and here is the Shaft code. There are some additional methods, a different syntax. It's a mix between Fluent and a regular code. I don't know. When I check it, I don't see the benefit. For me, it's messy. It's long. You need to define here the as private fields the locators and then paste them inside the action types, which makes the writing of the test more complex for me and more verbose. Again, there are many examples here in their GitHub repo. Again, I don't see much benefit of having such a syntax, but still, I haven't used it really in many projects. I just checked the documentation. Again, it's a matter of preference, I guess. All right, you saw my, explanations when I was doing this type of research. Of course, you need to do it more truly and pick more solutions, right? And as I said, during this implementing proof of concept, it's important to form a working group. It will be best if it's built from technical experts like test automation engineers, maybe seniors, but not only, because juniors will need to write tests as well. You need to implement 2-3 tests for each solution. Maybe everyone from this group by themselves needs to write these 2-3 tests to feel how to work with the framework. After that, the step 5 is to rate based on the assessment criteria, to provide a rating for each of the assessment criteria that we defined at the beginning. You can further extend the rating phase by prioritizing the different criteria and provide weight index for them. So put rating between 1 and 5. 5 is the highest score, and if there is a weight index, you will need to multiply it by it. For example, 1.5 for good documentation. This means that if I put a rating 4 here, and if I have a weight index of 1.5, I will multiply 1.5 by 4, which will make the actual rating 6. That's it. And everyone from this working group will need to create such a table. And we'll need to create an average. After that, during the phase 6, each person from the working group, again, should provide their ratings based on the proof of concept. Then you can also put the weight index, again, based on the participant seniority, authority, or role. In the example on the first row here, participant 1 is the QA lead, which is why we multiply all scores by 4. And here you can accept that participant 2 is like a principal, right? And this is why we multiply by 2. And then you have your average from all participants for all of the frameworks. After that, the phase 7 is to create a high-level test automation strategy if you don't have one already. We need to have a list of test cases, no matter whether they're detailed or abstract, that we'll need to automate. Then we need to have priorities and categories by them, and so we need to put these test cases in 3 phases. Maybe we'll start with the phase 1, which are the highest priority. At least this is my way. And then, based on the test cases that we need to automate, we can update our test automation requirements, right? That we defined before. This is why I included this phase here. And then we need to provide estimates for phase 1 test cases. Why this is important? It's important because if you decide to create your own framework, sometimes it can take months to develop it, depending on how much people were involved in this effort and about their skills, right? And if it's very important for the company to have this regression test in, 4 months, and if you need 3 months to develop the framework, then the choice is obvious that probably you will need to use an existing test automation solution. But again, it will depend on your particular context. And again, for all of the requirements, maybe you don't need to develop all of the features at once, but maybe you can do them in stages. Now, the final decision, existing solution or not. You will need to answer some of the questions, like how much time you will need to implement and even create the customizations, even if you pick an existing solution. How much it will cost to maintain and support it later. Do you have an easy way to learn it? Are there any trainings, etc.? Or if you make the final decision to develop your own framework, what are the estimated development costs and time? For example, if you need 3 months QA architect time, this means that the cost is you need to multiply its salary by 3 to find the real cost, compared to, for example, paying just the licensing cost for something, even if you pick a paid solution. But this is just the upfront cost. What resources are needed upfront? Do we have the necessary expertise and skilled personnel? Maybe if you don't have an architect or senior people, maybe it's not a good thing to develop your own framework because maybe you won't be able to do it. Is it adequate training and support available for the team if we want to upskill the team so that they are capable of writing a framework? What are the long-term support and maintenance costs? For example, if you need your architect, if it needs 1 week per month, then again, you know the cost. Can the team handle ongoing updates and scalability issues? How well will it integrate within your current technology stack and continuous integration, continuous development tools? Can we ensure the required performance and scalability? Can we provide comprehensive documentation and user support? Will the framework be actively maintained and updated? Can it adapt to future technology changes? So many questions, right? But again, let's assume that based on your initial research and requirements, let's decide that we're going to create our own framework. I'm going to teach you how to do that. So we need a high-level development plan, right? So based on everything that we discussed right now, let's use .NET as the primary framework. We're going to use C#. Probably if you're a fan of Lambda tests, you already watched some of my videos about design patterns, part of the Lambda Test YouTube channel. I will include a link below. So we're going to implement some design patterns for maintainability. We're going to use WebDriver, APM for mobile, and REST for the API. We're going to support both MS-DES and NUnit, no matter that I'm more of a NUnit fan, because it will depend on the different teams in your company which of these unit testing frameworks they will want to use. And then again, we will need to decide how to use the framework. As I said, I'm going to teach you how to use the framework, not as NuGet packages, but this more maintainable way as a Git submodule. After that, we'll create separate projects. This will we'll start in the next module with creating a project for web. Then we'll proceed with mobile and API. We'll create a project for shared core logic. We'll create a dedicated project for our tests. And we'll have one more project for all of the different integrations, like integrating with Lambda tests, Mailswap, Twilio, and other third-party services. So, in this first module, we started with pinpointing precisely what we aim to achieve with our framework, exploring open source tools for inspiration, created a list of requirements and criteria to evaluate different solutions. We discussed the different phases for this process of evaluation and research, asked some questions to finally decide whether we want to use an existing test automation framework or create our own. The decision was to create our own framework, so we ended up with a high-level development plan that we'll use in the next modules to build our own test automation framework, step by step. And in the next module from the series, we will continue with the first brick from our future framework, creating our web core project. Hi guys, greetings from Bulgaria. I'm Anton, and this will be our second module out of the course about building advanced test automation frameworks. And we're going to discuss how to build our core components for the web part. Before that, please subscribe to the channel if you haven't done so. Each week are published many new awesome videos and you will be notified. Also, don't forget to check the awesome Lambda test blog, where there are many edited out articles that can help you to be a much better test automation engineer. I'm not going to spend much time again discussing the course overview. We already looked into this overview in the first module where we defined the scope and the requirements about our framework. We did like a research and also we used an assessment system for deciding what are our requirements, what features do we want, and evaluating between and choosing between different frameworks, or ask some questions whether we want to create our custom framework. And after this evaluation, we decided that we want to create a new framework, and I'm going to teach you how to do so. So we're going to start doing that now. First, we're going to create the framework structure. Then we're going to implement many of the test automation framework components. And of course, we're going to use many of the design patterns that we previously discussed during another Lambda test course about design patterns. If you haven't watched it, I suggest to do so. You're going to find all the relevant resources and links to the playlist in the links below. And also, you're going to find the link to the GitHub repo with the source code. What else? I suggest to clone the repo and in this particular video, I'm going to, you will need to switch to the correct branch about this video. And I suggest to play along. And if it's too fast for you, you can slow down a little bit the speed of the video or increase the speed. But I suggest to check the code along with the video and my explanations. In this particular video, we have a lot of code to cover, and this is why I won't spend much time typing the code, right? So let's begin with creating all the framework infrastructure. I always, before typing the code and writing something, I'm a little bit old school, and I always open Notepad and create something that I call development plan. It's always best before directly writing the code to take a pen and write down or use Notepad. So here for us, I created a short plan how to create this web project in the framework. Again, the big difference between a library and a framework for me is that the framework is combining many libraries, but on top of that we can extend it and customize it, and this will be one of our primary goals when we design the framework. On top of the readability, the stability of the tests, API usability, and how easy it is for you to figure out how to use it. So in this particular module, we are going to create the initial projects for the framework. And these initial projects will be the Polaris White. This will be the name of the framework. You can pick whatever name you want, but this is the name I liked and I picked. So these core projects will have and contain all of the base classes that we need, all of the plugin infrastructure. Later in the next module, we're going to build that. And the core project that we're going to develop now is this polariswhite.web. And to ease our work now, I will put the test that we're going to develop using the framework directly in this project, in this solution. However, keep in mind that in the last module, I'm going to show you how really you should use the framework. We are going to use it as Git submodule, and your test usually will be outside of the original framework repository. So we're going to install some NuGet packages. I'm going to reuse some of the tests that I developed during the series about design patterns so that we don't lose time. Initially, they won't use any framework or design patterns and or just page objects, and later we are going to refactor them to use our framework for web development, web test automation. Then we're going to use the adapter pattern that we use quite extensively in during the design patterns course. If you haven't watched the video about proxy and adapter, you will find the links below. Probably I won't spend so much time to explain it again, but again, I will give you a quick overview. So we are going to use adapters. Also, we are going to use the strategy design pattern to develop this kind of reusability of our components and allow the users, the clients of our framework, to be able to create new locators and weight strategies. Something new that we're going to develop are new web components. Instead of having only one adapter for wrapping iWeb element, we will have separate components for example, for the text field, for the button, for the anchor. You're going to see it in a minute how this works. Also, we'll bring something more and implementing lazy loading. Instead of finding immediately the element in the moment when you create an instance of these adapters components, instead of doing that, in order to make our test more stable, we're going to trigger this process at the moment when you perform the first action with the component. For example, at the moment when you type text or click a button. And we're going to add more new stuff like these dynamic validations. Instead of doing immediate assertion, for example, checking a particular label or the total of the website, we are going to bring this, I call this validation, which means dynamic assertions that we're going to wait for the particular condition to happen. For example, the price to be updated or to be calculated the right way. This will bring much more stability to our test as well. And in case of any problem, there will be much better exception message. So we're going to refactor the test later using the patch objects, and of course see our new part of the framework in action, refactoring the existing tests. And later during the next module, we're going to upgrade that using the plugin architecture based on the observer design pattern. It will be quite exciting. So let's get started. First, we need to create the projects. I already did so. So here it is. We have one solution that I named again Polaris-wide test framework. And I created for now these three projects: Polaris-wide web, that will contain all the components for the web, the core, and the demo system tests. Now, I suggest to use this new project functionality in Visual Studio. For now, our framework will be able to support both MS Test and NUnit. However, I suggest for you to pick NUnit, and we can pick directly here from the templates pre-configured project that will come with all of the required NuGet packages installed. You can do this by yourself when you click on dependencies, manage NuGet packages, and click browse and search for them, or when you double click on the project, the MS build definition will be open. This is the language for defining projects in .NET. So in this MS build, as you can see, we have this node. It's XML-like language. We have this package reference. Basically, here is the name of the NuGet package and the version. As you can see, we have all the required NUnit NuGet packages and this Microsoft.NET SDK. That's it, what you need here in the Polaris core. For the Polaris web, the main thing is that you need, of course, Selenium WebDriver that we are going to use, and also you need to add a reference to the Polaris-wide core project. Again, in this Polaris-wide project, little by little, we are going to add the different infrastructures like base classes for NUnit, also plugin architecture that we are going to develop next time. For now, we'll keep it a little bit more simpler without the plugin architecture. And for our demo system test, again, it's a regular NUnit project that has a reference to the Polaris-wide web project. That's it. Nothing more special. Regarding the tests, this is our next part from our development plan. So we have the NuGet packages, we have the projects, and I copied the existing Selenium tests. Let me quickly explain. I created a namespace called noFramework. Also, when something I forget, again, I suggest you to clone this repository that you will find in the links below, Polaris-wide repo, and clone and trigger this branch build core components for web. And yeah, so under this namespace, noFramework web models pages, we have regular iWebDriver, regular Selenium tests that are using this e-commerce playground website, 𝐓𝐴MDA_test. Again, we have automated that many times during some of the other videos that probably you have watched. So in one of the tests, we are comparing different products. Going to this particular screen, asserting all the information, that's it. And then the second test is to add two products, increase the quantity, go to the cart, increase the quantity here, verify some totals, going to the checkout, filling the information, verifying some prices here again, and completing the purchase, that's it. Here, of course, I use page objects. As you know, the page objects, they're basically wrapping what's going on each page. So we use properties for the web elements. In places we use WebDriver wait for waiting particular elements to exist on the page or the elements to exist. Nothing really fancy, and we have some actions that we can perform on the page. For example, the checkout. As you can see, we have tons of inputs here. We can fill the user information, we can fill the billing information, and we can have sometimes some assertions. We have one class that I call website or app. It depends on the term that you want to use. That basically have a reference to all of the pages that we don't need to initialize them in every test class. So we initialize the driver in the setup, and after that we use the page object. That's it. So later we are going to refactor them. I already did that, but I'm going to show you in a minute how this works. And you're going to find the refactored version under this folder framework, under this namespace. Now, before we look into the refactored version, you will notice in my code that I prefer to use global usings instead of, making up my files very long. So I prefer to put all the usings here. So you will find these global usings files in all of the projects. All right. What's next? Let's open the development plan again. We need to create WebDriver adapters again. Let me open our presentation. Here I copied the diagram from the adapter design pattern presentation. Here we use, in many of the patterns, we use the composition principle. Let me quickly refresh your memory about the composition principle. This is a principle where classes should achieve polymorphic behavior and code reuse by their composition, by containing instances of other classes that implement the desired functionality, rather than inheritance from a base or parent class. And this is especially important in programming languages like C# or Java, where multiple class inheritance is not allowed. In this adapter design pattern, it helps us to eliminate the usage of hard-coded pauses in automated tests, and instead it will allow us to automatically wait for elements to appear, and moreover it will help us to improve the API usability of our tests. It will help us to adapt the iWebDriver interface here. It will help us to add new methods or change their signature, and especially for the components, since this video is about the web core components. We're going to create many of these web components because we're going to split them. Each of them will have totally new methods. Like, for example, not all of the components will be able, you won't be able to click them or send keys, but instead you will have type text, set date, set value, set attribute, and many more methods, right? So the adapter, it adapts a particular interface, right? You change the signature, add new methods, and this is why we have this new interfaces. They're called they're usually in the pattern they're called target. This is the iDriver that, as you'll see in a minute, I have split it into multiple interfaces like the original architecture of Selenium WebDriver. And then they will define that these domain-specific interfaces for client use. And then we have the adapters that we are going to see in a minute how they work. They adapt the interface of the adaptee. In this case, this will be iWebDriver and the iWeb element. And they will adapt our new this adaptee to the target interface. And basically that's it. And also we're going to use strategy. The strategy, this is very popular pattern. Usually it enables to change algorithm's behavior or behavior of something, and we can change this behavior at runtime. Or this means when we write the test, you can change it instead of, every time provide and hard code that to our framework. We will be able to create different strategies for finding elements or waiting for them, and later we'll be able to add new logic to our framework. So let's return to our code. For now, I will close the tests and stick to the folder structure of our web project. First, we have a folder or a namespace for the assertions where we're going to put these validated assertions that we're going to discuss at the end of the module. Then we have the components that we'll spend much time now in this module. These are, these are like anchors, buttons, checkboxes, date, diffs, emails. Later we'll add much more complex. There is a separate module where I'm going to teach you how to create complex such components that rely heavily on JavaScript, like for example working with editors like Word. Then we have the core folder where we'll have our driver factory that we're going to discuss in a minute. We have defined strategies that we're going to discuss. This is the different locators instead of having this by locator. We have page objects, pages, you know what this is. Plugins that we are going to develop next time. Services where we have all of the adapters that are adapting the iWebDriver interface, and we're going to discuss this now. And the weights that are using weight strategies. So, what is a driver adapter? The driver adapter, as we discussed, is based on this iDriver interface. As you can see, this iDriver interface, it derives from multiple other interfaces. I splitted them to make our work easier. So we have the iBrowser service, and it gives you methods for controlling the browser. We have back, forward, refresh, something from the original buttons of the browser, right? But we have one more method, wait for Ajax. As you know, Ajax is responsible for asynchronous JavaScript requests that refresh just parts of the page instead of reloading the whole page. We're going to use this many often. This is why this is new method that it's not part of WebDriver, but we use internally JavaScript. We have an interface for the cookies. We have an interface for finding our new components. We'll spend much more time on that. We'll return to this later. We have interaction service, which is about performing more complex actions like drag and drop, double click, click and hold. It's based on the actions API of Selenium. We have the JavaScript executor and the navigation service that's responsible for going to a URL and exposing the URL property. Now, the adapter, as I said, is responsible for adapting the original interface iWebDriver to the new interfaces. And in order to do that, instead of having one really huge file or a class, I use the C# functionality for partial classes. What is the partial class? The partial class helps us to split a class definition to a few files. So here, all of these files are actually a single class called driver adapter. If I open the this driver adapter.browser, it's actually the same driver adapter class, as you can see here. But everywhere we have this partial keyword. So I split it. Every file is implementing a different interface. But when you compile, all these files will be compiled into the driver adapter class. But this helps us to, to ease our work to find what we need. For example, I know that when I click to the cookies file, that everything about cookies will be here. I always prefer to split my files like that, even page objects. So this driver adapter without any suffix here, it just contains all the definitions in the constructor. It basically wraps the WebDriver await the actions. And in a minute, we're going to discuss this list with wait strategies. We're going to use them for some internal logic. And also, one very important class is this driver factory that later during the next module we're going to use in some of the plugins. But as you can guess from the name, this driver factory, it's placed here in the core folder. Usually we use factories to create objects. And this particular class is responsible for the initialization of our driver. For backward compatibility, I use, again, WebDriver Manager. However, you don't need to use it if you use Selenium version 4.11 or above. For backward compatibility, I use it. You will notice that this class uses heavily static. It basically has, for now, 2 static methods. In the next modules, we're going to upgrade it to contain logic, for example, to allow us to start our tests in the cloud, in the Lambda test cloud, or in the grid. Also, later we're going to upgrade it to allow us to run all of our tests in parallel. For now, it's just single-threaded, right? And we have here a single start method responsible for, this is called a factory method, right? And it's called start. This browser configuration, for now, it contains 2 important properties: browser and browser version. Later it will contain, and we're going to discuss in the next module, we'll have other stuff like lifecycle execution, which means whether we want to restart the browser, reuse it, or close it just on failure. And later we'll have different executions like grid execution, cloud execution, local execution. For now, we'll just initialize the browser type, which comes from this enumeration, which contains all the different browsers and browser version. And so based on this configuration, we have a switch, and in this switch, we're initializing the proper options. We set the browser version so that, again, if you use the built-in Selenium Manager, you don't need WebDriver Manager, you can delete that. And basically that's it. Later we are going to upgrade it. We are going to use bidirectional APIs, for example, to add some emulations here, to change the user agent, to emulate mobile, to, for example, use geolocation, and many other awesome stuff. And later, when we add different configuration files, we're going to, for example, use that for responsive testing. Many new additions will be added here. For now, it's very, very simple, just single method. and we have one dispose method for closing the browser. That's it. And later, if we want to access the driver, we're going to use it from here. So our driver adapter, this means when you initialize it using the new keyword, you're going directly to get the instance to the driver from this static wrapped property. And then we are initializing the WebDriver with the actions and everything else. So the rest of the classes here, they're basically more or less they're wrapping and exposing their wrapping and using this wrap driver. As you can see, this back method is just calling wrap driver, navigate back, forward, etc. However, here we added a new method, again using WebDriver wait and some JavaScript, waiting for all the requests to finish. Then for the cookies, we're doing the same thing. WebDriver manager cookies, deleting the cookies or adding new cookies. For the interactions, we expose it again. You're going to use it the same way while you use the actions class. For the JavaScript, it's a little bit more complex because we have now a generic method for using the components that we're going to discuss in a minute. But basically, again, behind the scenes, we are using the execute script. For the navigation, we just have for now URL and go to URL, nothing more fancy. And we can use later, in the next module, I'm going to show you how we can use extension methods to add new methods to the adapter and to add new find strategies and wait strategies. Now let's focus on, before we move to these find methods, because they're one of the core things that we're building our framework. Instead of having just why can this test without the framework, without every time using the find and then by. For me, this is a lot of typing, because imagine you have this locator. You need now to place the bracket. Next, you need to type by. Then you need to put a dot. Then you need to pick something. Then you need again to place brackets. Then you need to place two quotes, etc. It's a lot of typing, right? For me, it's much easier if we have methods like right now. I'm going to show you just the parts how we find elements with the refactor version with the framework. Now we have something similar to the website class that I showed you. I call this application. This application gives us access to all of these services or interfaces part of the adapter. And as you can see, this, when we initialize that, actually this is just initializing the driver adapter. But since it's split it into multiple interfaces, we have access just to the methods part of the browser, from the navigation to the cookies to the interactions. And instead of having this long name, I call this elements. This elements property is giving us access to all of the methods for locating elements. And the way this works is, again, as I told you, the components adapter is actually not a single class, but many different classes. In a minute, we're going to discuss the pros about this approach. It's a little bit more complex. We have more classes. However, we will have specific classes about each component and much more methods based on the attributes of the web element. But if we focus now on just locating the elements, for me this is much simpler. Just when I type find by, I have the IntelliSense and I have all of them. Before this was possible, for example with Appium, they removed that and they used this approach just internally. I understand all the approaches, they have pros and cons. For me, this is faster typing instead of, again, having this approach with the by class. And the limitation about the by class is that everything there is static, which means that you cannot extend it, you cannot add your custom methods. Here this is possible. So here we have less typing, and also we have lazy loading that we're going to find next. So let's discuss first these strategies and what they give us. Let's open the 𝐜𝐴Tors folder. So this 𝐜𝐴Tor folder, again, the strategy is based on a base class. This is the base class, the abstract class for all of the strategies. This is a very simple base class. It just contains an abstract method that it's converting the strategy and it's returning the native Selenium by, and we have the actual value, the actual ID, the actual XPath, etc. That's it. And then for each specific 𝐜𝐴Tor type, for example, if we want to locate something by ID, we need to use the ID find strategy. This ID find strategy, as you can see, we need to provide the actual value using the constructor, and then we implemented the abstract method by just calling by ID, providing the value. The same goes for XPath find strategy. The convert is just calling the native by XPath. However, it goes interesting when, for example, we have inner text containing. And as you can see here, this inner text containing is something that we don't have natively in WebDriver, which is fine. I mean, this is something that frameworks should have. They provided us just all of the core functionalities, and then later, using such libraries and frameworks, we can extend that, which is completely fine. This is not something like a cons of WebDriver by itself. So here I'm using this complex XPath by containing a text, and this is awesome because we're going to reuse it. We are not going to type it every time. The same goes for ID containing, but here this time I use a CSS selector for the ID containing. So these are the strategies. Later, when you use the framework as a user, you can add your own strategies, and next time we're going to do that. We're going to create such a strategy for example, finding elements using XPath access and finding an element by label. And I use this very, very often in enterprise projects. The same goes for weighting strategies that we are using inside our components. These weight strategies, we have this abstract base weight class. It just initializes some timeouts and sleep intervals and provide some core classes that internally they use WebDriver weight, nothing more. And every weight strategy, it needs to implement this wait until that accepts a find strategy. For example, we need to, for example, this to exist wait strategy, it will wait internally. It will wait internally for element to exist. Again, it's completely fine. You can use some of the expected conditions functions if you don't want to create your own. I created my own just for the sake of the example. And the same is valid for to be visible. Here we're checking displayed property and whether the element was found or not, etc, etc. And now we have if we check how this find service works. This find service, as you can see, all of these methods, they accept a new strategy, right? New find strategy, and we're providing the ID. And this will return a T component. This T component, or this generic parameter, means that we're going to change T component with some of these classes. button, anchor, checkbox, date, all of them, they derive from our base component. This is our base adapter. In a minute, we're going to see how this works. But yeah, this web component, it's similar to our driver adapter. I just, on purpose, I didn't use the word adapter, but if you prefer the word adapter, it's fine. But this web component, this is the base class for all of the other web components. For the buttons, for the checkboxes, basically this is the class that contains, this is the one of the main additions. All of our web components now, they wrap the iWeb element. We use here composition. So it consists, we're wrapping the iWeb element. Now we know how our iWeb element was found. And also we are going to add lazy loading, which means that we're not going to immediately find the component, but later. We're going internally to wait using the wait strategies for the element to be found or to exist or to be clickable. And we're going to add new elements there. In order to achieve that, again, we're going to return to this method. It's called find component. All of the rest of the methods are calling this find component. You will notice that it accepts a find strategy, is generic, means that we're going to create any of these classes here, because all of them derive from web component and also they have an empty constructor. So we're creating an instance of them. We're not, as you can see, we're not triggering the native finding. We're not calling driver.findElement and converting. We're just creating an instance of the class. And we're just initializing the find strategy. We're initializing the wrap driver and we're returning it, which means that every time here, when you create an instance, this will create an instance of your text field, but we are not going to immediately find anything. We're just creating an instance of this div, date, etc. And the moment when we're going to trigger the finding and everything is much closer to the actual action. For example, when you perform the type text here, this is our text field component. This text, as you can see, this type text, it's calling the base text type text. And as you can see, the type text is similar to what we did with the wrap driver. It's calling our wrap element. This wrap element, as you can see, is returning our native iWeb element. And if we open that, you will see that now the empty constructor is just initializing the list with wait strategies. We have some interactions in JavaScript service. Internally, we're using the driver adapter. That's it. But the whole magic is happening inside this property, the wrapped element. We're checking, is our wrapped web element? No. By default is no, because we just created an empty instance, that's it. But the first time when we want to execute an action, for example, performing a clear or send keys or clicking in, we're going to check, is it no? Yes. Then we're going to trigger now the lazy loading and find the element, and we'll provide the find strategy that we assigned. And as you can see here, next, another important thing for our web component adapter is happening for our web components. The stability of the framework is very essential. As I said, we're using the adapter mainly. One of the core reasons is to perform these waits internally, no matter whether this is just to exist or to be clickable or to be interactable, many different things. But we're going to check our list with wait strategies. Do we contain a wait strategy? If we don't, then every time we're going to at least perform one strategy, and this will be our to exist strategy. This means that every time we'll at least check whether this particular element is visible, exists on the page or not. So we're going to for each this list, and as you can see, we're going to call the wait until method for this particular strategy. As we discussed, this method this abstract method that comes from the base class for all weight strategies is implemented in all of them separately. This means that to be visible weight strategy, it will call in this wait until method, this method, element is visible, and we're going to check the display property. For the clickable, we have other logic. For example, we will check that whether the element is enabled or not, etc., etc. So our job first will be to execute all of the wait strategies. Just after that, we are going to perform this find native element method. And it's a very simple method. As you know, in WebDriver, we have two ways to find an element. We can search for it inside the whole browser. This means that we are going to trigger and execute the find element of the wrap driver. Or if we set a parent wrapped element, this means that you can, for example, search inside the div or inside the whole table. Then we're going to search inside the other element. That's it. And because all of these native methods, they require the native by, we execute the convert method that will basically convert the find strategy to original by. And that's it. We're going to initialize now the wrapped element, and afterwards, every time when you call the wrapped element property, we're going to return the already found original native iWeb element. And another interesting part is actually how we initialize. This is part of the API usability and from what the framework is actually giving you. Check it out, it's very awesome. As I said, by default, we are always checking internally. Even if you don't type anything, we're going to wait for an element to exist, because we add, if the wait for strategy is empty, we're going to wait for the element to exist. And now look, this is how we search for the element. app.elements.find. Here we provide as a generic the type of the element, text field, select, etc. And afterwards, you'll see that we have a fluent interface. And here I can say to be clickable, but this means that this to be clickable, in a minute you're going to see how this works, but it will add, this to be clickable will add a new strategy to our wait list. However, since it's using a fluent interface, I can add one more to exist. Then I can add one more to be visible. And not just that, I can even provide some timeouts here. This means that as you can see, there is an overload. There are two overloads. I mean, one of them is accepting the timeouts by default, but also I can, for certain cases where I don't need to wait, for example, for 60 seconds or to do it faster, I can adapt that. And the way this works, I have here another class called Web Component Extensions. As you can see, this is a static class called Web Component Extensions. And all those classes to exist, to be visible, etc., they're generic methods, and they're extending T-component. This base T-component, as you can see, this type is actually, I'm extracting my framework that this T-component derives from web component. This means that this method is extension method for all of these types, because all of them, they have for a base class the web component. Then we're just creating a new wait strategy, and then we're calling this method ensure state. What is this ensure state? It comes from my base web component class. It's just a single public method of our base web element adapter that is just adding a wait strategy to the list with wait strategies. That's it. And later, since we use that inside our wrapped element property, we're going to trigger that, and this will be executed inside the for each loop that we do here, right here, right? When we find the elements. Besides that, nothing really special in the base class for the web components. Everything else is just, again, when you hover, we're using the interaction service to perform that, to move to the element. When you, for example, have enabled in displayed, we're just calling the wrapped element and nothing more. I added some new methods. This is why we need the adapter. As I said, we're creating a new interface. We're adapting and adding something new or changing the signature. web element of Selenium doesn't provide a method for setting attributes. However, this is really important for us, especially if we want to automate HTML5 components that I'm going to show you in a minute. And here I use some JavaScript for that. And we're using, actually we can use directly the JavaScript service here, etc. Another important thing, since I don't want, as I said, all of my components to be, to allow you to click them. For example, it doesn't make sense for you to click, I don't know, a date. Maybe you can set the date, but it doesn't make to click it, or it doesn't make sense to click on a text box. You're going just to call a type text, which by default maybe it will click inside it, but you don't need the click by itself. Or it doesn't make, for me, for example, if you have a div or a span, it doesn't make sense to click them. Instead, you're going to use the button. And this is why, as you can see, we define these methods. We have a definition for them inside the base class, but they are protected. These methods are protected. This means that when you use the button, by default, you don't have access to this. You need to expose it. And this is why, if I want to implement my component, web component to implement, and allow the users to click, we need to use the new keyword now and call the base definition of them. There are different ways to achieve that. I prefer, in order to achieve some code reuse, to have some definitions inside my base adapter. So I use quite extensively this approach with the new keyword. In order to distinguish and decide which components to create here and what methods do you need to add. For example, this date component is very interesting. It's, let me show you the way how I decided what classes to create here, what classes for the web components. I opened this website. Occasionally, if you are a fan of my videos, probably you watch some of them on the 𝐓𝐴 YouTube channel. In a few of these modules, I mentioned this website. I really like it. MGN Web Docs. This is a website for the developers from Mozilla, the developers of Firefox. And this is like a full documentation of JavaScript and HTML. And here we have very detailed information about this input type date. This is this sort of web component. It's HTML5. And by default, if you use send keys, probably it won't work. And also, you need to make sure to format really carefully the date here as a string. And also, for each of these components, we have different additional attributes. The attribute is, for example, the value is attribute, the min is attribute. But these attributes, they're totally different. We have some global attributes that are, shared among all the HTML elements. However, there are some attributes that are valid only for inputs or just for particular type of controls. For example, here we have min, step, placeholder, and others. This is something I think that we need to assert in some cases. For example, there might be a requirement that from usability perspective that a particular component should allow autocomplete, or whether it's read-only, or whether it's required. And instead of every time parsing and calling get attribute and providing the strings, etc. in all of the components, I believe that our adapters, our components, should expose that by default. And this is what I added here. You will notice also that in this web component, I used quite extensively the keyword virtual. And this is a specific for C#. In Java, all of the methods in the class are virtual by default. You don't need to use this virtual keyword. This means that in child classes of this class, you can override them. However, here this is not possible if you do not declare that this is possible. This is why I want my clients to be able, the users of my framework, I want for them to allow them, if they need to change how this behaves, how this works, for example, how the click is working or how we get the value of this is read only, they can just create a child class of this date and they can override it. That's why we use quite extensively here virtual. Also, one more thing, that it's really the power of this adapter design pattern and especially what we did here. Again, instead of having send keys, here this is especially important for the date because this won't work here or it will work strangely. Here I changed totally the signature of this. I changed the name. We have now setDate method. Then instead of providing just a single string, now we have 3 parameters here to ease your job. We need to provide all of the data here as integers, and we're providing them, we're formatting them later as strings using string interpolation, the right format that the controls accepts. And then this new method part of our web component, we use JavaScript to set the value attribute. This is how this component is working. Awesome, right? And I did the same thing for the text field. As you can see here, we have autocomplete, read only, required, and later we can assert them. So we're going, and for example here, we have this type text, but again, it doesn't make sense to allow you to have a send keys, for example, for the div. This is why the div doesn't contain anything. You can just get the text and the inner HTML. But the text field, instead of having just send keys, and be sure that you clear everything inside this input. Instead of that, you have type text, and then we are calling the base method here, which is protected, and as you can see, we are reusing that. Even here, we can always, for example, execute the to be clickable weight strategy. That's fine. You can do that here. One more thing that we haven't discussed yet before we wrap up this video is about this last part of our development plan. We implemented the lazy loading already. We haven't discussed the validations. What are these validations? Well, as I said, if you look into checkout here, imagine that we are increasing the quantity and we update that. As you can see, the quantity can be, it depends on the website. As you can see, it was updated without refreshing the whole page. This was done using AJAX requests. This means that we can use the new wait for AJAX method. However, here, if you use a regular assert, sometimes if you don't use WebDriver wait, and depending on when you found this particular label, maybe it will contain the old value. It won't be refreshed. And it really depends what you want to verify, whether something exists or not, or whether, for example, if I click here, continue, maybe you want to check whether these messages appeared or whether they are visible. So I want, instead of using assertions, here in the checkouts, I developed another functionality, which, as I said, instead of using this regular approach for that, and for me, this approach of using asserts that something, then comma is dot equal something, this is very hard to type and it's time consuming. Instead of doing that, I have a new functionality added called validate. As you can see, for each component here, for example, this is my this is a text field. Actually, this is a label. For the label, as you can see, we can just check whether it's visible and what is the inner text. And this is just in TestSense now in Visual Studio. This validate will wait internally for the price to be changed to this. It will wait for 30 seconds. But it's more than that. Every component knows and can verify only the attributes that it contains. For example, the button will be able to verify whether it's visible, we'll be able to check the value and whether it's disabled. Let's see, let's find the button, for example, continue button. If we have the continue button, you'll see that we can check the value and whether it's visible. If we check, for example, the checkbox, we can check whether it's checked. But you know, you saw that for a regular button, we don't have this method. But if we see the definition of the checkbox, you will see that we don't have such methods here. How this works? Well, we have the magic of these interfaces here. We use them for two things. First, we use them to implement the adapter design pattern, similarly to what we did with the contracts for the driver adapter. They're very simple. They're part of this folder. For example, we have iComponent checked, whether something is checked or not. We have iComponent click that defines that my component should be clickable. We have is disabled, whether we have text, whether we have autocomplete, etc. So we use them like a Lego. For example, the checkbox, we implemented iComponent value, iComponent disabled, and iComponent checked. And after that, under the assertions folder that I told you about previously, we have these validate component extensions. We implemented extension methods, but we are not extending the actual components, but we are extending specific interfaces that my components are implementing. As you can see, we accept T, but this time T is just the components or the types that are implementing a specific interface. This means that this method won't be visible for components that, or maybe this method won't be shown for components that are not implementing iComponent value, because we have such. For example, div doesn't contain a value, and this means that this won't be available for the divs or for the spans. And the way this works is that we have this base wait until. This is just a method, a static method here at the bottom, where we are just using WebDriver wait to wait for a particular condition. If the condition timeouts, then we are throwing a specific exception with the specific exception message that we provided here. This is another benefit of using this validate method. So we are providing a very detailed message of what happened. The component should be not checked, but it was. And even we can provide a URL. This is actually something that I'm doing here. So I'm saying this component should not be checked, and the test failed on this particular URL, which is quite awesome, right? And again, we're using lambda expressions to provide, this accepts a function of bool, which means this is anonymous function that is returning a boolean or a simple boolean condition. In this case, we are checking whether the component value contains something. That's it. And then we use string interpolation to format the exception message. And as I said, we have, and right here, by default, we're using the default timeouts, but if you prefer, in particular cases, you can even set your own custom timeouts, which is quite awesome. If we look into the refactored framework tests, where basically they're looking quite identical to what we had before. Actually, this is the no framework, and right here we use our app to create some page objects. Again, we have similar base classes. And maybe the biggest change again is that right now we are using here the driver factory. This is important. We need to use the driver factory to start the browser, and then we need to dispose it at the end. After that, everything works like a charm. We're using the framework, and in the next module we're going to extend that. We're going to create some plugin architecture here, and we're going to add new plugins for controlling the browser. Instead of repeating that every time, we'll be able to switch between the browsers. We will be able to control the life cycle of the browser. For example, reuse the browser every time or restart it just on failure. Also later, we'll be able to execute it in the cloud, or for example, mark whether a test is passing in Lambda test or a failure. We're able to highlight elements and much more. All right, you saw the refactor version. We're going to work on that much more later. Again, in this particular video, we saw how we can implement and combine together the adapter, the strategy design pattern, the factory pattern, also page objects and app design pattern. Again, in the next video, we're going to work on this plugin architecture for building customizations for our framework, allow you to bring much more extensibility. Again, the big difference between a library and a framework is this particular feature for extending the framework and customize it for your particular needs. So we're going to proceed with that next time. And also I'm going to show you how we can create and extend various points of our framework. Hi guys, greetings from Bulgaria. I'm Anton, and this is the third video out of our Advanced Test Automation Framework course. We're going to discuss plugin architecture and customizations. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when there are new videos. Also check the awesome Lambda test blog, because each week there are tons of new articles that can help you to become much better test automation engineer. In the links below, you will find everything that you need, the links to the GitHub repos with all of the codes that I'm going to present. Also, you will find the reference articles part of the Lambda test blog. I suggest to clone the repo with the code and check the code while watching the video. Also, you will find in the links some links to parts of the video. If you know something, you can skip it, or you can increase or decrease the speed of the video. So let's get started. Here is our course overview. I won't spend time again to discuss it, but I suggest to check all of the videos sequentially because they are interconnected. First, we defined the scope and the requirements, and then in the second module, we started to implement those requirements, building all of the web core components. And now we are going to upgrade that, bringing this plugin architecture using some advanced design patterns. I'm going to use some design patterns that we already covered in another course called Design Patterns in Test Automation. You will find links to it below. Of course, I'm going to refresh your memory and explain everything that you need to know. So in this particular module, first we're going to cover this plugin architecture, and in many details we're going to see how to implement the observer design pattern, and we're going to extend NUnit, and after that some of the web component adapters, so that we can, for example, highlight some of the elements while the test is playing. Also, we will scroll down to particular elements, and this will be incorporated in another new project that will be called Polaris Customizations. And a big part of this module is this plugin customization architecture is really important. This will upgrade our test automation library to a framework. The big difference is that frameworks give you the possibility to customize them and upgrade them, which is not always possible for many of the libraries. Also, I told you about it in the previous two modules. that the suggested approach of using the 𝑨𝒏𝒕𝒐𝒏 and distributed it across your teams or users, if it's open source, is to use GitHub Git submodules. So we're going to start with that. I'm going to present to you a new repo where I implemented that. So then we'll proceed with discussing the observer pattern. We're going to implement a few plugins. First, for upgrading NUnit, where we're going to control the browser locally using attributes like, for example, changing the browser, changing whether we want to reuse the browser or restart it every time or just on a failure. And then I'm going to explain and show you some other customizations that I created in this new project. So let's get started and let's begin with this Git submodule architecture. So before we begin, again, I suggest to clone the repo. It's called 𝒏𝒐𝒏 and as I explained last time, for each particular module out of the course, I created additional branch. So right now, for this particular module, you need to switch to this branch, plugin architecture and customizations here. And you will see the current version before we upgraded it later. And now the new repo that I created, it's called 𝒏𝒐𝒏 system tests. Imagine that you have two teams. One of the teams is responsible for developing the framework. Many often this is the quality engineering team inside your organization and maybe the core role of the QA architect. And then this framework should be used inside other teams like, I don't know, CRM or support system team or shopping cart team, etc. And all those teams, probably they will have different repositories with different tests. It really depends how big your organization is, or whether the framework is open source or not. So inside this repo, here there will be two projects. One of them will be my tests, and then we'll have another folder for customizations. Anything from custom web components, new 𝐜𝐞𝐟𝐢𝐬, weight strategies, extensions to the driver adapters, we'll discuss all of them, or different new plugins. And as you can see here, with this specific icon, this marks that I used the other repo here where my framework is as a Git submodule. And let's find Git modules here, this documentation. You can check it out. This is the original documentation of GitHub. So a Git submodule is a mechanism that allows you to incorporate and manage one or more GitHub Git repositories within another Git repository. And this is particularly useful for including external projects or libraries in your main project, while keeping them as separate repositories. This is our main goal. This will ease the update later of the framework. You can pick another version, etc. And of course, we'll have different branches and history and everything in different rules, maybe for pull requests. So yeah, while keeping them as separate repositories, each submodule maintains its own commit history. It can be developed independently, making it easier to manage complex projects within multiple dependencies. Each submodule is a separate Git repository with its own history and branches. The main repository tracks specific commits of the submodule, ensuring that it always points to a known state. Again, if we create another release of the framework and if we use Git tags, this is the way how we develop, for example, my own 𝑨𝒏𝒕𝒐𝒏 framework, developed by 𝐓𝐡𝐢𝐬. So later, inside of our clients, they can decide which version of the framework they want to use as a submodule, right? And this is exactly what we are going to do. So I already initialized the project and I cloned it. So this is here, I cloned this 𝒏𝒐𝒏 𝑨𝒏𝒕𝒐𝒏 system tests, right? And as you can see, we have two projects. I copied the project with our tests here, demo system tests, and I created one more project called 𝑣𝒏𝒕𝒐𝒏 which is not part of the original framework, right? And inside this folder framework here are basically the projects that are part of my original framework that I'm going to use as a submodule. Here it is. This is the folder. This is the folder of this 𝒏𝒕𝒐𝒏 system tests. And here I added this 𝒏𝒕𝒐𝒏 test framework as a submodule. At the moment when you add it as a submodule, it will just clone the repo. Of course, you can add it to another folder. This is not a problem. I opened the command prompt here inside this folder, and I want to show you the exact command how to do that, how to add it as a submodule. Use the git submodule add command to add the submodule. You need the URL, like I copied it here, of the repository you want to add, and the path where you want to place it within your main repository. Right now, I don't provide the path because I want it to be placed inside the main folder. I already did that. After that, after adding the submodule, you need to initialize and fetch its data. And you can do that with git submodule update init recursive. This will initialize and fetch its data. After that, it depends which version you want. There are different commands, but basically, I switch it to this particular, I switch the submodule or the Polaris framework to this particular branch. So you need to check out the particular branch that you want to use inside your project. After that, it's easy. If you use Visual Studio, it's relatively easy. Here, as you can see, we have multiple repositories at the bottom. Let me show you. Right here, you have icons. You have two repositories and multiple branches, and you can switch them. For example, when I click here, you can see that I see now that I have two. I have branches for 𝒏𝒕𝒐𝒏 framework, and I can switch the branch for the current repo, which is 𝒏𝒕𝒐𝒏 test framework system tests. And the usual approach is that when you want to, this will ease the debugging inside the framework if you want to add new features or to fix something. But also, and this is how we actually configured our 𝒏𝒕𝒐𝒏 framework, we have specific rules for making PRs. This means that you cannot just, place a commit inside the original framework, but instead you need to create a branch, then you need to create a PR, then someone needs to review it from the core maintenance, and then they need to merge it if everything is fine. But again, you are not obligated to create any PRs. You can just use the framework as it is. And the whole point of talking about plugin architecture and customizations is exactly about creating all of these additional functionalities without modifying the original framework code. So let's discuss that now. Let's discuss this plugin architecture. Again, we're going to base it on a pattern called observer design pattern. And this pattern is quite popular in this type of loosely coupled architectures. And I'm going to present to you a version of it that you can implement in any popular programming language, object-oriented programming language. At least in C#, there are maybe at least 3 versions of it, how you can implement it easily. There are some built-in capabilities within the language, some interfaces and special classes. You can find an article of mine on Automate the Planet blog. Also, you can use event and delegates, but I will skip that because this is some kind of a specific for C#. For example, you don't have events in Java, at least not built in. And this is why I'm going to use a much simplified version to ace that job. So, The observer design pattern defines one-to-many dependency between objects, so that one-to-many dependency between objects, so that when one object changes the state, all of its dependents are notified and updated automatically. In our case, let me explain it within the framework. The thing that we want to do is that we want to extend NUnit and MSTest. For now, we'll just work with NUnit for simplicity. And we want to execute logic of every plugin without modifying the base class here every time. For example, if you want to add this new functionality for controlling the browser, I don't want to modify the base test, right? I want to create this 𝐜𝐨𝐏𝐸 architecture design without my base classes to know about the plugins. Later, we're going to upgrade that with allowing our tests to be executed in Lambda test. Then we'll have another plugin for example, marking whether the test has passed or failed. It's going to publish, for example, it's going to publish some of the exceptions to the platform. For security reasons, we might want to download some of the videos from the cloud and save it somewhere else. Again, we're going to do that with some of these plugins. But again, there are many additions that can be added to our workflow, and we don't want to every time edit that. And we want to be able to do that outside of the framework, to allow the different teams the possibility to customize it without modifying the actual framework. Otherwise, one team can make the change and then break other teams, and we don't want to cause this type of regression. Or you don't want to edit your base test and then break 1,000 tests, right? Basically, this allows you to send data to many other objects in a very efficient way. This happens through this plugin observer. As you can see, in our case, we want to execute logic before the test initialize, after the test initialize, before the class initialize, after the class initialize, before the test cleanup, after the test cleanup. Most of the plugins actually will execute logic just before the test initialize and after the test cleanup. This is the usual approach, but again, depends on the case. As you can see, we have a couple of classes here that are part of this particular relatively complex design pattern. We have the plugin observer, or usually this is called just observer, but I rename it to easily explain it. I call this plugin. And even in the pattern, in the original implementation, interfaces are needed for both, for the plugin observer and for this plugin execution engine. In the original pattern, this plugin execution engine is called execution subject. Again, to ease our job and to simplify it a little bit, I will use just base classes for that. I'm going to use the terms plugin and plugin execution engine because you can easily understand what they're going to do. And our base test, it won't know which plugins will be executed by the plugin execution engine. Instead, it will just use the plugin execution engine, and that's it. Later, in some of our specific tests, we are going to add the plugins to the plugin execution engine, but again, without modifying the base test class. That's it. Let's see it in action, and I'm sure that you will get it. The thing that we want to do, before discussing now this local execution engine, let's see where our plugins needs to be placed. I'm going to place them inside this Polaris White core, inside the plugins namespace. Right here, right? So the base class for all of the observers is this plugin base class. And as you can see, I defined multiple methods. These multiple methods, as you can see, They are not abstract, they are already implemented. And why I did that? As you can see, they're marked as virtual, which means that you can override them inside the child classes, inside the actual implementation of the plugins. However, most of the plugins will need just to execute logic in one of the places, right? And the plugin execution engine, as you will see in a minute, it's very simple class. It will just for each of the plugins and execute their methods. And even if you haven't, in order to simplify the implementation of the actual plugins, I don't want every time to, implement abstract classes and they to be empty. Instead of that, I just provided here empty-bodied methods that can be overridden if needed. Otherwise, they will do nothing. And I created those methods that basically say, this will be executed before the class initialized. This will be executed after the test class initialized. Before the test initialize, after the test initialize. Before the test cleanup, after the test cleanup. That's it. Very simple. And we provide some data like which is the test class, which is the test method. That's it. This is normal, reflection in C#. And we have one enumeration for specifying whether the test passed or failed. Then the plugin execution engine, again, in this architecture, this is this class, which will be responsible for working with the plugins. It will contain methods for adding a plugin and removing a plugin, and for reaching basically the hash list of all plugins. Why hash list? Because we want, you can use a list or a hash list. For simplicity here, I change it to list, but if you use hash set, basically we'll have just, you'll be able to add a unique plugin just once. And this is usually what you want. You don't want to add a plugin twice. Or you will need some additional conditional checks. So my plugin execution engine, as you can see, it's static. And another thing is that it contains this list, static read-only list of plugins of the base class. So this means that I can put here any actual implementation of a plugin inside this list. I have two very simple methods called add and remove. They will add plugins and remove them from the list. And after that, I have similar signature of methods like my plugins. Now they are static. And as you can see, the only thing that these methods are doing is that we're for eaching all of the plugins inside the list and executing their methods. As I said, even if you haven't overridden them, most of the cases this will do nothing. It won't slow down or anything. But again, we're just for eaching them. That's it. Now, we need now to connect them. If you take a closer look, the second part is to actually create this base test class, right? And this base test class will be the central base class for our not only web tests, but also in the next module, we're going to discuss how to create similar project, but for mobile tests using Appium. So this will be the base class for the mobile test, for the web test, for the API tests, and for all different kinds. And this will allow you to reuse the plugin architecture between the different types of projects. So if we return to the project here now, inside this infrastructure, as I said, our framework can support multiple technologies, but right now we'll focus only on NUnit, but you can do the same for MS Test if you want, and even XUnit, but it depends. So for NUnit, I created this base test class. I mark it with test fixture. If you are not familiar with NUnit, you will find in the links below there is a whole playlist with very detailed explanations about NUnit, but this is my favorite test framework for .NET. So this is an abstract class called base test. This means you need to derive from it. We use the test context, which comes from NUnit, in order to get some information, for example, whether the test failed, the test name, etc. One one-time setup is a specific attribute in a unit that basically decorates a method that this method will be executed before, just once, before all of the tests. This is why it's called one-time. We're going to set up just the class. And this is why here I use my plugin execution engine. Since it's static, I call onBeforeTest class initialize, right? And now in my child classes or in my tests, I won't use this attribute. Instead, if I want to execute some logic inside the class initialize, now I'm going to override this protected method called virtual class initialize, right? The reason for that is that I want to have just one core one-time setup. And in order to, use my plugin execution engine, here at this point, this will for each of the plugins and execute their onBeforeTest class initialize if they overridden them, right? Then it will execute my logic if I have overridden the class initialize, and then we're going to execute the onAfterTest class initialize. I did the same for the setup. This is the test initialize, right? This method will be executed before each test. We have some .NET specific logic for getting, if the test failed, it will populate this throw exception, because in any unit there isn't another way for getting the actual exception of why the test failed. But sometimes we might need this information inside the plugins, and this is why I want to capture that, and after that provided it here to the after test cleanup events so that we can do something with it. For example, we can send it to the cloud, send it to the test report portals, etc. But basically I'm doing the same thing. I'm calling my execution engine, and it's onBeforeTest initialize, which will again for each all of the plugins here. Then if I want actually to execute my custom logic inside my tests, I'm going to override this empty method now, which is protected virtual, which is test initialize. I won't use the attributes. And then I'm executing the onAfterTest initialize. And we're doing the same thing for the tier now. Again, plugin engine, empty test cleanup, onAfterTest cleanup. That's it. And we're doing the same thing for the class cleanup. Also, you will notice that I have one additional empty method called configure. This will be the place where all of the child classes will define which plugins need to be added here. So if we take a closer look to how our tests will look now, if I open them, you will notice that right now I'm not using directly here the base test, right? I'm using the web test. This web test is placed here inside core and unit, and this web test will derive from this base test. As I said, the base test will be the parent class for the web test class, for the mobile test, etc. And this is how we are going to reuse the plugin architecture. So in my web test, I have access to the application class, which, if you remember, it holds references to the driver adapters and working with page objects. And I'm overriding the configure method, where I called my plugin execution engine .addPlugin, and I added this new plugin that in a minute I'm going to explain how it works. And after that, we are going to explain what this component plugin execution engine is. It's a similar implementation, but allowing us to extend a little bit the web components. Where, as I said, I have created a similar plugin architecture, but allowing us to, for example, execute logic when a particular element was located or not. Again, if you use hash set, probably you don't need this if condition, but for now, since I wrote that with list, we need to use that every time. And only once we'll add the plugin, and after that, this will start working. Now, let's explain how this vocal execution attribute works in this new plugin based on our plugin architecture. If we don't have it, we need to use every time our driver factory to call every time in every class, in every test unit, this start method, where I need to pick the browser version, and this will initialize everything. And of course, in the teardown, every time I need to dispose it, right? And this is a problem because especially when you want to reuse the test later in the cloud and maybe change the browser, etc., it's too much code duplication. And I really like another approach where when we use these attributes, vocal execution, I can really quickly change from this enumeration the type of the browser. Also, we have a life cycle where we can restart the browser just on failure or every time, or we can reuse it locally if it's already started. And this will optimize the execution time, which is really great. I mean, here this can run the test twice as fast locally. However, and later, maybe we can extend that later when we talk about responsive design testing. We can instruct here through the local with this attribute, for example, changing the resolution, changing the size of the browser, and adding other stuff. Also, this attribute allows us to not only to place it on top of the class, but also we can override this behavior and, for example, say this particular test should be executed against Firefox, right? And this works out of the box. The way this works is, again, we're going to use the plugin classes that we defined in our core right here. Again, let me remind you, this is inside 𝐴𝑟𝐴𝑠𝑦.core project inside the plugins namespace. And inside my web project, I created this plugins folder right here. And we have browser execution. We have the browser enumeration. We have the browser configuration that we used the last time that accepts lifecycle and execution type. We're going to use that more, especially when in the video about responsive testing inside this module. We're going to upgrade the solution and be able to run it inside the grid, inside the Lambda test. So as I said later, we're going to upgrade it further. But the core logic is happening inside this browser lifecycle plugin right here. And also we have this attribute. This attribute is a class where we use this attribute usage, where first, you need to mention here where you can put this attribute. We can put it on top of a class and on top of a method. Also, we instruct that we can inherit it because later we're going to again create additional attributes, for example, for quality execution, grid execution, etc. And you cannot put multiple of them. That's it. And we have a very simple constructor here that, again, we just provide the browser and the lifecycle, and then based on it, we initialize the browser configuration class. So inside the browser lifecycle plugin, here it is, we derive here from the base plugin, this is our base observer. If we return to the diagram, the plugin class is here. It defines all the empty methods that you can override. And then we'll have different plugins, not only controlling the browser lifecycle, but many more that will override just a specific point that they want to execute logic inside. In this particular case, we are going to execute logic inside on before test initialize and maybe on after test cleanup, where we're going to close the browser. And again, we're not going to override all of the methods, right? we're going just to execute logic here and here. That's it. In the point when we execute logic before the original test initialize. Why here? Because many often inside the class initialize and test initialize, you want to, for example, navigate to a page, find elements, etc. This is why before the test initialize, we need to start the browser. We have a method called getConfiguration. Here, inside these three methods, we use C# reflection. This C# reflection allows us to get from a specific type or a specific method to get its attributes. And after that, we check, do we have a method attribute? If yes, then please get its browser configuration. Or otherwise, get the class. Later, we're going to upgrade that when we discuss the module about configuration files. Here, we're going to add additional logic for reading default values from a JSON file. And we'll have different JSON files for the different test environments. So this get browser configuration basically gets the information out of the attribute and initialize this current browser configuration object. After that, we have should restart. And here we have some logic based on the life cycle enumeration, whether we need to restart it. If it's not set, of course, we need to restart it, etc. And in the restart browser, it's obvious what to do. We close the browser, we dispose it, and then right now we have only implementation for local execution. As I said, later when we implement this execution inside the grid and inside the cloud, inside the Lambda test, we're going to create additional methods here inside the driver factory. But for now, we're just calling the static driver factory to start the browser. And as you can guess, inside the on after test cleanup, we're doing a very similar thing. We're shutting down the browser if we need to restart every time, and depending whether we need to restart it on failure, and if the outcome of the test is failed. That's it. And later, inside our tests, the only thing that we need to do is we need to comment here the driver start factory. I'm going to comment here the teardown. I already derived from the web test and put this local execution for run. And now, if I run here this particular test, it will use now our plugin architecture and this execution browser plugin to run the tests. It will restart every time the browser, etc. Also, right now, I have added two more plugins that in a minute I'm going to explain that are extending the particular web components. As you can see, without the driver factory now, out of the box, using the plugin, this started my browser. It will navigate to the website. As you can see, the highlight now is working. In a minute, I'm going to explain how this works. It's a very similar, we have a similar execution engine and a base class for the plugins, but they basically give you another point. That's it. And now we have a green test. So as I said, let's now look into these additional plugins, this web component plugin execution engine. I wanted to create two plugins for highlighting and for scrolling into view, because sometimes, for example, especially in this case where we purchase products, if you try to check accept terms, this won't work unless you scroll down. And this is especially useful when you have video recording of your test, because you will see exactly where the action is happening, right? Otherwise, you will just see the visible part of the browser. WebDriver is not scrolling automatically, which is normal. I mean, this is not a drawback of the framework. This is why we need frameworks. So, where I put that? Well, inside our plugins folder now, I have, as you can see, a folder called components. And inside this components folder right here, I created another base class called web component plugin. The web component plugin is very simple. Again, it contains two virtual methods that have an empty body. Your plugins, if they override that, if they don't override that, nothing will happen, nothing will fail. But as you can see, the method is called onComponentFound. As you can guess, this will be executed exactly when the lazy loading is triggered of the web component. Exactly when we found the native web element, this will be triggered. And all of the plugins will be for each of these web component plugins. We have a similar static class called Web Component Plugin Execution Engine that is responsible for holding a reference, a list, a hash set to all of the web component plugins. You have again two methods, add and remove plugin, but this time you accept the observer for the web component plugins. And we have two methods where we just for each this list, that's it. The place where I execute that, instead of doing that in the base test, as you can guess, we are doing that in the base class for all of the web components. If you watch the previous video, this is the adapter, the web component adapter, this base class for all of the web components, this web component class. And again, we don't have a list to plugins. We just use the static web component plugin execution engine. The only place where I use it is inside our wrapped element. If you remember, we implemented lazy loading, which means even if you create the plugin, even if you create the specific web component checkbox button, at this particular moment, you're not going to search for it inside the browser or inside another element, but instead, you're going to trigger this logic only when you perform a particular action, click, typing text, hovering, etc. And this is why, after I found my wrapped element, this is the place where I'm going to for each and execute the logic of all of my web component plugins that have implemented this onComponentFound method. And I already did that. I created two additional plugins here, the highlight element plugin and the scroll into view plugin. They both use JavaScript. This scroll into view plugin, as you can see, it derives again from this web component plugin, the base class. This is the base class, the base observer for this current implementation of the web component observers. And I overrided only the onComponentFound method. We just execute a simple script that it's using JavaScript to scroll down to this particular iWeb element. That's it. That's all it takes. And since I don't want, again, to put that and every time change my base class for web components, I did that inside the plugin. This was the 𝐜𝐴𝐬 architecture again. And again, I want to add later the highlighting. That's fine. I'm not going to edit the web component base class because it can introduce regression and many other things. And I don't want to make it much more complex than it is. It's already very complex. So this highlight plugin again overrides onComponentFound. And we have some, if you watch some of my previous Java videos or others, we use this multiple times to do that. Using the getCSS, getValue, etc., we get the original background colors, etc., of everything. And we change them to yellow and red, the outline. And then we use native JavaScript to return it back to the original background and color after 500 milliseconds. And we just go execute script, that's it. And this will happen really fast and it will simulate this highlighting, which is really helpful for, especially when you watch videos, right? So this is how the plugin architecture works. So we already checked now how the browser execution plugin works and the web components. Now let's finalize our module with discussing some other customizations based on the stuff that we built the last time. I'm going to show you how to create a custom locator, custom weight strategy, and new components. Again, this is the real power to use a framework. not just a simple library. And I did that outside of our framework repo. Instead, I'm going to do that in our repo where our tests are, and we used our framework as a submodule. And this is the usual approach, right? Your other second team will just use the framework as a submodule, and they won't, if they want something custom, they won't push it back to the framework. Instead, if it's just something custom for them, they're going to add it to their customization project here. Now, imagine that we want a custom locator. What is this custom locator? I called it find by label, label find strategy. What is this label find strategy? I use this very often in many of our projects, especially in places where we don't have very good ideas, or locators are changing many times. We use actually these labels to find the inputs here. The way we do that is we use XPath access. There is an awesome article on the Lambda test blog about XPath. I suggest you to check it out. And what I do here, I can type the label. As you can see, the label is on top of the input. So first we find the label, and then we use following sibling, finding the div, and then the input. But again, this layout here for HTML elements, it's absolutely the same for all the inputs, for all the selects, etc. So we can reuse that. For example, if I change it to last name, as you can see, we found the next, and we can do the same for the email and the phone. So it makes sense to have such a find strategy. The way I did that is, again, I created a namespace called locators inside my customizations project. Our demo system test, it reference again our customizations. And now I added here, I derive from the base class find strategy, and I overrided this convert method where, using string interpolation, we are just providing the value that we're supplying to the constructor. Of course, we need to create some extensions to ease our job instead of using find and then new find strategy, etc. In order to do that, I created inside the services namespace a class called driver adapter extensions. And as you know, extension methods, they allow you to create these static methods, and they will be part of the driver later as they were, I don't know, written directly in the class. So I created this find label. Basically, this is absolute copy of all of the rest of the methods that are part of the original framework. You don't need, like here, if you go to find, you will see that they're exactly matching these methods here, right? It's very similar, but instead of calling it find by ID, I called it find by label. And we use the same signature with generics. So the only thing is that now, in order this to be an extension method, this needs to be static. You need to put them inside the static class, and also they need to mention here what they're extending. In our case, this will be the element find service. When you call element find service, after that they will appear as original methods of this interface. And here I'm calling my driver adapter dot find component, and then I provide the label strategy. I did that for find by label and find all by label. Also, imagine that sometimes you want to add some methods that are missing in the framework driver adapters. I missed the last time on purpose to implement working with alerts. And this is why here is an extension method, again, part of this driver adapter extensions. I added these two extension methods for handling alerts, providing some action working with them. Again, this exact implementation, it's not so important, but the important part is that you can add additional methods to the services without modifying the framework. Of course, in languages like Java, where you don't have extension methods out of the box, you have them with some extensions like 𝑨𝒏𝒕𝒐𝒏 and others. But still, if you want to do that, you will need to basically create a child class out of the adapter. But here, we have extension methods. You have extension methods in TypeScript as well. So this is a very popular approach, and we can add these additional methods to our driver adapter. Or to particular interface, it will be up to you. Maybe you can add them to the iBrowser adapter. It will be up to you. And when we open now the tests here inside the framework, it will be really important that if you want to use the extensions, you will need to provide an add using to this particular namespace. Otherwise, you won't see the extension methods. This is why I'm going to add the using to this Polaris White web services. And now, if I use here app.elements, we can type add by label. Do you see? And there is a star and there is this sign here that means that this is an extension method. It's not originally from the original implementation, but it's an extension method, which is excellent. And by the way, I did the same. I created another class for web component find extensions. As you know, we can search inside components, not only inside the browser. For example, you can search for other elements inside a div, big div, or inside a table. So here, instead of extending here the iElement find service, we are just extending the T component, implementing the same thing. I did something very similar for adding a custom wait strategy. Imagine that you want to wait a particular value to appear inside your HTML element. And this is exactly what I did. This is why this is called toValue containing wait strategy. It will wait when you find the element here. It will wait for the value attribute to contain a particular value. Again, it's relatively basically copy-pasted one of the original wait strategies, but again, it's outside of the framework itself. And in order to allow you to have this syntax about using fluent syntax to adding these strategies to the web component that will wait for them before returning the element, we basically I created this new class with extension methods called web component wait extensions, and basically we create the wait strategy, then we call the ensure state and provide the wait strategy inside. That's it. And now in the checkout, again, before typing something, for example, inside the first input, we have access to value contains, again, is displayed as an extension method. Again, all of those are outside of our original framework. And imagine that, lastly, I want to show you how to add custom components. Imagine that right now, if we look closer in our web framework, we don't have components for phone and for search for this HTML5 HTML tags. And similarly to the ML, we want to add such an implementation together with all of the validate methods that come with it. Again, where to check how they work, you can open the MDN web docs, the Mozilla website. Here we have the input. This is a specific input for working with phone numbers. They have, if you take a closer look, they have max length, min length, how long can be the phone or a minimum length. This triggers some validations, front-end validations, so it's important to verify that. The same thing goes for the search. for maybe you can implement cover as well. Usually they work with setting the value attribute. So the thing that I did, again, they're not part of the original framework. Instead, inside my customizations project, right here, I created a new namespace called components. And I added them. I added these two components. They will work out of the box using the find methods, find by label, find by ID, etc. This is why we created these different components. Our framework is lacking of some of the interfaces for them. If you remember, we use these interfaces for allowing these validate methods. They are special assertions where we will wait for a particular condition to happen. For example, we wait for the phone to be disabled or the phone to have a particular value, etc. But again, we derive from the web component. And we have many of these placeholders. Again, I did this research and I decided that we have get phone, set phone. As you can see, we are not using regular send keys, but instead we just set the value attribute because this is HTML5 control. If you need to call some of the base methods and define them as public, we just use the new keyword in C# and then call base, however, to reuse this protected method. And after that, we have pretty new properties unique for this phone and search, which is autocomplete. Again, we use get attribute. Instead of doing that every time, we do that here because it makes sense to validate them, whether it's required, whether it's read-only. This might be an acceptance criteria for you. And it's very useful to have them here instead of every time, using get attribute. And I added this max length and min length. As you can see, we are parsing them. We are returning them as integer. We have the size. And I mark all of them as virtual so that if you want to change their behavior later in a child class, you can do that. I did the same thing for the search. Again, we are lacking some of the contracts from some of the interfaces. This is why I added them here inside my customization project. I created these very simple interfaces for holding an integer, a public property to the max length, to the min length, to getting the phone, etc. And what is this giving us? Well, it gives us the possibility to create extension methods for validating all of them. For example, we have an extension method to this interface iComponent search, and we're calling the validate method that, will wait for this particular condition to happen, and we wait for such results to be equal to the particular value. Otherwise, this prettified message will be displayed together with the URL. And I did the same for creating similar validate methods, extension methods for validate max length, etc. And again, they are not part of the framework, but you will be able to use them as regular methods part of the framework. And one last thing, if you want to add methods that are missing in existing elements, you have two approaches. One of them is to use extension methods. That's pretty fine. You just create a static class called email extensions if you are going to extend the email. Our email actually was lacking of this max length, min length because we added them now. And it's pretty simple. We're just extending the original email component, which is part of the framework here, part of the Polaris White Web. We're implementing them the same way I did before. They're actually here, email extensions. Again, in order to use them, I put them, in order to ease the usage, I put them in the general Polaris White Web namespace. Another approach is to just not define it as partial, but to create a child class out of the original component, and then you can just override some of the emails, some of the methods. Why here? I just overrided this method setEmail. Instead of using send keys and clear, I used another approach for example, setting the menu attribute. This is a very popular approach for example, many people are changing the behavior of how buttons are clicked. Instead of using the original click, they use JavaScript, and that's fine. You can just create a child class out of the button and then change how the click is working. That's fine. Yeah, we covered a lot of things. So we discussed how to use our framework as a Git submodule. We discussed what the Git submodules are. We discussed in many details the observer design pattern and creating this plugin architecture. And at the end, we had a short overview about all of the possibilities, how you can customize the framework, creating custom locators, wait strategies, creating many extension methods to the driver adapter and web components. We created some custom brand new web components, and you saw the real power of the framework to be able to customize it and create plugins for it. In the next module out of our course about building advanced test automation frameworks, we are going to build and create the next project responsible for automating mobile applications. We are going to build these core mobile components. Hi guys, greetings from Bulgaria. This will be our fourth video from the playlist about building advanced test automation frameworks. So let's begin. First, if you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified when new videos are published, and they are published each week. Also check the awesome Lambda test blog because there are so many advanced test automation articles and then can help you to be a much better test automation engineer. In the links below, you will find the full source code, which is in GitHub. You need to clone the particular and check out the particular branch. In a minute, I'm going to show you. Also, you will find all relevant resources and jump links to particular sections from this video if you don't want to watch the whole video. Also, I suggest to download and download the source code. And while I explain, I suggest to check the code, right? Let's begin. I won't spend time on the course overview again, but we defined our requirements. We built basically the module for automating web, building these core components. Next, we upgraded our test automation library to be full-fledged framework in the previous module. I suggest to check and watch all the videos from this playlist one by one because they're some kind of interconnected. And here in all of those videos about test automation frameworks, they basically upgrade our knowledge about design patterns. So if you haven't watched our course about design patterns, check it on the Lambda test channel. You will find the link below. So in this particular module, we are going to create this mobile project, part of our framework. It will follow a lot the structure that we already created for the web. So we're going to implement all of these core mobile classes. Of course, there is super many classes, and this is why I won't type the code manually so that we don't lose time, but I will walk you through the code. So let's begin. Again, I suggest to open the GitHub repo that you can find below. This is the repo 𝑣𝒏𝒕𝒐𝒏 test framework, and the branch that you need to clone is right here. This build core components for mobile. Again, for each of the modules out of this course, we have a different branch because we are upgrading the solution little by little, right? So I switch to this particular branch, and first, if you are not familiar with mobile test automation, I suggest to check. There is pretty awesome playlist on the Lambda Test YouTube channel about test automation with Appium. Of course, we're going to, upgrade your game here with this integration. Anyhow, like with the web tests, I have here some mobile test automation tests, we're going to use Android. Of course, I'm going to create the project only for Android, but it will be absolutely the same with iOS. The framework that I developed in the past called 𝑨𝒏𝒕𝒐𝒏, very advanced framework. We're using a very similar structure here. But yeah, we have two different projects. Instead of having just one called mobile, we can have Android and then another project for iOS. Some other frameworks that you can check that are open source, they actually combine them both. It's a matter of architecture, I guess. So here under demo tests project, where we had tests for web, we have a namespace for the mobile tests. As you can see, there are 5 files for now. I'm just going to run the test for very simple APM test, that is clicking, finding some elements in the normal, very popular demo Android demo app. I have set up here, I'm using an emulator, right? So this emulator is just a pretty standard emulator that comes with Visual Studio. I also used and I already started the APM desktop server. You can do it by command line or you can use code. Here I commented this particular piece of code, which will basically start the server. That's it. And the way this works, let's run the test. Again, you can check the detailed playlist that you will find the links under the show notes. So now the project was built. In a second, the application will start. The test, as you can see, is executing. As you can see, it's pretty straightforward. We're just opening a few pages, clicking buttons, and here there is a very nice view with some buttons and different types of elements, so like combo boxes, selects, checkboxes, radio buttons, text fields, etc. So in order this to work, we have Android driver, of course, instead of iWeb driver. When you initialize the Android driver here, you need to provide the URL to the server. Usually it's listening to the port 4.723. I changed it to 22. And for the Android, we have a little bit more some settings, like the device name, which in my case is the emulator name. We have the platform name Android, the Android version, UI Automator 2, you will see in a second when we discuss why we need that. I have the test app path that later I will explain how it works. We have app package and the app activity, which is, you can think of it as the name of the specific screen that we're opening in Android. That's it. And of course, at the end, we need to dispose the driver. That's it. So let's see how we can upgrade that with our framework. In a similar fashion, let's see how this works when it's refactored. As you can see, I'm going to show you how we're going to make this work with a similar app execution plugin. The way we control the browser, this time we'll control the application itself. As you can see, we have much more settings here. We have the Android version, the device name, the app path, the app package. Of course, we don't want this to be copy-pasted every time. In some of the next modules, we're going to upgrade this solution to be able to put some of this default configuration inside configuration files, and this will allow us to have different configuration files for different test environments and setups. And also, this will be greatly upgraded in the next module when we discuss responsive design testing and executing all of those tests on the real device in the Lambda Test Cloud. But more on that in the next module. For now, as you can see, we're here deriving from Android test, and also we have a very similar syntax that in a minute we're going to discuss again how this works. But similar to our web module out of our framework, we have this app class that gives us all of the different services like before, like app dot, as you can see, we have web, touch, elements, app service, devices. For example, in devices, this is a particular service that we can walk and walk and others. As you can guess from the elements, we can find the different components on the screen. What else? In the app service, we have so many methods like installing a different application, removing it, backgrounding application, switching to web views, and so on and so forth. And after that, the syntax for finding elements is very similar to what we had for the web module. We have different find methods here. Instead of just having one default one where we provide the by locators, instead we have our methods with the different locators, and we need, as a generic parameter, provide the different components here. We have button, checkboxes, radio buttons, and many others. And after that, we provide the different locators here as a parameter. Also, as part of our page objects, we can, using Fluent syntax, we have these extension methods for, we can chain them. By default, our framework will use lazy loading, which means that here at this line, our framework is not going to search for the element inside the application itself, but instead we'll do that internally at the moment when we do the first action. This is the lazy loading that we implemented in the web, and we're going to implement it here as well. And if you remember from the previous video about the web module, inside our web component adapter, we had logic where we use these wait strategies that are incorporated with these extension methods, and we had a list that we're for eaching them and waiting for all of these conditions. We're going to do absolutely the same. The whole reason for this particular architecture is that we strive always for the different modules, part of our framework, to follow the same architecture, the same syntax. This means that if you learn how to use the framework for web and later you need to switch to mobile application or later desktop application or API testing, basically the syntax and the logic to be absolutely the same, of course with the differences between the technologies. So let's see how this works. I created this mobile project. As you can see, we have similar folder structure. We have assertions where you will see at the end of the module that we have similar validation methods. These validate methods, they basically allow us to wait for a particular condition to happen. They will wait internally using Android mobile wait class. They will use it so that we wait for example, a button to become disabled, right? Also, inside the components, as we will discuss here, are all of the adapters that are wrapping the normal APM element and Android elements. We'll have different components for buttons, combo boxes, text fields, and all others. We'll use again strategy pattern for locators and wait strategies. We'll have services with different contracts. We'll have plugins again for controlling the application. So pretty similar architecture. However, there are some differences. Let's begin with, if you remember, we need a class, a factory for initializing the driver before working with the plugins. And this will be our driver factory here. So I'm going to first explain the driver factory. As you can see, later we're going to upgrade our solution to be thread safe. For now, we don't need that. What does it mean to be thread safe? This means that at some point we will want our solution we want to execute our tests in parallel. This means that if we don't do some upgrades, there will be many consequences and problems. But we're going to use some thread local classes and others to make this work. So for now, we have a property marking whether this factory was disposed or not. We have app configuration class that it's initialized manually, or we're going to do it with our plugin. What we have here in the app configuration, again, we'll refactor and remove these URLs later here. I added some to-dos for later modules. Why? Because basically this URL will, instead of being hard-coded here, we're going to change it through these configuration files, JSON configuration files. We have a few attributes. Again, if you remember, we have the browser. When you want to execute your tests in the mobile web browser, we need to pick a browser, right? Chrome, Firefox, or Edge. We have the execution type. For now, we don't care about that, but later in the next module, we're going to use this particular enumeration. For now, we're going to execute our test only locally on our emulator, or if you connect a real device, of course. We have the life cycle. In a minute, we're going to use it in our plugin, where we have a few options. Basically, you can reuse the emulator and the app. This will optimize for sure the speed of the test, but again, it depends on your particular native application. We can restart it every time, probably in the next module when we execute the test in the grid or in the Lambda Test Cloud. This is the suggested option, because otherwise you will just have one huge session with one really big video, and we don't want that. Or we can restart it on fail. We have the local execution attribute, similar to what we had for web. Again, we basically specified here that we want this attribute to be able to put it on top of a class, on top of a method. We don't want to be able to inherit it, and we don't allow multiple of those. We derive from the base class for all attributes the attribute, and as you can see, we have very similar properties like in our configuration. Basically, we have the app activity, app package, app path, browser name, device name. All of those, we can set them through the attribute. And the app configuration, as you can guess from the name, this is a class, a model class for holding all of the settings that we need to control the execution of the application on our Android emulator or later real device. We need the app path, the life cycle, the device name, everything that we picked. And later we will allow the users of our framework to be able to add additional APM options. Like, for example, if you put a lock with a pin code, sometimes we need to add a specific option to allow users to override that. Or as you see in Lambda test the next time, there is a capability for bypassing the authentication with fingerprint, right? And we have a few constructors, nothing really special. But if we return to the driver factory, again, we have the app configuration, we have custom driver options. Again, later we'll use them. For now, we're going to ignore them. We have everything, as you notice, it's static. That's fine. For now, again, we're just going to run the test sequentially. Later, we're going to upgrade that. But we have a public property to the wrapped Android driver. And we have a factory method. If you remember this factory method design pattern, it's we use it to initialize some classes. And right now, we use it to initialize the Android driver with particular configurations. The thing that we do is that right now, again, we support only local execution. This is why, again, later we're going to add more branching here. We're going to implement these cells here. For now, we have just the magic is happening here in the initialize driver regular mode or local mode, as you let's use the same terms every time. So from the app configuration, we get the URL again. If you use APM desktop, or if you started APM from the command line, this will be just your local host on the default port. And we need to initialize these APM options. We set Android. I basically hard-coded those, but later we can move them to the configuration. We need the Android version of the device name again. Later we want to change that with the attribute, because basically sometimes it's like a requirement your application to support different Android versions and devices, of course. If it's a mobile web execution, we're going to set the default browser. Otherwise, we need to pick, as you can see here, we use app package, app activity, and app path. By default, for our demo project, I moved all of the applications here in the resources folder, right? And if you check properties, you will notice that I set them to be copied always. Basically, when you rebuild the application, they will be copied to the bin folder in this resource folder. And this is how I get them. However, it depends, again, if you have JSON configuration files. Later, it's a very common practice, all of these solutions to be integrated in our continuous integration deployment process. This means that you have one build for example, building your application with particular settings. The output will be placed somewhere on your virtual machines for the build agents. Then you need to put this dynamic path supplied through environmental variables or something else. Again, this can be changed over time. For now, for simplicity, I just use this approach with the copying the application there. After that, let's ignore these custom driver options. We initialize the driver, that's it. And we have a dispose method. This is how our driver factory works. Let's discuss now the plugin. If you remember from the previous module where we used the observer design pattern to extend in unit, our core methods for working with plugins, they're placed here inside our core project, right here, right? And we have the base class here that it's using this plugin execution engine. So this plugin execution engine, like with our web tests, we have this Android test that it's basically the base class for all Android tests. We have a property to the app class that later basically it exposes all properties to the different driver adapters, and we have methods for creating page objects. That's it. But the whole thing is that we have this configure method that we are overriding, where we added our app lifecycle plugin. This is how, instead of like here, instead of not here, but the no framework version, instead of repeating the whole code every time in the teardown and the setup, etc., the whole logic is happening inside our plugin here, app lifecycle plugin, this file. It works pretty much identical to how our browser lifecycle plugin was working. The name is different, of course. As you can see here, from all of the methods, again, we had different points, like before the class initialized and after the class initialized, before the test initialized, after the test initialized, before the test cleanup, after the test cleanup, before the class cleanup, after the test cleanup. We have 8 of those methods. However, since in our base class here, we implemented all of them and their set is virtual, but they are empty-bodied, we can just override the ones that we need. And in our plugin, we need, like with the browser execution engine, we just put logic before the test initialize, because sometimes in the actual test initialize we want, for example, to navigate to a page, or in this case we want to navigate to a particular activity or find elements. This is why we need to do that before the test initialize, and then after we execute the test cleanup, not before that, but after, because Sometimes in the actual test cleanup, we still do some actions in the application itself. This is why it's important to be after it. We basically are going to restart the app, close it, etc. So in before the actual test initialize here, we know right now which is the actual test that we're executing right now, and we use this get app configuration. Again, we use some reflection to get our vocal execution attribute on a class level and on a test level, and then from it we have a special method in our app configuration class that can initialize the app configuration from the attribute properties. And this is exactly what I do. Here we just have a simple branching for, if you put something on the class, this means that the whole class will use this setting. However, you're allowed, like with the web tests, if you want to change something for a particular test, if you put this annotation here and, for example, change the Android version, this will be, if this is missing, we're going to use the class level. However, if we have it on a test level, then this will override the class level. Later, when we upgrade this plugin to use configurations, first we will have the configuration, then if you have a class, the class level will override the configuration, and then the third place will be the test, which will override both of them. So if we return to our plugin now, again, this is the branching here. For now, we have the app configuration, and after that, we just use the should restart method. It basically checks the life cycle, enumeration. If you set it that it needs to be restarted every time, then fine, we will restart the application every time. But as you can see, the restart app is just using our static driver factory. It will just close any existing connections to APM. It will close the app, and then it will start it again. That's it. And we're going to shut it down. In the after test cleanup, we are doing very similar thing. We have two ifs. That basically, if we said that we want to restart it on failure and the actual outcome of the test is failure, then we're going to restart it. Otherwise, we have another condition for shutting it down. That's it. As you can see, it's very similar to what we had for the browser with slight differences. That's it. The biggest difference is that our app configuration actually have pretty much more configurations. That's it. So that was the plugins. That were the plugins. If we walk into our services. Our services now, as you can see, I splitted the adapters again. We use here some partial classes. If you remember what a partial class is basically it allows us to split the class among many files, but when you build the project, all of those files, since they are partial, they will be combined in a single type. In this case, this will be the driver adapter. In this case, the driver adapter, instead of wrapping 𝐜𝐤 we are wrapping Android driver. However, since we want to support three types of applications on mobile devices, we want to support mobile web browsers, we want to support native applications for which we need Android driver, but also we want to support hybrid applications, which are a mixture between the two. So you will need both the Android driver, but also our web driver adapter. This is why if we open the project here and its dependencies, I reference here our Polaris White core project to be able to use the plugins in the base classes, but also I reference the web project because we are going to, for working with mobile web browsers and for working with hybrid applications and web views, we are going to use the already existing infrastructure in our web project. And I installed additional dependency to APM WebDriver, the latest version for now. If we return to our driver adapter, as you can see, nothing really special in the main class. we just have private variables and one public property that it's called 𝒏𝒐𝒏 that actually we get them, as you can see, from the driver factory. Again, at this point, when you need the driver adapter, we already executed the plugin. It's going to start and initialize the wrapped Android driver here. That's it. Now, for the rest of the driver adapters, if you remember how we use them in our app class, you will notice here that again I have a bunch of interfaces in this app class. We have a private variable to the driver adapter, and then instead of having access to the whole driver adapter, I have public properties to the element find service, device service, keyboard. Basically, I split the whole Android driver among, and I distributed it through these interfaces that we are going to see in a minute. And also we have page objects, or instead of calling them pages, which is wrong, I call them Android view. And if we take a closer look to the different services, you will notice that in the interface that I called app service, we have methods. I moved here all the methods that we control the application itself. We can activate it, background it, we can work with its context, we can install an application, remove it, switch to web views again, since the hybrid applications are a mixture between a native app and then they have this web view and working with web. This is why I put here in the app service the work with web views. Then we have the basically all the methods that we can work for the device. We can lock it, unlock it, we can turn on the location services, open notifications, set particular settings, rotate it, screen orientation, getting the device time, etc. I moved all of them here. We have a general interface that basically implements all of the rest. Then we have the element find service. In a minute I will return to it, but it exposes all of the methods that are responsible for locating our components. We have a few methods for working with files, downloading them from the device and saving them to the device. We have a few methods for working with the keyboard, hiding the keyboard and pressing some keys. We have touch actions. This is interesting, similar to the actions class in WebDriver, but here we have additional methods like swipe and tap that are specific to mobile devices. And also we have the web service. This web service, again, we use it in cases when we need to work with mobile web views in hybrid apps and with mobile web browsers. And instead of repeating the whole logic that we built in the web project, instead, of course, we are just referencing the web project. That's it. And here is the implementation. Again, this is a partial class, the driver adapter. We already have access to the Android driver that we initialized from the driver factory. And all of those files are implementing different interfaces. This particular file here, .app, is the same driver adapter. As you can see, there is a difference between the file name and the class name. It's implementing right now this particular interface. Again, the big benefit of doing that is that if you need to update something that is related to the file system, you don't need to search for it inside a very huge. If you had put everything inside one big file, it was going to be a hell to find what we need later if we need to do some changes. This is why I prefer this approach, at least in C#. So we implement this interface here. As you can see, sometimes we are catching some exceptions. With this start activity, sometimes it makes sense to hide the keyboard, because if the keyboard is there, this makes sometimes harder to find some elements. Besides that, we're just wrapping. These methods are not so interesting because we're just wrapping some of the regular actions that Android driver is doing. However, we're improving some of the signatures. As you can see right here, the default background is actually accepting time span. But most of the time, like 99% of the time, I think will just use seconds. And this is why we improved here the interface for our needs. We changed it, we adapted, and instead of providing time spans, which is a bit longer and longer to type, we just provide integers as seconds. And here, the interesting part, later when you clone the repo, you can check it out. Right now, this is not our priority, but I think it's a big improvement for have different methods for working with web views. Like half a year ago, I had to work on this complex hybrid application, and it was extremely hard to work with these web views. So as you can see, the regular syntax, to work with that, we need to do this type of casting. We need, sometimes in hybrid applications, we have many of these contexts, and you need to find the right one. For example, in Xamarin, this is the case. So I moved here some of these methods. Also, we have this super advanced switch to web view that accepts a function to filter which is the correct web view that we need. Again, in the adapter, this is the whole purpose of using the adapter design pattern. We are adapting, we are making things simpler for the user instead of doing all those things every time. And regarding the device service implementation, as you can see, for example, here, the regular device time is returning string. I noticed that depending on the version of Android, depending on the particular mobile device that you use, the returned string is totally different, which doesn't work for me. I mean, when we want to assert that, we want to work with date time, for example. This is why I think we adapted that to return an actual datetime, and we format that, we parse it, etc. Also, what else? The rest of the methods here, more or less, are just wrapping the very similar methods in Android driver. The same is for the files. Pretty much very similar for the hide keyboard, but I noticed that sometimes this is throwing an exception. This is why I decided to try catch it. Touch actions, this is interesting because we're using this actions class. However, there are some specifics about, for example, swiping. There isn't an original swipe here. This is why I simulated that with click and hold, then move to a second element. But again, you will notice that this method is generic. All of them are generic, and they are accepting our T component, which means that we're accepting our Android adapters, component adapters. This is our Android component. It's not the native Android element or APM element. This is why we need this adaptation right now. We have a similar thing for this swipe with coordinates. We have another implementation for the tap. Again, as you can see, we enrich. We make them a little bit. We provided more implementation here than it was, and we hided some complexity. And for this web service, we just exposed our WebDriver adapter here. Again, we are using all of the logic that we used before, all of the complexities of our web module. And before discussing the these find components, they are working in a very similar manner. But before doing that, we need to take a closer look to the implementation of these find strategies. More or less, they follow the same algorithm, the same design pattern like we use for the web. They're located here under the locator folder. However, they work in a slightly different manner because both drivers are different, right? So if we open here this find strategy, which is the base class for all of the find strategies, you will notice now that again we have the value, which is the actual XPath, the actual ID, the actual CSS, whatever. However, instead of having this convert method right now, we have different find elements for finding inside the application itself using the Android driver, or for searching inside an element. And as you can see, all of those methods are abstract, which means that for each particular strategy, which is ID containing or whatever, we need to implement that. If we take a closer look to one of the simplest ones, you will notice that right now we implemented all of those find methods, and we use the native approach for that, providing this mobile by, the tag name, and we return the APM elements. That's it. And later inside our native find elements, we are using those for returning the original APM elements. That's it. The interesting part here is actually for most of my other strategies, for example, for ID find strategy. Since we are using UI Automator, with my experience, I noticed that when you have the mobile application and when you open it, APM sometimes struggle to find elements that are not visible on the screen. You need to scroll down, swipe to the bottom until the element is visible. And this is very hard to do. This is why there is a very secret and strange way of how to do that. If you use Android UI Automator locators, and in them there is a native way in Android. If you wrap this UI selector inside the UI scrollable, and they have a native method called scroll into view, then you need to pass another UI selector, and then we use this resource ID, which is the native way how we locate elements with UI Automator. How I found that? There are a few advanced articles that you can find online for doing that. However, the best way to check all of those is if you open developer.android.com here, and there is a reference for UI Automator. All of those are described here. And as you can see here, from the right there is an agenda with all of the methods, and here we have resource ID matches, which is using regular expressions to find elements. Again, this is super complex, very easy to make a mistake. This is why strategy pattern here is super excellent, because we are going to reuse it every time. But again, this is super magic, because every time when you provide this selector, we're just going to provide the actual ID, but we are going to use string interpolation to generate this out of the box for us. Natively, it will use, instead of using mobile by.id, we are going to use every time Android UI Automator. And then this automatically will scroll down, and then we'll find the element by ID, which is super awesome, right? And I did a very similar thing for example, ID containing, but this time here we use resource ID matches, which again is using regular expressions. For some of them, I left them for you just to see. If you don't want this more complex approach, you can just use the standard way of doing that with the native elements. That's it. If we need to discuss the other type of strategies, the weight strategies, you already saw in our tests that we're using the framework, we already have the capability of, if you remember from the web part, we have this to be clickable, then to be visible, and we can chain as many of those as we like. If we open that, you will see that we have this class Android component extensions. It's extending our Android component adapter that we are going to discuss in a minute. But basically, this is just calling the component ensure state, which is adding these strategies to the list with strategies that we're going to for each inside our lazy loading, and we're going to execute its method wait until for waiting for the element to be clickable, to be visible, to exist, etc. Again, you can find all of those strategies inside this folder. They're following the same pattern as before. If we open the base class for them, this wait strategy, we are just getting the wrap driver, we have the timeout, the sleep, we have an abstract method that all the strategies need to implement, and basically that's it. Instead of WebDriver wait, you're using the native Android driver wait. That's it. And if we if we see how the toExist wait strategy works, we just derive from the base strategy. We have a constructor. We implemented this wait until that accepts find strategy, and that accepts this function that returns a boolean that accepts the Android driver and the find strategy as a generic, and we're waiting for this element not to be known. Absolutely the same way they're working as our web, so we're not going to spend more time here. However, we need again to discuss first, before we walk into the find methods, we need to look how our Android adapter component is working. Again, the adapter is using composition to wrap the original APM element, and we are implementing here lazy loading, which means that at the moment when we find the element here, at this moment we are just creating an instance for the button, but we are not finding the native APM element. We are doing that inside this click, and let me show you how this works again. We have a few properties here. We have an access to the parent wrapped element. We have the find strategy, which is super important for our for our component adapter, right? We know the elements now, the components, they know all of them, the button, the checkbox, the combo box, all of them, they know how they were located, holding a reference to their find strategy. Then we have access to the wrap driver, and we have also a list to all the strategies. At the moment when we call find, this will just initialize the list, the driver adapters, that's it. We'll just get an instance, a reference to the wrap driver through the driver factory. And then the whole magic again is happening inside this wrap element property, triggering the lazy loading. And as you can see here, all of the public properties, or the protected ones, they're calling the wrapped element, which means that, as you can see, by default, we're checking, is this wrapped element, which by default is no, because we are not initializing it in the constructor. If it's no, then we are going to find it, and we're going to call the native find element. Otherwise, we're going to return it, right? This is how the lazy loading works. And this find element, it accepts our find strategy. Then it checks if our list with wait strategies, if it's empty, then we're going to add to it toExist wait strategy. This means that every time we will be sure we'll wait until the element exists on the screen. If we have more, and if we have changed this to be visible, to be clickable, to exist, etc., we're going to for each them, we're going to wait for all of them to happen. And just right then, we're going to call this native element, where we're going to search with the find strategy. This is the moment when we execute our strategy. If you remember, every strategy has 4 implementations of searching inside the app using the native wrap driver, or searching inside inside the wrapped element. That's it. This is how the magic works. Also, we have here all of the different find methods, but again, they're searching instead of inside the driver, we are looking inside the parent wrapped element. That's it. But all of the rest of the methods here, like get size, get location, hover, we are working with the wrapped element. This is how the lazy working is working. And the rest of the components, they are just deriving again from this base component adapter, the Android driver, and we are implementing some of the interfaces. If you remember, at the end we are going to discuss that, but we need them in order to have access to these validate methods that will wait for element to be disabled, to have a particular text, etc. And as you can see, we have different components: the button, checkbox, combo box, image, label, number, password. They're significantly simpler if we compare them with the web, because here you don't have so many attributes, right? And the actual possibility that you can do with Android driver, you're limited, right? Even you're more limited with iOS driver, but yeah. For example, as I said, these adapters, they can help you to simplify the usage, right? Like with the get number, we're getting the text, then it depends how this works, but for example, this number, it has an inner Android element, so this is why I'm finding it with class name, then we parse the number, then we return it as an integer. For the button, for example, we use type text. However, if we take a closer look and if you remember how this works, I put some of the common methods inside my Android component, the component adapter, but they are marked as protected, since we don't want to allow, for example, it doesn't make sense to type text inside an image, right? Or it doesn't make sense to have access to type text inside the label or a combo box. It depends on the combo box, but still, this is why they're protected. This means if you explicitly doesn't use the keyword new, you won't have access to them. And this is why I predefined the type text method. I use the keyword new, and then I call the base implementation using the base keyword. If I have something new, like for example in the checkbox, this is, I don't have it inside my Android component because I need it only here. I tried in all of the components to have the same naming, the same signature, similar to the web. For example, if we later add a similar module for working with Winamp driver for desktop, I will try to do absolutely the same, to have the similar architecture, the similar names of the methods, similar signatures, as long as it's possible, right? So I will return in a minute here to these components. I will just quickly explain again how these find methods work. Again, they're generic methods. This T component means that I can supply here all of these different types, even if you define them in your custom project. I can put here any component that it's deriving and has a base class, this Android component. I mentioned here the keyword new, this generic constraint, and this means that all of my components, they have an empty constructor. And if you remember, in my empty constructor, I'm just initializing the wrap driver and the list with strategies. And then we initialize here the correct find strategy. In this case, this is the ID. In this case, this is ID containing. And the whole magic is happening inside these two methods, where I accept a find strategy. Then we create, since we are sure with this constraint that this T component has an empty constructor, we call the empty constructor, we initialize the find strategy, we initialize the route driver, we return the component. But at this moment, if you remember the Android component here and its empty constructor, we are not calling anywhere finding of the elements. This is the big deal about the lazy loading. And lastly, if you remember, if we return to our framework version, here I have these validate methods. They are super specific regarding, for example, here I will have is visible, inner text, etc. However, if I change that to another type, imagine that this is a checkbox. And if I call, as you can see, the checkbox doesn't have a method click, which is logical. And if I call validate, now I have validate is checked, which I didn't have for my button, right? And the way this works is, again, we have these interfaces. I haven't implemented all of them, I haven't created all of them, but if you remember, we'll have disabled no matter what you want to validate, right? So, for example, for the button, we have interfaces for iDisabled and iText. For the checkbox now, I have disabled, checked, and text. And the way this works is that this checked interface, it means that I need to have a property here implemented for isChecked. And inside this assertions folder, I have these validate component extensions. The way this works is that I have all of those extension methods because they're basically put it inside the static class. These are static methods. We use this special syntax for the extension methods here with the this keyword. They're all of them. Right now, as you can see, T or T component is not the actual component. We're not mentioning that right now we need to derive from the Android component adapter, but instead I'm extending the interface itself. This means that all of the components that are implementing this particular interface, they will have access to these extension methods. And normally, as before, this validate method internally is using WebDriver wait, and it will wait until this condition is true for a particular amount of time, whether it's visible, whether it's checked, and we're going to throw a specific exception with this particular message here. This is another cool thing here with this particular message, and we can override the timeout because sometimes you may by default wait for 20 seconds, but in particular cases that you know that your application is slow, you can put longer timeouts. Yeah, that's it. As you can see, we covered all of it. The whole structure is pretty similar. It has some differences because of the specific of Appium, but right now we have two modules, web and mobile, that they follow a very similar structure, which is pretty awesome. We implemented again the adapter design pattern, the observer, we use strategies, we use factory methods, tons of design patterns. You can find in the links below the links to the playlist with design patterns. If you haven't watched this, I suggest to check it out. Also, if you're not familiar with NUnit, you will find a link to this playlist as well. Yeah, in the next module, we are going to cover responsive design testing, which will be a very important module where we are going to upgrade what we currently have to support execution in the grid, to support execution in the cloud. We'll add more settings in our attributes so that we can, for example, change the size of the application. We'll add some additional assertions to check and assert the layouts. We'll have these layout assertions. For the web, we'll have these style assertions. Many exciting things, so check it out. Hi guys, greetings from Bulgaria. I'm Anton, and in this module we're going to cover responsive design testing. This is a module part of our Advanced Test Automation Frameworks development course. But before we begin, hit the ring bell so that you get notified when new videos are published to the Lambda Test YouTube channel. Also, check the awesome Lambda Test blog, where you can find many detailed articles about automated testing. They can help you to be a much better test automation engineer. In the links below, you will find links to reference materials like articles and websites, and also a link to the GitHub repo of the framework. This is the GitHub repo, 𝑨𝒏𝒕𝒐𝒏 test framework, and I suggest to watch the modules sequentially, one by one. And for each particular module, we have a different branch from this GitHub repo. So right now, in this module, we're going to work with responsive design testing branch. So check out this one. I suggest to clone the repo, check out the branch, and work beside me while I explain the code, because it's quite a lot. It will be easier for you to follow. Now let's back. Also, below you will find some time links where you can jump into particular sections of the video if you want just to skip a particular part. I won't repeat the whole course overview, but again, I suggest to check all the modules sequentially. But first we defined the scope and the requirements for our framework. Then we built the web and the mobile core modules out of our framework. We extended it with plugin architecture, and right now we are configuring and executing our tests using attributes for controlling the native mobile applications and the browsers. And in this particular module, we are going to cover responsive design testing. So first, we are going to discuss shortly what this is. In the links below, you will find a link to a YouTube video where I explained it in much more details when we were covering Selenium, the new Selenium CDP integration by directional APIs. After that, we're going to upgrade our solution with local execution attribute to support mobile emulation. I'm going to use the Chromium engine for that. And later we're going to upgrade it to support as well execution in the Lambda Test Cloud for the web applications. We're going to create a layout assertion library. In a minute, I'm going to explain what is this. And this layout assertion library, it will also support these native and hybrid mobile applications that instead of running them on emulators, we're going to refactor our code to support executing these applications on real devices in the Lambda Test Cloud. Many things to cover, so let's get started. First, let's cover in short, discuss the responsive design testing. In order to do so, I'm going to open our favorite e-commerce playground website. Also, in the links below, you will find links to these two articles from the Lambda Test blog: responsive testing with examples and best practices, and responsive web design testing checklist, all you need to know. Of course, I summarized everything really shortly to explain it. But responsive web design automatically adjusts the website onto different screen sizes, resolutions, and orientation, like this one here. So if I'm on a 7.1 inch device, the elements should be scaled up automatically from what they would be on 5.5 inch device. Today, this practice has become more critical than ever as more and more people are viewing your website on different screens and devices. Again, here some of the features, as you can see, the order, the layout of the elements is different. We have 3 of them, and when we are on a smaller screen, everything is reordered, the layout is reordered. So there are several types of responsiveness testing that can be performed to ensure that the website is responsive and functions correctly on a variety of devices and screen sizes. The first one is visual regression testing, which is part of the regression testing that involves taking screenshots of a website on different devices and comparing them to ensure that the layout and the design are consistent across different screens. Of course, we cannot incorporate that into the framework, but basically the Lambda Test Cloud supports that. As you can see, I entered here the URL, the same URL that I showed you before, and I picked many different devices, mobile devices here, and the Lambda Test Cloud made these screenshots here that I can check later for this visual regression testing. Then we have the cross-browser testing, cross-browser compatibility testing. This is the most significant kind of front-end testing. We're going to implement that into our framework to support it so that we can determine if a website functions as intended when viewing using various browsers, devices, and operating systems. Actually, my tests were cutting some bugs. For example, this autocomplete here, it wasn't working on some of the devices, which is excellent because Lambda test put them on purpose, of course, on this website. Then we have, of course, the functional testing that we're going to do, that it's part of this cross-browser testing. We have performance testing, usability. We're going to talk about them in later modules. Now, let's focus on how we can implement, initially without the cloud, this type of mobile emulation into our framework. I already implemented that and I'm going to show you. I extended our local execution attribute here to support mobile emulation similar to Chrome. Now, as you can see, we have additional properties here: mobile emulation, device name, the different sizes, like that. I can change and pick from different sizes. I can pick for different user agents. In a minute, I'm going to explain what is the user agent. How I decided to put all of those here? Well, you can open developerschrome.com. I'm going to put that into the reference links. This is the developer documentation for Chrome, and they have a very, very good explanation about mobile emulation. They have some code here because, you know, Chrome driver is their main driver and suggest way for automating. This is why they have a native capability for simulating that. This means that we're going to use the Chromium driver that is supported by Chrome and Edge to do this type of emulation. As you can see, they allow us here to change the width, the height, the pixel ratio. The pixel ratio is very important. This is the density of the pixels for different mobile devices. We can change the user agent that I'm going to explain in a minute, and we can basically pick different devices here. This is the device name. So the way this works is I extended our browser configuration. If you remember, we had some constructors for controlling which is the browser, what is the life cycle, restart if started, reuse the browser, etc. Also, we had the execution type, whether this is a grid, Lambda test, or locally. For now, we'll keep it locally, but then we're going to implement the missing functionality. And now I added these new 5 properties: the size, pixel ratio that you saw, the device name, the user agent, and whether the mobile emulation is on and off. The size is just a regular struct that comes from .NET, which contains properties for width and height. Alright, after that we have a bunch of helper classes and enumerations. As you saw here, we have this enum called mobile, this class with, this is basically a class here, part of the browser execution namespace that contains all of the devices names that Chromium can emulate. Of course, there are much more, but for simplicity, I just pick a few of them. Most of the time, we're going to use this Galaxy S20 Ultra. Then we have 3 enumerations that are containing the most popular resolutions and sizes of phones. I just picked them from Google Analytics. We have a similar one for tablets and for desktop window sizes. Of course, you can extend that. You can bring your own custom sizes. It's up to you. Also, we have one more class here, Window Size Resolver here. This is a utility class that works with these enumerations. And usually, if we check Lambda test and in other places, they don't accept the size, but instead they are working with something like these strings, where we, basically this means this is a typical resolution string, right? And in some cases, in some instances, we will have to use this type of strings. In other cases, like the native WebDriver, it works with this struct, which is size. This is why I have a few methods. The first one accepts this particular string with X and separates them and initializes the size. Also, we have three static methods that accepts our enumerations using a switch statement to initialize the proper size struct here. We have the same for accepting the mobile window size and the same for the tablet. And also we have one extension method to the size struct that it's converting the size back to this string resolution. That's it. After that, I extended further. I added a few constructors to our 𝐜𝐸 execution attribute here. We have new constructors. Don't worry, in the next video when we talk about global settings, whether this is with options classes or with setting files, we're going to remove all of those constructors, and instead we'll have separate options classes, settings classes, and and we're going to use the options design pattern. But yeah, we have these constructors here that accepts now, as you can see, the three enumerations, and also if it's a mobile or tablet, we have the pixel ratio and the user agent. And yeah, basically we are initializing this browser configuration. The next big part, we're not changing at all here the browser lifecycle plugin. However, we need some changes to our driver factory. In our driver factory, we have now a new line, this line here, that basically has a new method called initialize mobile emulation options. As you can see, we are accepting the browser configuration. And if we go inside, this is a private static method here. It's returning Chromium mobile emulation device settings. This is a special class that if we hover, you will see that it comes from the Selenium NuGet package. And what we do, if the mobile emulation is on or it's true, then we are initializing this to, we're creating a new instance of this Chromium mobile emulation device settings, and we are initializing the user agent, the width, the height, the enabled touch, and the pixel ratio. I forgot to mention about the mobile user agents. This is another class with these long strings here. What is the user agent? The user agent is a string, is a text string that a web browser or other client sends to a web server in the HTTP headers of a request. This string identifies the client software making the request and provides information about the client, such as the browser type, the operating system, and the device. As you can see, we have the device, we have also the operating system here, etc. And the web server can use the user agent string to tailor the responses based on the capabilities of the client. Many often, especially in the front-end JavaScript files, especially for older browsers like Internet Explorer, it's very typical to base your CSS logic, for example, or JavaScript based on these user agents and reorder the elements differently or style them differently, etc. Because some browsers are not supporting everything, for example, for new CSS, etc. And the practical usage of this is that we can emulate different devices like mobile against desktop to test responsive designs. We can simulate different browser versions to ensure compatibility. We can check how different user agents affect the behavior and rendering of your web application. And yeah, by setting a custom user agent string, you can effectively test and debug your web application under various conditions, ensuring a consistent user experience across different devices and browsers. All right. Next, let's return to the driver factory here. So we are initializing all the user agent, the width, the height, enabling touch events, and the pixel ratio. That's fine. And then if we return to our start method here, you will notice that this mobile emulation, this if here with a mobile emulation is enabled or not, we are initializing Edge and Chrome options, both, because this is supported only for Chromium. You can later, under the Firefox cases here and Safari, you can throw unsupported exception. And the Chrome options here, they have this special method, enable mobile emulation, that accepts the mobile emulation options that we initialized and the device name. That's it. And after that, everything works like we're executing on a particular mobile device. Let me show you right now. Again, we extended the whole execution. This means that I put it here a breakpoint point, debug point, and I'm going to debug my test. Mobile emulation here is on. And let's see it in action. The rebuild happened, and we are waiting, just a few seconds. Now you'll see that the browser is open full screen now. However, as you can see here, we're in mobile emulation, and the site was emulated on this particular mobile device. Everything was reordered, the layout is different, and we can later now implement further, do the layout testing. In order to implement the layout testing library, what we are going to do? Again, the layout testing, we can do it together with style testing. This is very important because many often styles will be different, but they are really important for when you check them on different mobile devices. Whether, for example, you have the same font, the font size, etc. In our library, we want to check that this particular input is on top of this dropdown, that this button is below this dropdown, that, for example, this list is right of this grid, or that these two buttons are aligned horizontally, or that these two are aligned vertically. So how we can do that? Again, we want this library to be available not only for checking websites, but also it's absolutely valid if we execute our native application on a mobile device. It will be important for you to again do this type of layout testing, especially when you use the app service for rotating the phone, and all the elements will be reordered, and this should work properly. Or some application is forbidden, to be changed, their layout to be changed. So the way this works is, let me stop the debugging, is that I already created such a test. Let's see how our library works, and then I'm going to explain how I implemented it. But yeah, I have page objects here. And one more trick, by the way, you will notice that here I have a mobile homepage, and here I have a regular homepage. What is the difference and why I have two versions of my homepage? Well, many often, since the page is reordered, some elements are visible only on mobile, some elements are visible only for the regular page. This is exactly what is happening in our case. For example, here, the locator for this button is different than the locator here. The same is valid for this input. This, as you can see, we have three elements. The first element located, as you can see, the first right now is not actually the first one here is our search. However, the same locator is not working. As you can see, the first one is not here, but it's the second one. So again, and if you check the button, it's totally different locator that you cannot find it with this XPath. So some frameworks, like for example Tata or doing your research, if you watch the first module, they support different syntax for searching for that. For example, here some of the frameworks are using attributes for mentioning which are the locators, or they have different methods for chaining different locators if one is not working but the other. I don't want to overcomplicate the framework. This is why I left it like this. I prefer to have base pages where maybe these properties can be abstract and you can just re-implement them for the mobile and for regular version. Right now I just copy paste them and switch the locators, but usually the approach is that you have one base page that will be the base for the mobile and then for the desktop version of your page. That's it. And all of the methods probably will stay the same. However, again, on a mobile view, most of the cases you don't have autocomplete. So even the actions are a little bit different. The behavior is different. Again, there might be some bugs right now. If you run the test on mobile emulation, you will see that some of the functions of our website are not working. And this totally makes sense. This is why we are doing this responsive design testing. Now let's return to our tests. If you remember, the layout library, it needs to check whether a particular element is on top of another element or below it or right of or left of, or we can check the height or the width, or we can even check the whether the elements are aligned horizontally or vertically. I implemented just part of it. I have two versions. I'm going to explain only the first, and I'm going to show you how the second works. The first version that you see here, it contains some extension methods to my elements. And each element out of my library, when I add this using here for the layout, Polaris core layout, this will add these assertions and they will become available to me. We can say this particular element is above of this select. Or I have a few overloads for example, saying above of, greater than, and then I can provide pixels here, exact pixels. Or assert below of something, then provide other pixels. We have many overloads like greater than, greater or equal than, less than equal, approximately, etc. There are a lot of overloads, as you'll see in a minute. Also we have similar assert methods for checking whether an element is right of something or left of something. And we have also methods for checking the height of the element and the width of the element. Again, with checking with pixels. And this will be especially important, again, when you run the test against different, for example, mobile web browsers or screen resolutions. Even it will be one thing on one laptop, it will be totally different on a 24 inches monitor, right? And then the second version is using a Fluent syntax. It's using a Fluent builder. If you check one of the videos about Selenium on the Lambda Test YouTube channel, I already explained that in Java. Here you can check the code yourself. Again, it's a little bit more complex and we won't have the time. If you prefer this Fluent syntax, every time we will have to call validate. However, the code is significantly less because this was implemented only in, I think, 5 files, 6 files, and here we have many of them, as you'll see in a minute. And here we have much less number of methods because we don't have all of those overloads, but instead we have like chaining methods. For example, you have equal, you have greater than or equal. Basically, by calling these additional methods, you can supply the different pixels. And yeah, as you can see here, we are running the mobile emulation on Galaxy S20 on this particular screen size. etc. Let's see how this works. Let's execute this test. And since I want this library to be available for my mobile test as well, as you can see, the test failed for some reason. Element was not interactable. Anyway, sometimes this happens. Actually, this is the one that I want to show you. It's different again, and here we have also this assertion library. In a minute we're going to see how this works, but again I'm going to explain how this works. We're going to check the CSS properties for all of them. For the border color, for font family, actually here we call the bug because, as I told you, there is a bug in the responsiveness. But yeah, here we implemented that for the home page for this particular resolution, and I asserted the border color, the font family, the font size, the font weight, and the text outline. In a minute I'm going to show you how this works. I implemented absolutely the same, but for our mobile framework here. And let me show you. In a minute, in the second part, I'm going to show you how this lambda test attribute is working, but this will allow us to execute our native apps into the lambda test cloud, which is quite awesome. But also, as you can see, I can execute them again in lambda test, but I can start a separate activity or open a particular view. And after that, I have very similar, no matter that I'm working right now with totally different components. They're actually mobile. As you will see, we are going to reuse this layout library for both syntaxes, for mobile and for web as well. We have similar methods: assert above, greater than, less than. Also, we have this additional aside. As you can see, we can provide any number of elements here to check whether they are aligned horizontally or vertically, or centered or right, etc. And we can assert the height and the width. How this is possible, this to be like available for both? Well, I created this namespace here called layout. It's inside our Polaris core framework. We have version 1 and version 2. Again, you can compare the size, and I haven't even implemented all of the methods for this version here. Again, this version is simpler. This is a little bit more advanced because we are using fluent builder pattern. It contains a lot of delegates, functions. This is why it's a little bit more complex. If you're interested in that, you can again read about this fluent builder pattern. We implemented something similar when we were talking about builder design pattern on the Lambda Test YouTube channel. I will put the link below. Now, for our first version, it's really simple. Again, as you can see, it's in the core project. We're not copying it in web and mobile. It's actually containing static classes, and actually all of those files here, they're the same class because this is a partial class. All of them are the same class, but they're partial. Again, I'm doing that because it's easier for me if I want to add something to a particular file or fix something. It's easier for me to orient myself instead of putting everything inside a single file. You will notice that they're extending this iLayout component interface. We're not working with web components or Android components or with any of the native elements. And this is actually how we are achieving this reusability among the two core modules of our framework. If we open this iLayout component interface, you will notice that the only thing that this iLayout component has is the point and the size. You know already the size. This is the height and the width. And the point is actually, again, a struct from .NET that contains the X and Y coordinates of the element. Again, both the Android native element and the iWeb element, both of them have these two, the point and the size. This is why inside our component adapter, actually in our iComponent first interface, we're deriving from this iLayout component. We're doing the same for the mobile interfaces here. We're deriving from the iLayout component. This means that my Android component now needs to implement the iLayout component. And as you can see here, I added these two properties. It's the same thing for the web component. Right now, in my web component adapters and the Android component adapter, I have these two properties: point, which is the location, and the size. That's it. That's the only thing that I need to change into my two projects here. After that, if I add this namespace, the using to it, all of those methods will be available for me. The way this works is that we have a very simple assertion here that, as you can see, we are calculating the actual distance. I'm not going to overcomplicate the explanations now with all of these calculations, but they are very simple calculations regarding the coordinates about X and Y and how they are rendered on the browser. You can read that into on the WebDriver in the APM documentations. But in this utilities class here, it contains only a few of those calculation methods, while calculating the right distance, the left distance, the above distance. Again, as you can see, we're just the calculation is slightly different. And then when we calculate the distance like that or below, if this is not true, then we are going to provide this message. This particular element should be below of this element, but was something else as pixels. So this means that we will have a very nice explanation message what failed. So this is, and additionally we have this layout assertion static class layout assert that again it contains some complex calculations here, but it's basically for reaching all the layouts that we provided as params. This means that this params keyword, it allows you to provide any number of parameters here. And as you can see, we are providing them as an array, but we're just separating them by commas when we use that. So this is the layout library. Next, let's focus on implementing the web quality execution. I already showed you the lambda test attribute, right? The one for the demo website. Right here, I have this lambda test attribute. This allows me to execute my test in the lambda test cloud. Again, mentioning the browser version, and even mentioning here the desktop, the resolution itself. The way this works is, again, I can show you that our tests already have been executed in the lambda test cloud. Here is the web execution. It's quite excellent because, as you can see, I can pick any configuration as I want, any operating system and any resolution. And on top of that, I will have all of the commands. I will have this very nice video of what happens and how it works. Yeah, and we can do the same for the mobile app execution. I'm going to achieve the same for the executing of our native apps. As you can see here, I executed that on Pixel 4 Android version 13 for 9 seconds. And as you can see, we can see all of the APM commands here, and we can see a video of what our test is doing, which is excellent. We are opening it, we're clicking on the buttons, on the checkboxes, that's it. And also we will have, we will execute similarly on a mobile web browser the same test for asserting our website, which will be quite awesome, right? So how this works. In our web project now, inside the plugins, I have created additional attribute called lambda test attribute. As you can see, we have a lot of new configurations. Why is that? In order to configure that, you can open this lambda test capabilities generator. We have two options. We are going to use both of them for Selenium and for Appium. Let's begin with the Selenium one. We're going to use the new Selenium 4 syntax, 𝑨𝒏𝒕𝒐𝒏, as you can see here. And then you have some advanced capabilities like changing the operating system. You can pick between many different browser and browser versions if you need to support other ones. Again, you can change the resolution, which will be something that we are going to do. This added this particular line. And as you can see, the way this works is that we are not adding them all of them to the Chrome options, but instead we need to create this dictionary of strings of objects, initialize this dictionary, and provide the username, the access key, and also an important one is this options name of this capability of this option, and providing the dictionary here. The same thing goes for when we work with Appium. For Appium, as you can see, you have different operating systems, iOS and Android. For now, we support only Android. This is why we can pick among different devices. I'm going to use Pixel version 13. Also, you need to upload your application. When you upload it to Lambda test, this URL will be given to you. This will be your unique URL to your application. I have already uploaded to my trial account this demo application, and we have the URL to it. And as you can see, it's very simple. We need to provide the Android, the platform name, the device name, the platform version, and whether this is a real mobile. And we are going to work only with real mobile phones. Now, I have created additional configuration that it's under this configuration folder. It's called grid configuration. We have the provider name. In our case, this will be equal to lambda test. We have this options name. This is LT. If you remember here, if we switch to 𝑨𝒏𝒕𝒐𝒏 protocol, we have this LT options. This will be the options name. We have the URL, which will be the specific. Both URLs are different for the two clouds, whether it's mobile or web. And then we have this special dictionary with string and object. Now, when we have this grid option, it's absolutely the same for the mobile. Again, we have one attribute for the grid. Again, if you don't want to lose lambda test, some people prefer to use their native Selenium grid, using it on Docker in Kubernetes, which is fine. But again, don't think that this is free. It's not free, because when you host it on your own machines or in your cloud, you're paying money for it, and then you spend a lot of time when you need to maintain that. In my experience, usually the many times when we decided to maintain it ourselves, usually this is much more expensive than to use some of these native clouds. This is why usually we use lambda test. But again, it will be, you need to calculate that and see whether this works for you. Again, if you're using native Selenium grid, you can use this grid URL. You can provide the browser and the browser version, and after that you can configure here the grid configuration. But the most important thing is that this grid attribute is containing this property here for the grid settings. And after that, again, this grid attribute is deriving from our vocal execution attribute. This means that it has access already to all of the previous settings. And after that, we have the lambda test attribute. And this lambda test attribute, as you can see, We provide the browser version, the desktop size. We have some default values. This means that you don't need to supply them later. And we are initializing, we are converting this browser version string. If it's 0, which is easier to provide it as an integer. If it's equal or less than 0, then we provide latest, or we're converting it to string. Then we're initializing the browser configuration with some default values. Execution, actually here we need to switch to lambda test. This was a bug. And then we are initializing the grid settings. We are initializing the options to LT options. We are getting the username and the access key from the environmental variables. We are building the URL. We are converting the resolution to a string. As I told you, here we need it in this special syntax with the width and the height and x. And then we have some default values for the arguments. Of course, later we can extend our framework to be able to add additional options here or to be able to change that. I'm going to teach you how to do that next time when we have global settings, files, and configuration classes. So when we execute, when we configure that lambda test attribute, we can put it on top of our classes here in our tests like that right now. And if we execute that, this will be executed in our lambda test grid. If I run that, you will see that this will be executed in my lambda test account. As you can see, it was refreshed automatically, and it will start executing on the particular version. All right. As you can see, we are executing the same test on the lambda test web. But the way this works is that I extended my browser lifecycle plugin. Basically now I have here a field that is referencing my grid configuration. And also below that, as you can see, we have two additional methods that are using a reflection to check whether we have these two attributes, lambda test attribute. And we are checking, do we have a class level? If we have it on class level, but if we have it on a method level on top of the test, this means that the test level attribute will override the class level attribute. And then we are going to return the grid configuration, getting the property. And after that, we are just providing, and as you can see before, here we were throwing not supported exception. Right now, we have a new method called start grid. The way this works is that inside this driver factory, in our driver factory here, we have a new method called start grid. It accepts now the browser configuration and the grid configuration. We are initializing the options. Basically, this class will just return Chrome options, Firefox options, etc. And the important method here is this grid options, which will just return. It will initialize this string object, and it will add it using the options name. In our case, this will be the LT options that I showed you before that were important to us, not from here, but from the capabilities generator right here. This one will add this dictionary to the capabilities, to the options. All right, and what else? We are initializing the grid execution, initializing now a remote web driver instead of Chrome driver or Firefox driver, and we maximize the window. That's it. That's the only thing that we need to do to start it into grid mode. I did something very similar for mobile apps. Again, you will notice that I have a very similar attribute here for Android. So for the mobile version, we have Under the plugins namespace, we have app configuration. This app configuration now, it contains a property to the grid settings. And we have the lambda test attribute that again derives from the grid attribute. And here the only thing that it's different is that these settings arguments here are a little bit different for mobile, right? We're mentioning that this is a real device, that basically we're auto-granting permissions, etc. And besides that, in our app lifecycle plugin, it works in a similar fashion. We added these two additional methods for our attributes. And into the driver factory, again, we have this grid mode where there are two specifics, by the way. If we execute into the cloud on mobile web device, then we just need to, instead of providing the app path, we just need to initialize the browser name. Otherwise, we need to provide the path to the application and add these capabilities for app package and app activity. In case we have this specific string, which, if you remember, this is part of the URL to the app itself that was uploaded to Lambda test, then we are initializing it like that. Or in case we are working with local grid, in Selenium grid, then we're working with our regular approach, building the path from the resources folder. After that, we just initialize here. We are adding the grid options, and then we are initializing normally the Android driver. That's it. Now, in order our web stuff to be executed on mobile web browser, as you can see here, I again used this attribute lambda test, mentioning the Android version, the device name, Pixel 6, and right now it's different because we are missing the app package and the app activity, but I have that we are using that this is a web test, right? By default, we are going to run it on a Chrome. And as you can see, right now we're working with our mobile library. However, everywhere, as you can see, we're using this iWeb service. If you remember from the previous module, we defined that, and we're combining both the mobile and the web. And the way this works is that, again, I copied the same mobile test here, right here. If I run it into the cloud, you'll see that under web application right now, this will be executed on Pixel 6 version 13 on this particular resolution, which is awesome. We are using the exact same, as you can see here, is our web browser is opening on a real device, which is Pixel 6 on this version. This is quite awesome because otherwise, if you use a regular APM server, this is much harder to configure. Imagine that for every device, we have a different Chrome binary, different version of the browser. This means that depending on your emulator, you need to download the specific Chrome driver binary and provide it here. Or if you execute that through to code, if you start the server, then you need to provide here the exact proper driver version. For example, if your Pixel 6 is requiring Chrome driver version 120, then you need to provide the proper driver here. If you use S20 device, then here, I don't know, maybe you need to provide Chrome 125, because otherwise when you use the emulators, you cannot control or update the browsers. And you need to do this by hand. It's a lot of maintainability. However, when you execute that in the Lambda Test Cloud, this is awesome. They are doing this out of the box for you, which is quite awesome. I really like that. And the way this works, I extended a little bit our web interface now to support if we open here, I added, as you can see here, the availability to create pages. And right now we are using the same page objects that we were using for our web tests, but we're working with them in here with mobile web tests. This is quite awesome, right? Again, we're using totally the same page objects with app elements, with all of that, right? I did a few changes to our driver adapter here for the mobile. I just added this line here where we are initializing the driver factory wrap driver to the Android driver. This was the only change that I did, and this works out of the box for you. We are combining both modules, which is quite awesome. And this will work also for hybrid applications, which, as you know, they're not like native Android applications, but they're loading like a native application. But beneath that, when you work with all of the elements on the screen, they're actually rendered in a web view, many often using, for example, React Native or Xamarin or similar technologies. I have tested that. I was like half a year ago, I was involved in such a project where we use React Native and Xamarin, both of them, and this is working like a charm out of the box directly in the Lambda Test Cloud, which is quite awesome. Yeah, I think we covered everything that I wanted to show you. We looked and discussed what is the responsive design testing and why it's really important. We implemented this type of emulation using extending our local execution attributes and the browser plugin and the app plugin. Again, if you have the chance, always prefer to use real devices. Sometimes there are some glitches with the emulators. There are some troubles, especially if you're working with Android emulators. Sometimes they are crashing, you need to maintain them. The same is valid for web emulation. It's not always absolutely accurate as real devices. And yeah, you saw how we can execute the tests in the Lambda Test Cloud, both for web, both for native and hybrid applications, and how we can reuse our web module inside and combining it with our mobile module to execute our web tests together with the layout library into real mobile devices. Next, we are going to talk about configuration management, which will be quite important. Instead of hard coding a lot of these magic numbers everywhere, especially about the timeout settings, but also this is really important when we want to execute our tests on different test environments like staging, QA, development, etc. Or when you have different configurations for the various mobile devices. So wait for the next module. Hi guys, greetings from Bulgaria. This will be our next module out of our Advanced Test Automation Frameworks Development course. Before we begin, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published. Also check the awesome Lambda Test blog because there are so many detailed articles about automated testing, and they will definitely help you to become a much better test automation engineer. In the links below, you will find all of the relevant resources like articles and websites, and also the GitHub repo for the framework. I suggest to clone the repo and work with me and check the code while I give my explanations. And as for the rest of the modules, I'm not creating a separate repository for each of the modules, but instead I'm creating different branches for this framework because we are upgrading the solution, and you will have access to all of the upgrades bit by bit. So in this particular video, you need to clone and check out this configuration management branch. Also in the links below you will find jump links to particular parts of the video if you want just to skip some or etc. So let's begin. I won't again repeating the whole course overview, but before we begin I suggest you to check all of the modules one by one if you haven't done so. We define the scope and the requirements for our framework. I explain a system for picking and deciding whether you need to create a framework or not. Then we built some modules about web, mobile, we upgraded them through plugin architecture, and we upgraded the solution further for allowing the framework to execute mobile and web tests in the cloud and doing a responsive and layout testing. And now it's time to further upgrade our framework and support global settings, global configurations through files or some, let's say, coded approach with the settings. Why this is important? This is important because, for example, for websites, many often we have, almost always, we have different test environments like staging, QA, production, local environment, or like in an enterprise project that I'm part of right now, before release, the application is deployed to multiple compatibility instances where we need to check that everything is all right. We have different URLs, different performance, different timeouts are needed, and other settings are different basically. So we need a way for us to have these different settings instead of hard coding them in the code. An easy way. We can do that through static classes. I'm going to show you that, and also through JSON files. And we are going to use a pattern called options design pattern. Actually, partially we use it, but we haven't implemented it fully. In a second, I'm going to explain what is this. This is also important for our mobile module because as you saw in the last module when we were talking about responsive testing, especially on mobile devices, no matter whether this is a native application or a website that you need to check on real mobile devices, we have a lot of configurations between operating system, mobile devices versions, versions of browsers, browser types, etc. So we have tons of configurations that especially for hybrid apps or native apps, we need to check them on so many devices. And this is how we are going again to utilize this capability of the framework to be able to configure this globally. Why we're researching two different ways of doing that? Because depending on multiple factors, one of the solutions may be better than the other. At the end of the module, we're going to compare these two approaches. For example, the implementation with static classes, it will be a better option if you don't have so many tests, if not so many teams are using the framework. For example, if you're working in a single repository. However, if we have a more complex architecture where we have so many teams distributed around the globe, if they're using our framework as a Git submodule, and we need the flexibility to add additional settings to our files or classes, then probably the solution with JSON files will be better. But again, we're going to compare them in much more details when you see the actual implementations of those two approaches. Now, let's see and talk about the options design pattern. Here is a sample diagram. The options design pattern is a creational design pattern and is used primarily to simplify the configuration of complex objects. It involves the use of a class, often referred to as an options or configuration class or settings. I will use settings in our case. And it encapsulates all of the configuration settings required to initialize or customize a particular object. This pattern allows for more flexible and readable way to manage optional parameters and default values. Again, we already use it. Just in short, I'm going to show you that. We already had a similar class called browser configuration that holds now it holds the browser, the browser version, the life cycle, whether we need to restart the browser every time or reuse it, the execution time, whether it's grid or local, the size, etc. So this is basically an option class, but again, as I said, we are partially implementing it because here we don't have default values. Actually, the default values are initialized partially in some of the constructors and inside our attributes, like for example our lambda test attribute. Here, as you can see, we are initializing a lot of the default values for the grid settings. And some of the key characteristics of this options design pattern is that we are already doing that. We are encapsulating all configuration settings within this single class. Instead of passing 7 or 8 parameters to constructors or methods. Also, we have the default values. Again, this is partially done, but it will allow this sensible default values for each configuration setting, reducing the need for these overload constructors like we have them right now. Like right here, we will reduce the count of these constructors. Many often immutability is achieved through usage of, for example, records or immutability types. Right now we don't have a fluent interface, but we are going frequently, it's implemented with a fluent interface similar to the actions class or builder classes, and this will enable chain of method calls for setting different configuration options. We're going to do that for the static version. And separating the configuration logic from business logic, this will enhance the maintainability and readability. And if we return to the diagram, this will be what we're going to try to do, at least for the static version. We're going to create a separate settings classes that we are going to use them as static properties. This will be the web settings and the Android settings. They will hold all of the relevant settings. And also, we are going to use Fluent interface for exposing 2 more related settings, timeouts and grid settings. And we are going to use them through Fluent interface through these static classes. However, in order to achieve these different settings for the different environments, we need this class here, configuration loader. It will be responsible to read from an environmental variable or .NET profile. I'm going to explain a little bit later what is this. Through these profiles or environmental variables, we will switch configurations. And these methods here, they will initialize differently our static classes. Later, through this static class, we're going to use our settings. So let's get started and see how we are going to implement this static classes version of the settings. Right now, again, I will leave in order to skip some problems with the refactoring. I will leave now the browser configuration. I will leave those classes here. Instead, I'm going to create a new folder here called settings. And in this settings folder, we're going to create 2 namespaces. The first namespace will be file implementation and one more for the version that we're going to use now, implement now, static implementation. We're going to do absolutely the same for the mobile. Here we will have a similar namespaces. So right now, as I told you, we will need these settings, the static version. We will start with this web settings. In this web settings class, we will put all relevant, all other configuration properties that we need. For example, we will have access to the execution type. In order to implement fully the options design pattern, right now, as you can see here, I'm initializing a default value, right? I'm setting that the execution type is lambda test. Our web settings class, you'll see when we talk about the file version, will be slightly different because when we work with text files, JSON files, all of the properties will be strings. But here we have the other possibility to work with different enumerations that we have defined, which is excellent. We have now the default life cycle. I said that the default value will be restart every time. And what else? Also, we have the default browser, which will be Chrome. We have the browser version. And what we are missing, if we look into again our plugins, for example here, and if we see the browser configuration, you'll notice that the last time when we were working and configuring our local execution attribute to support emulation, so we need to have that as well. So I'm going to copy those, and we'll have to assign them some default values. Again, we need to make them static. We need to add a using to the drawing, and I'm going to make all of them static, right? Right now we are not fully implementing the options design pattern. In order to do that, for the size, if you remember, we have a class that it's called Windows Size Resolver. This Windows Size Resolver have a method Windows Size, which accepts our enumeration, which is this desktop window size, and based on it, it will return, like here, it will return this size object. And this enumeration, it just contains all the versions. For the pixel ratio, let's say that it will be 1. For the default device name, again, we have mobile devices. Here, I will assign it to Galaxy's S20 Ultra. Again, this is just a class with all of the constants, which are all the devices' names, which will be used for responsive testing. For the user agents, we have mobile user agents. Again, I will set it to Samsung Galaxy Ultra. And for mobile emulation, by default, I will turn it off. For now, this will be our web settings. However, I'm going to create one more class right here in the static implementation. I'm going to name this particular class timeout settings. What these timeout settings will hold? If we look here in our wait strategy, you will notice that every time we are hard-coding these magic numbers here, 62 seconds for the sleep interval. We have specific timeout for the strategy about to be clickable. We have totally different timeout here for validate methods. Right here, again, we're hard-coding that, but this is not the best practice, right, to have all of those magic numbers. So on multiple places, we just hard-coded all those numbers, and we don't want that, and we want to have the flexibility to update those timeouts based on our instance, on our test environment. So in order to do that, first we will expose 3 timeouts that are part. These 2 timeouts are part of the WebDriver. We have the page roll timeout and the script timeout. And you'll say, wait a minute, what is this 30? What this means? These are 30 seconds. However, it won't be clear, I mean, if it's just an integer, what we need to assign here. One of the ways to solve that is to rename this property to seconds here. And this will mean that when you assign a number, it will be in seconds. When we pass it to timeout, this will be version 1. Second version will be to use here this type of a summary. And this means that, for example, if I may make this property static, and if we use here this static property, let's make a constructor so that I can show you. Timeout settings, and as you can see, if I hover now, this page wall time, it says, if you see, get or sets the page wall time in seconds. So this type of summaries, they're really great because they can suggest what type of integer is that. So I would suggest if you use integers, do that. I mean, place this type of summaries and explain that these are not milliseconds, but these are seconds. Also, I'm not going to make that static. In a second, I'm going to explain why. Another option, instead of every time using this type of casts here, because everywhere we need time span, right? This is a special class in C#. Why we don't just make our timeout settings, all of the properties to be time span? This means that here, as default value, I can say time span from seconds, make it 30. Again, just for simplicity for now, I will leave the rest integers, but you got what I mean. Maybe it's worth making them time span. So I will add two more: wait for Ajax timeout and sleep interval. This wait for Ajax, if you remember, it's part of our browser driver adapter right here, where we are using WebDriver wait. And here again, we have these magic numbers, and we don't want that. We need to refactor this later when we have our settings classes. And for all of our wait strategies, we'll have separate settings for that. For example, element to be visible timeout, element to exist, not to exist. As you can see, not to exist and not be visible, they are short timeouts, they are just 10 seconds. This will be our timeout class. And I will have one more. This one more will be called grid settings. I'm going to create it right now. So these grid settings, it will be very, very similar to, and later I'm going to delete this grid configuration that we had before. It will be similar to this one. Again, on purpose, I'm not making it static. In a minute, I'm going to explain why. Again, here the provider name by default will be Lambda test. If you remember, the options name is this AOT options. This is the thing that we basically supply here with this new, if we switch to C#, when we use Selenium 4, and if we use the capability for 𝐓𝒏𝒕𝒐𝒏 protocol, we need to add this as additional option, options name, and then all the capabilities. This is why we need that. For the URL, we are going to replace that later, but this will be the Lambda test URL here. You can change that if you use something else. And for the options, I'm going to copy the default values from our Lambda test attribute. As you can see here, we are already initializing, as I said, we are partially implementing the options design pattern, but we are doing that inside our attribute. However, I'm going to fully implement our pattern, and this will simplify our attributes later. So right here, I'm going to basically initialize it to a new dictionary of string object, and we'll have all those default values right here. Now, since it will be one of the things to consider, if we have multiple of those settings classes and all of them are static, it will be really confusing, and you have to know that we have so many of them, right? Because they can be 10 settings classes, but you need to know, if they are static, you need to know the exact name and that this particular class exists. Instead, as I explained, many often we implement fluent interface, meaning that we use web settings dot timeout settings dot something. However, if everything here is static, we won't be able to do that. Instead, this is why all the statics properties will be only in our web settings class. And in order to access the timeout settings and the grid settings, I'm going to, since all of their properties are not static, we're going to access them like this. We have a static property inside our web settings that it's returning just timeout settings and grid settings. This will be initialized with all of the default values, which is excellent, and the same for the grid settings. And now, if we need to use the web settings, it will be quite easy. If I go to my to here, I can say web settings, timeout settings, and then element to be clickable timeout. Again, this right now is integer, but I can return time span here, and I can say time span from seconds 30. You see the benefit now. Again, instead of every time calling time span from seconds, we are hiding that in the options class, which is awesome, and we can use the settings like that. If we need grid settings now, in a minute, let's refactor, for example, our browser lifecycle plugin. This is another benefit. If you remember, if we look into our web tests before that are here, right here in the product purchase tests, right now, until now, we could place this attribute and override the browser, whether the lifecycle, whether this is restarting it every time or reuse it, to use mobile emulation, etc., all of that. And this will be reused for all of the tests. However, if you want a specific test to execute on different browser, let's say here we want Edge, that's fine, and we want something else, reuse if started, we can do that. And also I can place here the lambda test attribute as well. However, imagine that we have, I don't know, maybe 100 of these test classes. I don't want everywhere to switch that. Especially the same is valid for mobile devices. I don't want that. And by default, I want to make our browser lifecycle plugin. If I don't place specifically these attributes, I want this configuration to be loaded from my default settings, from the web settings class. And in order to achieve that, we need to refactor our browser lifecycle plugin. If you remember, we're using here some reflection to get the lambda test attribute or the local execution. And from there, we are initializing these two configurations, the browser configuration and the grid configuration. So in order to support what will happen if we don't place the two attributes on top of the class or on top of the test, this means that these two classes here, both of these values will be null. This means that this configuration will be null. And this means that in this case, we can say like that. If the browser configuration is null, then we can initialize it. We can initialize that from the web settings. Again, from in order to simplify the refactoring, I left our browser configuration file later. Maybe you can not use it, but again, I prefer not to refactor my core logic for reading directly the web settings. I prefer to leave it like using the app configuration and the browser configuration. And right now, if we don't place the two attributes, and if this is null, then we are creating a new browser configuration and we are initializing it from the default values inside our web settings, which is excellent. And we can do something very similar. If here we don't have lambda test attribute, and if this is null, then all right, we are initializing the grid configuration like that. We are reading the grid settings, the provider name, and all of that. Excellent. And we'll have the provider name, the URL, the options name, all of the arguments and everything. And we can continue doing this type of refactoring everywhere. Now, until now, we just have default values, but for our local execution. How to implement If we return, if you remember, here we haven't yet implemented this configuration folder. Let's see how we can do that. This configuration folder again is responsible for having different web settings for the various configurations. How we are going to switch the configurations before implementing the configuration configuration class? Well, in our test project here, these demo tests, I'm going to create a new JSON file. This is a very popular approach in .NET. I'm going to use this launch setting JSON. This is very popular for especially when we create websites using .NET, but I'm going to modify that and use it in our framework. So I'm going to create these launch settings. And these launch settings will define a few profiles. These profiles will give us this command name, project, not project, but development, then staging, and then here actually these are the names that we are going to use for the switch. And then later when you run your test through the command line, you need to call .NET test launch profile development. And then by default, .NET will initialize this particular environmental variable to development, staging, and production. And now inside our configuration folder, we can read this particular environmental variable and based on it load different settings. Let's see how this works. Again, we need to create a new class inside our settings folder here that I'm going to name configuration folder. Here is the configuration folder. I'm going to make it public. And again, here in a minute I'm going to present to you the implementation of those classes. But what we do here? Well, I'm reading the environmental variable that I told you. If it's not set, we'll just get development. And based on this environmental variable and its value, we have a switch, very easy. Based on the switch, we have three methods. These three methods will be responsible for initializing the default values for all of the environments, like that. Of course, we change that to be a time span. This means that here I need to change that to 60 seconds. And of course, you need to refactor those everywhere. Here it will be 45. Visual Studio is suggesting how to fix that. Alright, so everywhere, if you refactor those to be time span, then you have to fix that everywhere. But again, based on the environmental variable, we're executing, for example, staging. Let's say that I want to execute all the tests on the staging. This means that this method will be executed. As you can see, we are calling the static web settings class with all the basically I'm saying that this time I want to execute everything inside Lambda test, which is fine. While our QA environment is executed locally. So on Lambda test, I'm saying please restart it every time, while locally we can reuse the browser. Here I switch the browser to Firefox, and here I use Chrome. We can change the version. I change basically here the pixel ratio, but actually we don't need even to set all of those since the mobile emulation is false. I have different timeouts for different environments, which is excellent. And depending whether I have a local execution or not, as you can see here, the grid settings are now, but here we initialize them for Lambda test. And I did the same for the development environment as well. And this is excellent. If you have more, then you have to define a new method here and a new switch. This is the only thing that you have to change. After that, the switch is just through these launch profiles. That's it. I did absolutely the same refactoring, but we won't spend the time now to refactor everything. for the Android, but I want to show you these settings for the static implementation for the mobile as well. So here I'm just going to copy the implementation of those files. Like we have the Android settings, but again I put all the execution type, the default life cycle, the default browser, we have the default device name, the default app package, etc, etc, and all of the grid settings again. These two, actually all of its properties, they're not static, but basically they're almost identical to what we have in the web, but I suggest to use totally different settings classes so that you don't mess them up. And we have a similar configuration loader. Again, we have a static load configuration file, and again we are for example locally we are executing everything on our local APM server, local path to our application. Otherwise we are using Lambda test. That's it. And one thing that you need to consider when we use the configuration loader, you need to basically add a test setup class here. If you're using, of course, NUnit, we need to add this test setup. As you know, in NUnit and in MS Test, we have something called assembly initialize, which is a special method that will be executed only once for the project, for all of the tests, right? Like here. So we have this one-time setup, and we can execute any logic. And this is the place where we need to add our configuration loader, for example, for web. And then here I need to say load configuration. And we need to do the same for the mobile if they're in the same project. That's it. But again, you don't need to be sure to add that, otherwise nothing will work, right? Or you can call this every time in the classes in it, but I don't suggest that. Just use one-time setup, right? All right, let's review our second approach using JSON files implementation. For that, I'm going to mix both approaches. I'm going to show you two ways how to do that. First, let's add our JSON file. I already created one. Let's call this test framework settings. I'm going to add this file here, this test framework settings. As you can see, it has a very similar JSON structure, similar to our options classes, right? It has a root, the web setting, we have the execution type, but of course this type, everything here is string or a number. So we have restart every time, Chrome, browser version, we have the timeout settings, the grid settings, then the read settings, etc. Now, we can combine that, and I'm going to implement that using the launch settings. However, alternative approach will be to use this configuration manager here, the configurations, build configurations. For example, in 𝑨𝒏𝒕𝒐𝒏, the way we work with these configurations is that the only configuration that will be copied to the bin folder will be the one that holds the correct suffix equal to the configuration picked right here. And in order this to work, this will ease your job, especially when you're in Visual Studio, instead of assigning these environmental variables every time. But again, it will be up to you. This approach has its downsides as well, because through time I noticed that Visual Studio has some bugs, and especially for large solutions with many projects, when you create a new configuration here, sometimes it's not created for all of the projects, which is a problem, and you need to fix the solution files and the MS build projects by hand, which is not good. So let's use this approach. I'm going to create a special configuration folder inside our core project here, and I'm going to call that configuration. I'm going to install a few dependencies that are coming from Microsoft in our project. here are our dependencies. These are the projects: Microsoft Extension Configuration, environmental variables, JSON, this is the major one, the configuration, Microsoft configuration, and configuration binder, which is responsible for serialization and deserialization of these JSON files. This will be one of the things. The second thing that I need is that inside here I need to create additional versions of my options classes. However, they will be slightly different, and I'm going to copy the same but for the web right here. What is the difference? Let me show you. The difference is that now they're not static. Also, most of them, like here, they're actually string. They're not actually enumerations. Later we need to do that manually when you cast that. The same for the time. Instead of time spans here, we need integers. And yeah, and here we will place we will have basically two special classes. Let me show them to you. This is the configuration service. This configuration service is responsible for reading the configuration file, and after that deserializing a particular, serializing a particular JSON section and converting it back to these option classes. For example, here I can say configuration service dot get section. Since it's a generic class, I can provide here web settings, and then after that I will be able to call, for example, timeouts, something, right? Or I can do the same for Android settings or any type of options class that we have. How this works? Again, we are using Microsoft Extension Configuration. This is why I exposed that through, we need that iConfiguration root. The root of the configuration is actually this particular node, reading the whole configuration. And as you can see, we have just two methods. One of them, the most important one, is to initialize the root. The way we do that, I made and I converted here this to be copied always. And this means that all of the configurations, this means that for all of the environments, so we will have QA, we will have development. So this suffix will be the suffix of the file, will correspond to the launch settings here, to development, staging, and production. So I'm going to add one more. And as you can guess, all of the values here, for example, for the staging might be different, right? I can change them. The whole point is how I'm going to load it, and I'm going to change it. For example, here I can delete the grid settings if you are not going to execute them, right? And leave it like that. I can change them a lot, right? For every particular environment, we will have a different configuration file. That's it. So into the configuration service, I'm getting all of the files inside my assembly in the bin folder, all of the files in the execution there, and then using Lambda expressions, we are getting the first test framework settings that ends with JSON, and I'm sorry about that, this is the right version. We are reading the environmental variable, which is like again .NET environment. By default, it's development. We are formatting the settings file, and we are using the builder that will just get again the execution there, the settings file path, which we're going to combine the bin folder with the correct settings file, and we're going to add this JSON file to the builder. Later, when you say get section with this section name, the thing that I'm doing here is that when we get the name of the type like web settings, we're making its first name to lower, which means that right here. Or maybe you can skip that if you use like this syntax with capital letter, but I usually prefer to use the approach with like the way we name private variables, the same way I name sections and variables here. This is why we have an extension method that it's making the first letter of the string to lower. This is how our configuration works. And again, this get section, get method, this comes from the Microsoft library, will read just this part of the JSON configuration file and map it, initialize our web settings or grid settings or whatever section we provide. And again, this will work both for the web settings and for the Android settings. Let me show you, for example, here for the Lambda test plugin. This plugin, the way it works is that, not this one, but for the mobile. As you can see here, we can read that from the driver factory, or we can use some configurations. Imagine that we have the execution type, and we can get that from our configuration, like that. And I'm going to add the Android settings. We are going to use the files version. So how this works? We are getting the execution time from our Android settings. This is the execution type, and then I'm checking whether the execution type is a Lambda test or not. And we can use similarly in the browser execution plugin, right here in the browser lifecycle plugin, sorry. We can use the same logic, like right now, if we can get the particular section and we can initialize it if we change that right here. Let's say that we don't want this logic, but we want to use web sections. Actually, this is for the grid. We have a similar one for right here. As you can see, get configuration, we're getting the web settings, and then we're initializing all the web settings, providing to the constructor to the browser configuration. Or you can do it similarly like this. So everywhere where we need web settings now, we can provide them like that. Also, this particular approach, since this is not static, we can expose it through our app class here. For example, imagine that we can have a public property of web settings, but I'm going to get the files version. I'm going to call this web settings, and every time we're going to read that through the configuration, which is excellent, meaning that even if you implement your own app class, you can expose that instead of every time using the configuration service. You cannot do that with the web settings that are static. This means that you need to use them outside of the app class, which is some kind of a drawback. Another thing to consider is that if you want to extend the static version, like here, you can create a class called web settings extensions. You need to create a public static class where we'll have, for example, public I don't know, void at get some new settings. And in order to be able to access this from the web settings, we need to make this particular method static, and then we need to call web settings like that. And after that, when you use the web settings, for example, here, and you can do that in your own project. For example, if you use it outside of this particular repo, I will have now I will have now this access to the method as an extension method. But we need, of course, to add a using statement. All right. And also another benefit of using the approach with JSON files is that actually you can define your own sections here. For example, imagine that you need to add API settings. API settings. You have, I don't know, a URL to your API. Your API.com. You have some other arguments, etc. For example, you can have, I don't know, default port 3002 and other stuff. This means that you can add such custom configurations. You just need to create additional options classes, and this will work out of the box. This is a very popular approach for example, when we want to create custom plugins and we want to switch them on and off, or adding, for example, if you implement, I don't know, Azure Cognitive Services or something to Amazon services, then we need to provide some URLs, some data here. We can add such sections. You can achieve slightly similar thing with extension methods for the static classes, but again, it's slightly more difficult. Now, if we need to compare the static against the JSON files with sections, the static implementation have the following pros. The compile time checking reduces runtime errors. Like if you make a mistake here in the JSON, it will be harder to, you don't have the type safety. This is ideal for small projects with infrequent configuration changes. It's easy to access, easy to use because of the static properties are readily accessible through the application. You don't need these external dependencies to these Microsoft NuGet packages. Also, however, it's limiting the flexibility. You cannot add it to your base test classes or base pages or whatever, or app class. Extending configuration requires extension methods. Usability can be challenging as configurations cannot be easily integrated into the app and these base classes, and you will need to read the full documentation to understand the usage. Managing and maintaining settings become difficult as the project grows, especially with multiple environments, and requires manual creation of configuration loader classes if used as Git submodule. Configurations, of course, they will be basically different for each team and environment. While the JSON files, there are some drawbacks as well, but they allow for custom sections and easier extensibility. They are more user-friendly if integrated into app and base classes. They are better suited for complex setups and environments where configuration changes are frequent. However, without the integration into base classes, usage can be cumbersome as sections need to be loaded manually with this getSection generic method. Requires additional dependencies like Microsoft NuGets for configurations. It's less type-safe compared to the static properties with potential runtime issues, and needs robust error handling for missing or malformed configuration files. So, static implementation is great for small projects with stable configurations, offering simplicity and time safety, but lacking flexibility, while JSON files with sections provide greater flexibility, modularity, making them suitable for larger projects with dynamic configurations despite added complexity and dependencies. This was our summary. Next, we are going to cover and develop many more complex web components, and we are going to add them to our 𝐓𝒏𝒕𝒐𝒏 project. It will be quite interesting. We will use a lot of JavaScript, we will see. Many often we need to do that for enterprise projects, so this is really vital to understand how to do it. Hi guys, greetings from Bulgaria, I'm Anton, and this will be our next module from our course about developing advanced test automation frameworks. It will be dedicated to mastering of the development of complex components. In a minute you are going to understand what is this. Before that, if you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified when new videos are published to the YouTube channel of Lambda Test. Also check the awesome Lambda Test blog because there are so many advanced test automation articles that can really help you to be a much better test automation engineers. In the links below, you will find reference articles and also the link to the GitHub repo. Don't forget to switch to the correct branch for this particular module about mastering complex components. I suggest to clone the repo and check the code while you are watching the video because the code is complex, no matter my explanations. You will find also some jump links to particular parts of the video if you want to skip a particular part. So let's begin. Until now we have, I won't spend much time here, but the last time we were talking about configuration management, and before that we were executing our tests in the cloud. We're going to use that now as well. However, when we're talking about frameworks, there is also many often our websites are built not only with default HTML or HTML5 components, right? And thus we need to many times our developers, they are purchasing already complex built-in components to speed up the development of our web applications. They're quite extensive, they're quite complex, they're already tested. However, it can be a big challenge for us to automate them. Give me a second now. In the first part, I'm going to show you some demonstrations about these controls and components. After that, we're going to review their capabilities that allow us to automate them. Basically, we're going to review their JavaScript API. And as you can guess, we can use the already created architecture of our framework to integrate that and create different components inside our framework, and later helping us to automate all of the flows. So in the third part of the video, we are going to review a few examples of from very basic such components to very complex ones, and you can play with them. So let's get started and discuss what is a complex component for me. Again, this is a term that I came up with. Before you begin, clone here the repo and check out this complex component mastery branch from the Polaris white test framework GitHub repo. So a complex component, a regular component is, if you remember and if you watch the videos, I suggest to watch them sequentially from this playlist because we are upgrading little by little our framework. So our current architecture, if you remember, is that basically we have different components. We don't have just like in other libraries, we have just one generic class responsible for working with elements on the page. However, here, in order to simplify the maintainability, the readability of the tests, and to make our tests more plug and play and component based, we have different classes for all of those different inputs, buttons, emails, etc. And if you remember the second video when we developed the web core framework, all of those classes, they have specific properties, specific elements, which are making our work easier later to learn the framework and to ease our work when we automate the web pages. And this plugin architecture, component-based architecture like a Lego, it helps us now to add more components about these very complex different functionalities. Let's see them. Like one of them can be, right now, by the way, I'm not doing an advertisement or anything. I'm going just to present as an example some components that I worked in the past in enterprise projects. In my first company where I was a QA architect, they were working on these Kendo UI components. They're not only based on jQuery, but also they have similar components for desktop applications, mobile. Their web components were supporting various web technologies like Angular, React. It doesn't matter if your tech stack. But in general terms, when you buy such a set of components, they're very flexible. They have a lot of configurations, like this data picker. Of course, we have a regular data picker with HTML5. However, this particular picker, it has many other built-in capabilities, like you can switch different themes to style it. You can add many features on top of it, etc. And all of those web components, at least, they're heavily JavaScript based, right? So you have this picker. Another example is another website, FullCalendar.io. It's full-fledged calendar that it's similar to, for example, Google Calendar. And we can create events, we can alter them, we can switch to different months here. Yeah, you can check it later, the demo. But again, it's highly configurable and we can do many things on top of it. Then you have this sort of grids that, again, this is just the basic usage, basic example. They're much more sophisticated grids. Like, as you can see, we can have a grid inside a grid, then we can have a grid inside a grid with different elements here, with star ratings, with different of those more complex components nested inside with images. We have different filters, we have sorting, we can turn on and off different columns here. It's very complex, right? And again, this is just part. You can add many other features here, and it's quietly configurable. So this is another popular type of component, and it's extremely hard to automate if you don't do the things that we are going to discuss now, how to use JavaScript. If you rely on real clicks, for example, to click here and then click on the column, you can imagine that you cannot build a generic solution. I mean, for each particular grid page, you have to write these custom actions, and this will be much slower. Imagine that you have, I don't know, maybe here 20 pages. How do you navigate to the page 20 if you don't have the switch? You're going to click this 20 times or what? Or how many often we need to verify all the information inside the visible place of the grid? How are you going to do that with WebDriver? You're going to get a cell by cell. Again, this is an overkill, and we need a smarter approach. And again, there is a smarter approach, and I'm going to teach you how to do that in this module. And the last example, the hardcore, the hardest of all, is this editor. It's a very popular framework, CK editor. Like last year, I had to work on that in a project that I was involved. And it was a challenge, really, because for all those components, sometimes the documentation is really great. Other times it's harder because the documentation is fine for the regular usage, but then the actual JavaScript API is not so well documented because this is something internal for the component, and our work as test automation engineers is getting much harder. And part of the things that I'm going to teach you now is how to do this type of research, how to find all of those functions that you need, how you're going first to test them, and later how we are going to integrate them in the framework, and later how we are going to use the framework to automate some of the scenarios. Again, because I was part of a company that was responsible for selling and building those components, most of the time it's not your job to test whether, for example, here the boat is working or not. I mean, you're going to check, of course, whether this works or not, but most of the time when you buy such a component, the reason for paying money for something is that you realize that it was tested well and it was automated. And in reality, I can say, at least for the company that I was part of, they have a really great QA process, and they have many QAs responsible for maintaining the quality of those components. However, the thing that you need to check and focus is whether the component was well configured for your case. For example, this particular editor, it has tons of options here that each of them is configurable whether it needs to be shown here or not. And many often for each particular option, there are some variations how this works, right? So you need to make sure that it's working in the right way described in your requirements and acceptance criteria. So maybe this is something that you want to have automated tests for. And after that, when we expose these particular actions via the JavaScript in our test automation framework, you can just focus on automating your business requirements instead of testing the component itself. Okay, let's get started. While we already discovered and discussed that. So I'm going to begin with this data picker here. Again, in order to research that, I'm always opening the demos, and after that, I'm searching for the developer documentation about them. For example, here I have opened the data picker configuration, or I can open, as you can see, this is just the regular API reference here for the JavaScript UI for this particular data picker. As you can see, at least this Telerik website, it has a very good documentation about all of the capabilities that this component supports. As you can guess, maybe we will be able to open and close the picker. Maybe we can get the max value configured to pick as a date, or the minimum. Again, probably this is something that you want to verify, because, for example, if you're a bank or a hospital, there are certain cases where it doesn't make sense as a requirement to pick, I don't know, a date much in the past or much in the future. And this is why this is something that you need to check whether it meets your acceptance criteria. And of course, we need to verify when we pick a value or it was set by internal process of the application, whether the value is set correctly in the data picker, etc. And we want to be able to change that. So these are the main functionalities that we want to do. Now, if we open developer tools with F12, we usually need to find most of these controls. Right now, this is just a data picker and it's an input. Again, it can be an input, it can be a diff. It really depends on the company. Many often, for example, if we see the very complex grids or the editor, you will see that the whole thing is inside a single diff, of course with many other elements, but again the main logic is happening through JavaScript. So our starting point always is this placeholder for the component. In this case, this is this particular input here. So we need to initialize this picker. And when we get from the configuration, if we click, let's see for configuration, or if we want to open it, as you can see, they have very good explanations how you can initialize the picker. Here we are using jQuery with this $sign. Again, if you are not very proficient in JavaScript, don't worry. Like in the past, I wasn't as well. I was mainly working with Java and C#, and not always we are web developers, right? And understand that completely. Of course, I always had basic knowledge of JavaScript and HTML in order to be able to write automated tests, and later I got much more proficient. However, initially, when I wasn't so sure what I'm doing, I just asked my developers to help me with this initial syntax. Right now, you can check the documentation and experiment in the DevTools like I'm going to do. But in jQuery, this means find me the element with this particular ID. And this is the thing that we are going to do. So as you can see here, this is how we initialize the data picker object in JavaScript. And later, we will have some functions here, obviously, to work with the data picker itself. So let's see how this works. We switch to the console, and we are going to initialize this data picker. And I researched how this works. I checked the documentation for the value. As you saw, there is such a method. And this is how we can set the value to particular date and month. Maybe first we can initialize some variables here. Just be sure we start always from 0. So this means that this will be the 7th month. And now I can initialize that like that. Again, you can use the variable if you want. And as you can see, we set the date to July 15th, the current year. If we want to get, again, what is inside right now in this data picker, this is fine. Maybe we can type data picker. As you can see, there is a method for, maybe we can test that. As you can see, we have a method for open. Actually, in a minute, we're going to see that. But if you want to get the current date, again, you can find the data picker, then data can do data picker. And then when you use the value method, this will return the current date. As you can see, this is the date here. Later in the C#, when you got this particular string, we can convert that to C# date time. The same way you can use the min method to get the minimum supported date. Again, this can be something that you want to verify that it was configured the right way. We can get the max date, of course, which, as you can see, is 2099. We can again open the picker. I don't know why you want to do that, but it's possible. The same way we can close it. And besides that, we can get all of the options and print them. Again, maybe this is something that you want at least one test to be sure that it's working. oops, sorry, we need here to change the ID of that. Data picker. So as you can see, we have a lot of options. Maybe you don't need to know all of them, but as you can see, we can change the format. So depending on your country, the format, for sure, you need to change that. In America is one thing, in Europe is another. All right, so here is the full calendar IO. Again, how we do the research. I opened the docs, their docs, development docs. And again, not always you have so great documentation as for the can-do controls. This is why I'm checking all of the developer documentation and I'm copy-pasting in a document all of the different parts that I think that maybe they can help me. And probably here, the same way as we initialize the data picker, we'll be able to initialize the calendar. And then, as you can see, we have methods like next, preview, previous year, next year. This is awesome because if you don't have such methods, again, if you want to switch to the next year, you don't have a button here. This means that you have to click here 12 times. This is not working. Like, you don't have query parameters, you don't have cookies. So the only way to do that is through JavaScript. And we need to find those methods. Sometimes you'll be able to find those in the documentation. Other times you'll just have to initialize the component and try to figure this out from the IntelliSense. Again, the way this works is we inspect the whole thing. As you can see here, we have a div. This is what I told you. It's not always an input or a regular HTML component. This is just a placeholder, a div with the ID calendar. And this is how we're going to initialize that. You can initialize that in a calendar. As you can see, I already tested that in this like that. And then you can say calendar dot full calendar next. And as you can see, we switch to August 2024. The same way we can return to the previous month. The same way we can get, for example, if I switch here, I can use today here to switch to the current day right now. Or I can set to a specific day, for example. Maybe we can set that in the past. As you can see, we have year, month, day. We have a method goToDate, and we are getting the current instance, the full calendar, and we are switching to this particular month. And as you can see, we switch to 2022. Or we can get the current date. As you can see, here we have getDate. And this will be the method probably that we're going to use for verifying what is the current value in the calendar. As you can see, it's 2022, June 15th. And what else? Maybe we can, again, switch to today, and we can remove all of the events. As you can see, all the events were removed. Otherwise, imagine how you're going to do that. Even if you have delete methods, it will be extremely hard in these components. Most of the time you don't have inside this div other IDs. The text might be not unique, and it will be extremely hard for you to work with all that. And this JavaScript API, it's excellent. I mean, right now, another capability is to update. Actually, first we can, before updating the event, we can add an event, render the event, and we can change here new. And as you can see, we have a new event, or we can update one, which is completely fine. As you can see, we have updated title. Again, these JavaScript functions or their particular syntax is not important. The important is the exact the principle of how we use it, right? So before we proceed with the other more complex components like the grid, the color picker, and the rest, I want to show you how our tests are working and how they work. For these custom components that I showed you, I created a new custom controls tests. And as I said, in a minute we are going to review them, but inside our framework now, not the mobile project, but the web. As you can see here, I have one namespace, a folder for regular components. Again, for the ones that are like regular anchor button, the regular normal HTML tags, right? And I have another one called component.js that are based on JavaScript, that are complex. You can come up with better name, I guess. But as you can see here, I will have different classes for all of them. I have a different component class or adapter for the color picker, for the data picker, for the grid, for the gouge, for the full calendar. Since the CK editor that I showed you, like that, it's similar to Word. It's much more complex, and this is why I created a separate folder and a namespace for it. But we'll go to there. Now, in this custom controls test, as you can see, the usage is very straightforward. I mean, it's very simple. Right now we are just navigating to the demo website, and after that we're just finding this JavaScript component through its ID. After that, I'm using it as a normal component, like a regular HTML component. However, if we open the can-do data picker again, it's part of this namespace. I haven't implemented all of the methods. If you want, you can play with that and do that yourself. The way this works is that, if you remember, we have a base class for all of our web components. This web component adapter, it gives us the wrapped element, how the element was located with the find strategy. It gives us the lazy loading. This means that we're going to find the element just when we perform the actual action, not before that. And many other helper functions like hovering, focusing, setting the attribute, getting the attribute, other default methods for that are protected, etc. So we need to derive from it. This will be our base class. After that, all of the methods that we implement are actually just creating the actual JavaScript code as a string. You can use string format as me here, or you can use string interpolation and providing here the $sign. On purpose, most of the time I'm using string format because these are jQuery components, which means that we are using heavily inside the JavaScript $sign, and it will be quite confusing when you read it. This is why I use string format right now. But as you can see, we are just generating the following JavaScript here that I showed you before. This JavaScript, right? Yeah, this is this particular JavaScript. We are just setting all of those inside, right? But it's just on a single line where we provide the date. But as you can see, our method right now, it's accepting a real C# data time, and we are extracting from this data time object the actual year, month, and a day from it, and we get the ID from the find strategy that comes from our base class. Again, we can make this a little bit more complex. I won't do that now, to support different type of locators, not only ID, because sometimes you won't have the ID and you will need CSS XPath or something else. For now, I will leave it a little bit more simple than that. And when we generate the JavaScript, we just use our JavaScript service that again comes from our base class to execute that, and this works out of the box. This is how the data picker works. Similarly, I have a similar component for the full calendar. Again, we are deriving from our web component adapter. Then we have, as you can see here, full calendar method jQuery expression. This is the one that it's finding our full calendar and initializing it. And after that, we just use string format to append to this one the particular method, right? And yeah, basically that's it. I mean, since if you remember the syntax for the full calendar, it was something like the following. For example, for the next, this is the syntax that we need, and this is why this will be replaced by the actual ID, and this will be replaced by the method that we provide here, next, previous, today. But again, the whole thing is that in all of those methods, the main thing that we do is that we generate these JavaScript strings, and then we just execute them via the JavaScript service. The hardest part is not actually to write that. This is simple. The hardest part is to understand what are these methods, because many often, again, the documentation of those components is to describe how they need to be configured instead of providing you this JavaScript API. Maybe the most sophisticated method here is how we go to a particular date. As you can see, we again use string format to append here the ID. We have the go to date method, and again we use the different properties from the date time to get the current year, month, and a day. This is how this component works, and as you can see, this is the simple test and how we use it. We initialize again the full calendar, we provide the ID, and we just expose all of the methods that we might need in our tests. I implemented something similar for the 𝐾𝐞𝐟𝐢𝐬. I won't spend much time on it, but again, I just wanted to give you a little bit more. Here is the 𝐾𝐞𝐟𝐢𝐬 again. We have a regular 𝐾𝐞𝐟𝐢𝐬 in HTML5. However, again here, this data picker, it has much more capabilities and methods. And the same way, if you inspect that, this is just, in most cases, it has internally other buttons, and it might be even not, it's not an input, right? It's not like a regular HTML element, and it's not enough just to set the value even with JavaScript like we were doing for the HTML5 components, and you need JavaScript. This is the whole thing that I wanted to say for it. Now let's switch to even more interesting parts like the grid. First, before jumping to here, because it's a bit more complex, I want to show you how our grid tests are working. I created tests for the basic usage, this grid again. I implemented some and exposed some methods for this type of sorting, for filtering. Even as you can see here, we don't have a filter, but sometimes this is very, very useful, even if it's not exposed, because many often we want again to get the data from the grid and assert it, but with C# objects. We don't want just contains, because you're not sure where the particular string was, right? Also, jumping to the particular pages, again, if you don't use JavaScript, you don't have another way. So yeah, I built some tests for that. And the way this works is, again, we have a can-do-grid component. Here we find it like a normal, actually I forgot here to, we need here the URL. So I'm going to navigate to the particular URL. By mistake I delete that. So yeah, first we navigate to the demo website, we accept all of the cookies and the consent, then we find the grid. Heavily, as you will see, we have some internal weights because if we refresh here, you will see that it's using a lot of asynchronous calls. And also this is heavily dependent on what is the data binding, whether it's doing underneath some web calls to a particular web API or I don't know, some other way, because there are like at least 10 different ways how you can fetch your data. And as you can see, we have a method called getItems. This is maybe one of the most complex ones, and it's returning actual C# objects. As you can see, we have a model class that it contains a contact name, contact title, company name, country. And if we return to the grid, you will see that actually these are the exact columns here in the grid. This means that my method, getItems, will return this particular line is this grid item. And not only that, it will return all of those lines inside the list as C# objects. And later we can use native and unit assertions to verify that all the data that we want here is really here. And sometimes it's not just viewing the data, but there are more complex scenarios where the application is doing something on this data and you want to verify it and whether it's displayed properly, because even if it's fetched inside the database and saved the right way, it doesn't mean that here it was displayed the right way, because sometimes there's some JavaScript code that it's, you know, pre-formatting something, etc. It really depends. There are many different cases. And again, if we don't want always to again verify all of the data, because sometimes you won't know what's here, sometimes it may be populated on random, I don't know, then the popular way how to do that is to filter your unique name by ID or something unique that you built into the database and display just it and then verify it. And this is why I implemented a filter function here. As you can see here, we can provide the column names as constants. Right now, I didn't do that just for simplicity and for you to be easier to see what I'm doing. But this, my filter method here, it's actually accepting the column name, the filter operator, which is enumeration. And believe me, underneath, we're doing some pre-configurations that by default the JavaScript code, it's not working with our enums, and this means that as you'll see in a second, we have an enumeration and a switch, and we are rewriting the whole JavaScript code. It's more complex than that. And then we are filtering by this Thomas guy that it's part of our grid. So we have sorting again. We are sorting. We have different type of sorting, ascending and descending. Also, we can sort by a particular column. So I exposed this method. We have methods for getting the current page number, the current page size, and the getItems. And the way this works is, again, I check their documentation, like the data picker for the grid. As you can see, there are tons of methods. It's quite extensive. It took me some time to figure out all the internals and how they work. So again, in order to start, you need to search for this for the initial div that it's holding the whole thing. In our case, this will be a particular div. Give me a second to find the locators. Right here we have a div, this div with ID grid, and this row, data row grid. This is the div that you need. Again, I understood that from their documentation. So this is the div that you need. And after that, similarly to how the data picker was working, we need to select this div, and then most of these ℎ2 controls, they have this data method, where we basically say this particular div is actually a 𝐾𝐞𝐟𝐢𝐳. Give me its data. Please allow me to work with it. So right now, if I want to get the current data, get the total number of rows, I can use this data source total. And you will see in our component that many often we are working quite extensively with this data source. And as you can see, we have 91 rows. We can get the current page size. So what is the page size? This is the page size. So again, this is maybe something that you want to verify. We have 20 pages. We can change the page size. There is such a method. So this is the method to change the page size. So we can switch to 10. We can navigate to a particular page, for example, page, I don't know, 5. As you can see right now, we have 5, maybe we can go to 10. As you can see, we navigate to page 10, which is awesome. Otherwise, I told you, you need to do like tons of clicks in order to do that. Now, as you can see right now, we don't, maybe we need to reload that. Again, in order to reload the grid, there is a method for that. So we are going to reload it, or I'm going to refresh the page now to see all the stuff inside. And maybe we can sort by a particular column, maybe by contact name. Contact name, the ascending. And maybe there was a mistake in the name of the column. Yeah, it needs to be without the space. And as you can see right now, we sorted by this particular column, or you can do that for all of the columns. It's up to you. If we want to apply a filter, we can definitely do that. The filter works this way. We are initializing the grid, we are getting the data source, there is a filter method. We need to add here again the name of the column, the type of the filtering, whether it's equal, greater than, contains, there are many of them, but as you can see, inside our C# code we had our C# enumeration, but in practice here they have a very specific syntax that we will need to build this particular string later to provide to our JavaScript executor and service. And let's say that we're getting this particular name. That's fine. And as you can see, we filter that, which is awesome. Lastly, we can get all of the data. Let's remove all of the filters. We can do that. As you can see, we remove the filters. We can get all of the items as well. And usually they are returned, and we want to return them as JSON. When we have the JSON string, we can deserialize it to the list that I showed you, or just to the particular model class I told you about. Of course, the model classes, it will depend on your columns and the actual data. So in many cases, this is something that later you need to do. But yeah, you have a method dateItems, but we need internally to use JSON stringify, which will convert the current data items, which are basically JavaScript objects, and it will convert them to JSON. And as you can see, this is the exact JSON that later we are going to work with inside our C# code, and we are going to deserialize it to C# objects, which is awesome. Again, you can get all of these data as C# objects, which is awesome. Really quickly, how this works inside our code. Again, this is a bit more complex component. I won't spend all the time needed right now to explain everything, but I'm just going to point some of the key parts here. And one of them is that actually when you load such heavy JavaScript components, many often, if you try immediately to execute the JavaScript code, you will get JavaScript exception that a particular property, like for example the data source, wasn't initialized yet. In order to fight this problem, I initialized again here a WebDriver wait. And if we look closely below, you will find two methods that I'm using heavily inside of all of other methods. One of them is called wait for data source to be initialized, and the other is wait for data items to be initialized. The thing that we do here is that we are using this getGrid reference. As you can imagine, this is just the initializing line for the grid. And later, when we have initialized the grid, we are executing this script over and over again until it returns true, until the data items are not null and they have a length more than 0, or again here, actually I have here a typo. This is the data source. So we wait here for the data source not to be null, and we're going to execute that many times. And this is the way this works. Again, for example, for the filter, maybe this is one of the most complicated pieces of code here. We're waiting first for the data source. If the data source is not initialized the first time when you execute the script, it will just fail and do nothing. So when we have the data source, after that you're free again to design the whole filter logic. Again, here we use a string builder since the filter is much more complex. Again, here I won't spend now time to explain how internally the filter is working. I will just put a reference article for that. Again, maybe for the get items, this is the only method that I'm going to explain. Again, we wait for the data items to be initialized. We get the grid reference. We use string concatenation. You need to be very comfortable to use all of the string library methods, like string concatenation, string builders, and all of the rest. So here we use string concat, which will just connect as a plus sign the grid reference and this JSON stringify grid data items. This will return this big JSON that we saw earlier, this JSON, as a string. When we have this particular string, we use JSON converter that comes from Newtonsoft JSON, or you can use the native .NET Core JSON library for doing that. But this is a native library for working with JSONs that is just converting the JSON to your list of model class. This is a generic method that here we need to provide our model class, which in our case is the grid item. If it was something else, you need to provide another model class. That's it. In a similar fashion, other functions are working, like change page size. That's fine. We get the grid reference, then we use string concatenation to again initialize the grid, and then we use grid data source page size and provide the new size, but as an integer. Your methods, your users require just the integer. That's it. After that, again, for all of the people, you just need one person in your team that is responsible for building once all of those controls. After that, all other engineers will just use them as something natively part of the framework or part of WebDriver, etc., which is awesome, right? And may often, at the end of all of those operations, we're calling wait for Ajax, which will wait for all of those asynchronous actions to happen. That's it. Lastly, let's see the most sophisticated, in my opinion, component, which is basically this editor. Again, the way we use it is when you navigate to these are our tests. When we use this particular demo feature rich, let's open it. Here it is. It's loading. As you can see, we need again to wait for it. Again, we can select a particular code. We can make it italic, we can make it bold, we can insert images, we can highlight something. A lot of stuff can be done here. It's like full-fledged editor, right? Again, when I was doing my research how I can work with that, again, I read the whole documentation and everything. Here it was more challenging because, as I said, there are a lot of examples how you can configure the whole thing, but not so many, or at least it's not very sorted the right way to find how to work with the JavaScript API. As you can see here, we have get data. Probably this is something that we can get what's inside. We have set data. We have execute. Probably we'll use that to execute some commands like undo, redo. Also, here in the how-tos at the bottom, I found that they have more examples to do more sophisticated stuff. So I got some of the parts that I used from here. So yeah, let's do some actions in the console about that. Again, I'm going to include some, for example, here there is a documentation about the commands, the list of all of the commands. And yeah, as you can see, we have the highlight, we have some logic, for example, what are the different attributes. Again, this was really a challenge how to work with. And from one of the examples, actually, I found that we can initialize and get the instance of the current editor like that. We are doing a regular query selector by this particular class, and then this element, it has this JavaScript property here. And this is how we get the particular instance, and after that you can call all of the methods. For example, we can get the current HTML content, editor instance get data, and this is the whole HTML here, and you can work with it, you can change that. For example, we already have the instance, so we can set the data. This means that you're going to override that and you're going to change it, and this means right here we change the HTML. This means that you can set whatever you want as an HTML here when you see how the editor formatted it as an HTML, which is awesome. Another thing, you can get the inner text of the editor if there is some your text goes here, right? Inner text. We can clear the text like that, so we can set the data. This means, again, this will clear everything. You see now that it's empty, right? I'm going to refresh that. So again, I'm going to initialize my editor, and now we want to select all of the text to do something. And again, from there was documentation about shortcuts, for example, keystrokes. I found that when we use editor instance editing view document file, and we can simulate Ctrl+A, which, as you know, is selecting all the text. Sometimes, of course, there's some bugs, like maybe not all of them are going to work. Yeah, this is an example. This was working like 1 week ago. You need to be careful, and this is an example where when this is not an official API but internal of the component, many often, especially for this component, it happened many times, they change the internal APIs, and this is a problem because this will break your tests. However, we can, for example, if we select something like that, you can execute a command. This is how we execute particular commands. Command get bold.execute. And as you can see, we bolded the thing. We can make it italic. We can undo. For example, this is how you execute undo. Now it's not italic, but we can redo and make it again italic. We can change the font, for example, font size, 18 pixels. As you can see, we change that. We can change the font family, again, with commands. As you can see, there are tons of commands here that we can use, and this is excellent. We can move the cursor, we can simulate enter, we can click toolbar buttons. For example, this will simulate the click of the bold button. Again, this was working. Right now, probably it's better to use the commands. Or this was working in another configuration of this component. Anyway, these are my tests. I'm again navigating to the example. Then I'm getting the 𝐾𝐞𝐟𝐢𝐬 component. I'm saying that it needs to be clickable. This will wait internally for this loading to happen, and then we have methods like select all, and then I'm executing a particular command. For example, bolding the text, or getting the text, or getting the HTML. The way this works is, again, if I navigate to this particular namespace, 𝐾𝐞𝐟𝐢𝐬, as you can see, we have many enumerations like of the commands. Again, I got them from their documentation. I have some extensions, like, for example, matching my enumeration to the actual command name. This is how I'm going to execute the commands. And we have other enumerations, like different heading options, highlight colors that they support, and many other things. But if we go to the particular component now, 𝐾𝐞𝐟𝐢𝐬 component, it works the same way. We here derive from this web component. I have the text area, this 𝐾𝐞𝐟𝐢𝐬 editable. This is my wrapped element. I'm executing most of the stuff against this text area. And as you can see here, as arguments 0, I'm just again initializing all of those JavaScript snippets that I showed you before. Sometimes we can, for example, setting the text, we can do that against the text area and its wrapped element. Other times we are just executing all of the commands. Maybe the most interesting method is how to execute a command. As I told you, we have this editor commands enumeration, and we have these extension methods where we just get the actual command name from this dictionary. As you know, the dictionary is key value pairs. So this will return the actual command. I'm going to format it the right way against the current instance, and then I'm going to execute it, and everywhere I'm using the JavaScript service. Again, here this is much more complex. It requires, maybe the hardest part here is to find the actual JavaScript methods. But again, once you do it, it will really improve your test automation efforts, and our framework support that. Otherwise, it was going to be extremely hard for you if you don't have this particular architecture in the framework to support all of those heavy JavaScript components. So yeah, we reviewed the JavaScript API. Remember, this is the first part that you need to do. Read the whole documentation, experiment in the console. And after you have the snippets inside a particular document, then you need to integrate that in your framework. And you saw the implementation. We always derive from our web component, and then basically you need to be very proficient in using the string library of .NET or Java to build all of those JavaScript strings, and then we use the native JavaScript service or executor to execute those scripts. Remember that many often you will need for some of the more complex components, like the editor or the grid, to wait for particular JavaScript variable to be initialized. Otherwise, you will receive a lot of JavaScript exceptions, and many often we use the WebDriver wait internally to re-execute a particular JavaScript code to check whether something was initialized or not. And also for some cases we use, again, wait for Ajax. This was the summary. In the next video, in the next module, we're going to talk about adding more troubleshooting capabilities to our framework to ease the analysis of determining the errors in our tests, why they failed, whether this is a real bug or a problem in the tests. Hi guys, greetings from Bulgaria. This is our next module out of the Advanced Test Automation Framework Development course. And this time we're going to discuss troubleshooting capabilities. Of course, before we begin, first subscribe to the channel, hit the ring bell so that you get notified about many new videos that are published each week on the Lambda Test YouTube channel. Also check the Lambda Test blog because there are many detailed articles that can help you to be a much better test automation engineer. In the links below, you will find the link to the GitHub repo with all of the source code that we're going to discuss. And before we begin, I suggest to download and clone the repo. It's called Polaris-wide Test Framework. And for this particular course, if you're following it, I'm creating a branch for each particular module. So after you clone the repo, in order to work with this particular code, you need to check out the troubleshooting capabilities branch. And little by little, we are upgrading our solution for each particular module. And I suggest to check this course from start to the end, module by module, because we are upgrading little by little our framework. So this is the course overview. Don't get confused. These are not the exact modules. We have like 12 or 13 modules or so. These are just the bigger groups grouping the modules. And this time, this troubleshooting capabilities is part of the fourth group about operational excellence. The troubleshooting is very essential capability of any framework because, we as test automation engineers, we spend a lot of time when it's not just writing tests, of course, but at the end of each day, we need to analyze the test execution and analyze whether a particular automated test execution failure is a production bug or a test environmental issue or a problem of the test. And there are many features that can be added to any framework that can help us to speed up this process and make it much more automatic instead of spending a lot of manual work each day. Because we're going to talk about scaling, and this is not only about parallel execution, but imagine that you have 10,000 tests and even 1% of them, if they fail, it will be a lot of burden to you and your team to make this type of analysis. So through in this particular module, we will focus on these particular features, and we're going to add them to the framework. If you follow me on the YouTube, you will recall that many times we discussed parts of such features like leveraging, for example, toast messages or this exception analysis that we are going to implement again, chain of responsibility design pattern, but we're going to simplify it a little bit. Also, we can, and we'll discuss shortly, the highlighting and other smaller features. But here the emphasis in this particular module will be how to connect all of those features together in the framework in a more maintainable way, using and extending our plugin architecture of the framework so that we don't break everything if we refactor all the time the framework. And building this particular design will help us to extend it even further if needed later to bring more advanced features. For example, we are going to begin discussing how we can add BDD logging. What is the BDD logging? This is a term that I think I came up. Many people refer to BDD using this Gherkin syntax for Specful or Gherkin in Java. This is a special tool writing the tests using natural synthesis using a regular native language like English. However, in my experience, I wanted back in the past to generate those logs instead of writing the tests using this particular syntax. Instead, when I execute my test, to have a particular log of what happened. For example, I'm going to navigate to this page, then I'm going to click to the element with this locator and type this particular value there, or select this from the combo box or check this particular checkbox. You get that, right? And I was thinking that maybe many clients actually really love it, even much more than other more advanced features, and I was really surprised. And many engineers found it very useful. So this will be the first thing that we are going to integrate into our framework. To go even further, we are going to implement those toast messages. If you are not familiar with the term, these are messages using JavaScript that basically in web, these are notifications that are pop-ups that will show up particular messages. This is quite useful when you're going to see an example in a minute. This is useful when you have a video recording and you print what data you create into the test environment or what you validate on the page, etc. Because many often all of those background operations, you cannot distinguish what's happening in the video. And if we combine that with the cloud execution on Lambda test, this is super awesome, especially when you have a highlighting. After that, we are going to integrate the exception analysis that we developed in the series about design patterns. Of course, I will give you a quick refresh on what it is and how it works. But again, this basically is a solution that will analyze the failures of the test and will print a prettified message about the reason for the failure if it's something more generic. And we're going to add a little bit more troubleshooting plugins, like for example, we are going to mark the test in Lambda test as pass, fail, and also we are going to print there the native C# exception, which by default it's not happening, and we need to create a special plugin for that. Or even we can add a plugin for failing tests if there are any JavaScript exceptions in the console when we execute our test in the browser. So let's begin. Lots of things to cover. First, we're going to discuss the BDD logging and the toast messages. But let me give you just an example of what we are going to do. This is the solution here, and I wanted to show you the BDD logging. I have already executed this particular test. As you can see, we have a logger. This is, we printed that on the console. Let me move that here. So we printed that on the console. And as you can see, I added a plugin for mentioning what test we started. Then I have a walk for each of the particular actions that we did on the page. What we typed, what we verified at the end right here, with the particular value of what we verified, which is very awesome because many often we are going to generate dynamic data, and this is pretty helpful because every time this will be refreshed with the specific data that you generated. And for example, sometimes there are bugs in the test data setup, and you can provide these logs and add them to the bugs that you are creating in Jira, for example, and this can help your developers to analyze the failure. And if we check the Lambda test platform, again, these marks of pass and failure, I will show you a little bit later the plugin responsible for that. But I wanted to show you something else. Let's play this particular video of this execution. And if we jump, you will notice that we have now the highlighting, right? But also pay attention to the top right corner right here. We have these toast messages. Again, they are very similar to the BDD logging. These are the toast messages that are showing every time what we are doing, what we are verifying, and also we are scrolling down, and it's completely visible, which is awesome. In a minute I'm going to show you how we can implement that. In the past, in one of the Java courses that we had on the Lambda test, I showed you how we can integrate something similar using the WebDriver listener. However, the WebDriver listener class, it's much more generic, and it won't work for many of the parts of our framework that we have now. Since you can subscribe to events, general events, like clicking any element or typing in any element. However, if you recall the module about our complex components, for example, table, grids, and that are heavily using JavaScript, actually we don't have events for that. You have a general event for executing JavaScript, but like you don't have an event for setting an attribute. Or even if you have one, it will be super generic, right? This is why we will have to create and use observer design pattern or its native implementation of event and delegates in Java. For that, we'll see how it goes. I will show you. And something more, as I said, a little bit later, I'm going to show you how we can send, as you can see, I filtered assertion errors here. Let me refresh. This test failed, and it's marked not as complete, but as failed. And we can view all of the native exceptions here, right here. As you can see, this is directly pointing parts of my code where my test failed, which is awesome because it can help us to, again, troubleshooting much easier instead of going through different platforms to see those exceptions. For example, before implementing this plugin, I had to go, for example, in my continuous integration tool to view the exact exception, then switch to Lambda test to view the video, and then go to my code. Now I can just go directly to Lambda test, view and filter all the failed tests and check the exact exception, which is awesome. And I will have the whole stack trace. Again, we're going to implement such a plugin, reusing the current design of the framework. Now let's begin, and let's see how we can implement this type of, how we can support the BDD logging and the toast messages. For the toast messages, I'm going to use this library. It's called 𝐽graal. So we are going to use JavaScript, of course. And we will have to add to every document this link and script tags. as you can guess, since you're going to use your own application, probably in 99% of the time, these scripts in CSS won't be available there. So we need to find a way how we can add that to each particular page before you do particular actions, so that we can use this syntax later to throw the JGrow messages. In order to do that, later I'm going to show you that we are going to create a new service utilizing the new integration in Selenium about CDP, or Chrome Developer Tools protocol. It has a capability for pinning a script or executing a script and initializing it for each particular page. So we are going to create plugins about that as well to create the toast messages. As you can see, there are a lot of parts that we need to utilize, but that's fine. This is why, as I said, the most important part about this particular module is how we can integrate everything and create this particular design so that we support this type of extensibility and plugin architecture. Otherwise, your code will be full with copy-pasted code and it will be a maintenance hell later. We are going to use event and delegates inside our components. As I said, we're not going to leverage the WebDriver listener class. Instead, and actually the event firing driver, which is responsible for triggering those events. And I'm also going to use this time the native support for the observer pattern in C#, utilizing the event and delegates. Now, what are the event and delegates? You will find a link to this article of MSDN, handle and raising events. So in C#, the observer pattern is often implemented using this event and delegates. This pattern allows an object called a subject to notify a list of dependent objects, observers, about the state changes without knowing who or what those observers are. Again, in C#, these events are a way to provide notifications, and delegates are like function pointers in C++, but they're type-saved. And an event delegate is a delegate specifically used with events to provide a mechanism to bind event handlers to an event. Maybe this sounds a little bit more complicated than it is, but in a minute I'm going to show you how we can do that. So for the job, I'm going to create here two folders. One of them I will call event, and I will create one more that I'm going to name event handlers. Now for the event handlers, for the events, I'm going to create two classes for holding the data. One of them is called component actions event argument. We are going to use this class to basically hold all of the data that we are going to provide to our observers. Basically, this is like a grouping for of the data. In this case, when we trigger such an event from a component, we will hold a reference to the component itself and the action value. What is the action value? The action value is the value that we type in a text box, a number that we pick in a number box, an email that we type in an email input, or I don't know, a value from a combo box, or something that we verify in a diff. However, some of the events that we are going to trigger, for example, when you click an element, they don't have an action value, and this when we do that, we will use this particular constructor that, as you can see, it doesn't accept an action value, but instead it's just accepting the I component. So inside each component adapter, we are going to create static events. Why static? We use static events because it will be easier to subscribe later. The subscription is when you add that, if you recall the video about Observer, and when we created the plugin architecture, we had a list of all of the methods that we are going to execute at a particular point. Basically, through the event handlers, we are going to subscribe or add methods that will be executed. And we do that with the operator plus equal. So here we use the special keyword event, and then we have this generic class part of the system namespace called event handler. And as you can see here, since this derives from the base class event args, we provided our custom arguments that this event will use, this event handler. And after that, I'm going to change our base class here, that it's part and located in our base class for all of the components, the web component class. And this is the place where we are going to trigger this particular event. So I'm going to change the signature and I'm going to provide the actual event handler that we need to trigger here, the actual event. Why I use default parameter here? Because I don't want, by default it will be null, and I will mention don't trigger the event, don't fire it, don't invoke it if it's not initialized. If it's null, don't invoke it. And this way, even if somewhere I haven't provided the clicked event here, there won't be an exception. I won't need to fix it everywhere in my code. So I'm going to invoke here the clicked event, and again, in order this logic to work with with the if statement, I'm using this special operator, the question mark, and this question mark dot means that if this is null, this won't be invoked here, this won't be executed. And when we call invoke, this will execute all of the event handlers that we subscribe to this particular event, and later we're going to create event handlers for the BDD logging, for the toast messages, and later in more advanced frameworks like the ones that I developed for some of the enterprise projects, we went even further, extending this idea. And instead of only having the BDD logging, actually we have something called dynamic test cases. These dynamic test cases are actually integrations with test case management systems that if a test case is missing there, we are going to create with the API a test case with the name of the test, with all of the basically actions that the test is doing with the exact data, and we will have also validation steps into the real test case. And not only that, but if we for some reason update later our test and add new actions or delete some, and we refactor the automated test, with every execution when the test is green, we are going to update this particular manual test case in the test case management system, whether this is 𝐓𝐻𝐸R, that it's a very popular test case management system as a plugin for Jira, or Qtest, one of the maybe best test case management systems, no matter, or Azure DevOps. It works for all of them. So we can update later this manual test case. And even more, if depending on how you integrated this, you can have creating an execution for all of those manual test cases and having that. Again, it depends on the flow and how you use the test case management system. But again, this is leveraging the same design. This is why I'm saying that this module is about this design in the framework, and it's important to understand how this works. And we don't need every time to go and refactor all of the methods. Instead, we are using this plugin architecture, and we are upgrading that to support it. So we're triggering here, and also, by the way, another usage. You can, if you are sure that your tests that you are executing are super important, for example, you can have 20 of those tests that are executing every day, constantly. They're called sometimes smoke test suite. If something fails, you're completely sure that it's a bug. Maybe we can leverage the same design and architecture to create plugins for that, to create automatically Jira bugs, and adding all of those steps, BDD logs, screenshots, videos to the bug, and assign it to someone. And this can be automatic. Again, you need to be really sure that your tests are very, very stable in order to do that. But again, this is something that I have implemented in the past, and it works and it's doing a great job. Again, leveraging the same design. So here we are triggering the event. We can do something similar for the default method for typing the text. Right here, I'm going to provide the event handler, the text set. As you can see, it's no. And after that, I'm going again to trigger the same event here after we type the text right here. In some designs, some people prefer to have two events, one before of the actions and then another after the actions. And to be honest, in designs of the frameworks in the past, we have added both of them. However, through practice, we found out that actually nobody is using the event before of the actions. It's just, I don't see a practical usage of that. And usually we are triggering all the events when the particular action happened, whether this is clicking of a button or typing text. Now, all right, so I added that to our base web component adapter. And next, if we go again to our anchor class, you will notice that here now this is underscored, right? And it says that already we actually updated the signature of the method because it has a default parameter. So it doesn't make sense now to have this new keyword. So I'm going to remove the new keyword, and I'm also going to provide our clicked event. And I'm going to do something similar for the button. Again, I'm going to create a new event handler. I'm going to provide here the event handler, but be careful. We have totally different events here. You cannot reuse them. And you will see, for example, for the checkbox, we'll add event handlers like checked and unchecked, or for the date component here, we're going to add date set. We are going to add something similar for the validations, etc. Again, here we need to remove the new keyword. Here it is, the checkbox. We don't, again, the whole point of having separate events is that, again, instead of using the event firing driver, we are going to leverage our custom event and event handlers. So here now we have checked and unchecked, and in the methods below, we are going to add them. For example, here I'm going to invoke the check and checked, and after that unchecked. Like that. And the way we execute that, by the way, is that this invoke method, it accepts as an argument, as a parameter, this is actually the current reference to the object that it's firing the event, and then the second object always are the event arguments. So we are creating a new instance of our custom event arguments, and we're executing, and actually we are using the first constructor that it's accepting just the component. For cases like our text field, right here, again, we need to remove the new keyword. For the text field, we are going to use the text set, and yeah, like that. Again, we have something, it needs to be in past tense because it's executed after the action. And for example, for the date, here we are going to use the our second constructor. As you can see here, we have date set event, right? And I'm going to invoke it right at the bottom. This is a great example of how and why this cannot work with event firing WebDriver. Again, here for the date HTML5 component, the input, it doesn't work with send keys because we're setting the value attribute. And in many of the complex controls where we use this complex JavaScript to control how we set values, how we get the data, etc. If you throw particular events, if you fire them, you cannot subscribe to anything meaningful in the event firing driver, because the event firing driver, it provides just super generic methods. And in this more complex context, this is not working. Don't get me wrong, the event firing driver is super okay for most of the cases, but in such more complex setups like this particular framework, this won't work. And this is why we need to implement it ourselves. Alright, so after we implement the rest of the components, we can create some base classes. For example, the first class that we need is one abstract class. I'm going to add it here in this particular folder. Is this abstract class that it will be the base class for all of the base classes that we are going to leverage to allow our users easily to add methods and implementations for these events for the components. And let me show you how this will work. Now, for all of the event handlers, I will have a specific base class for each specific component. Like, for example, I have one such base class for the anchor, for the button, for the checkbox. All of them are implementing this abstract class, which we need to override the subscribe to all and unsubscribe to all. Again, we are using this special operator here. This basically says add this, subscribe this event handler or a method, add them to the for each statement of this event. And when you fire the event, all of the subscribed event handlers will be executed similarly to how we implemented the observer design pattern, where our execution engine actually for each all of the observer specific methods in each particular point. Again, this is just something built into the language. You don't have something similar, for example, in Java. But this is like you're using a lot of code, which is excellent. Again, we are overriding those abstract methods. In each of them, we are just subscribing to this static event or events that we added to the components. And then we are providing a protected virtual method that, as you can see, it's empty. This is the method that we are later going to override in each specific implementation. We will have one child class for the BDD logging, one more for the toast messages. Later you can have and add more for example, dynamic test cases or automatic bug logging system. Yeah, and I did that for all of the components. Nothing really special, but we're going to reuse all of this boilerplate code where we're going to subscribe to the events. One more thing here for the validations. I think one of the biggest benefits of this particular design is that we'll see again in the video, as I told you, especially for the toast messages, we are seeing exactly what we are verifying on the video. In order to accomplish that, if you remember, our validate methods are something very specific about we are waiting for something to happen and we are validating it. They're like dynamic assertions, and we're waiting for the specific thing to happen. And here to our extension methods class, validate component extensions, I added for each of the specific validate methods a specific event handler. As you can see, we have validate is visible, is not visible, value is, inner text is, etc. And then after the actual validation here, calling the wait until, we are throwing the specific event here, right? And of course, pay attention that again, for most of the parts where, for example, we are checking whether a value contains something, I have called the second constructor here, providing the actual value that we are asserting. This way, I will have access to this particular value and print it on the console for the BDD logging or in the toast message. Again, this is an information that we need. However, if you are checking just whether something is visible, then we don't provide that into the constructor here. Also, one more thing to pay attention: if for some reason this fails and the information is wrong, this event won't be triggered, because here this particular logic will throw an exception. Maybe this is something. This is maybe one of the reasons why you may consider to have one more event before the actual validation, so that you log that before actually executing the logic. But again, it will be up to you and what you want to do. Now, let's switch to the actual implementation now and don't lose time more. I have implemented already in the browser that I told you about the troubleshooting capabilities. I already implemented these child classes, implementing these event handlers. As you can see, this BDD logging button event handler is deriving from the base class that I showed you about the button event handlers. As a user of the framework, I can do that in the my custom project outside of the framework. This is completely fine. The designs support that, and we're using that for many clients actually. Again, we're deriving from this base class, and we're just overriding the protected method clicked event handler. In this case, as you can see, I'm using a special class logger. In a minute, I'm going to explain what this logger is. It's something important that I have already added to our core project. It's something that we can leverage across our framework. But as you can guess from the name, this is a logger that will log messages to the console, to the debug output, to files, and to other systems. In this log info, as you can see, we use string interpolation with this $sign in C# instead of string format. And we are going to say click, and this will print that we are clicking on the element with this find strategy. Now, in order this to string syntax to work, as you know, we can get the actual value of the find strategy, like the actual XPath or the actual ID. But if you just print the ID, it won't be clear to you directly from the message that this is an ID or it's not a class or something else. This is why, in order this toString to work, if you don't override the toString method of the specific find strategy, this will just print the name of the class, like ID find strategy or XPath find strategy, and it will be super useless. In order this to work, I overrided the toString method for all of the find strategies. As you can see here, I overrided the toString method that comes from the base class of all objects, the object class. And when you call to string, this will print 𝐓𝒏𝒕 is equal to the actual value. I did the same for the rest of the strategies here. ID equal to something. So if we return to the BDD logging again, let's see now how this logger is working. In order the logger to work, its static utility class, I added it here in our core project. As you can see here, the core project, and I have a namespace logger, and I have a static logger class. We need a few NuGet packages. I'm using the default way to do that in .NET, in .NET Core. I installed all of these related NuGet packages coming from Microsoft.extensions logging, logging abstractions, configuration console, and debug. Also, all of this infrastructure, it supports integration with other open source loggers. And in this particular case, I prefer working with the open source logger called Serilog. So I installed all of the related and needed NuGet packages for it. Again, we are going to support logging to console, debug, maybe to files as well. This is pretty useful sometimes, for example, for the files to send them via email or to attach them to a bug report, or sometimes when you debug, it will be better for you just to observe them here in the output, debug, etc. When you have the console, as you saw, we are going to print the BDD logging into our continuous integration or directly integrate that into the Lambda test as well. Now, I created this static logger class, again, this utility class, again here. So we have a static private read-only variable to the iLogger, which, as you can see, comes from the Serilog. And we have, again, logger configuration needed for creating the logger itself. So this logger configuration is responsible for initializing the logger itself. And you will notice that now I have these global settings. If you watch the module, if you miss it, check it out, about the configuration management in our framework. I showed you two ways how to do that, one with JSON files and another with static classes. Similar to this web settings class, right? This web settings class, it controls the behavior of our web project. We have a similar one for mobile. Explicitly, I added some new properties here that we are going to leverage in a minute in the plugins that we are going to create. So we have a property for controlling whether we have BDD logging, property controlling whether we have highlighting, whether we need to scroll into view, whether to enable toast messages, whether we have screenshots on failure, whether we want to enable the exception analysis or check for JavaScript errors. Again, many plugins that I'm going to show you quickly at the end of the module. However, it doesn't make sense to repeat every time the configurations for the logging inside the web settings, the mobile settings, desktop settings, API settings, and every time, right? Since they are static, we cannot create a base class for that. This is why I added this global settings class that will hold just static properties to everything that it's common and shared across all of our modules, whether it's API, web, desktop, mobile, right? For now, this is just the logging settings, but later we're going, when we talk about reporting solution and result frameworks, we're going to add these settings here to our global settings. And yeah, so I created this logging settings class, which basically have a global switch for enabling the logging, and whether we want to enable the console logging, the debug logging, the file logging. And for now, I have just a single output template. The output template is something controlling how our messages are formatted. For example, here, as you can see, whether you want, for example, to have the time here. Maybe you can strip that. If you don't want the time, you will remove this particular thing. Also, you can control the level of the logging, whether we want to print only errors and warnings or everything. Whether you want just the message, a new line, the exception. So you have a lot of flexibility. You can provide a different output templates, as you'll see in a second, for the console debug and file. For now, I just use a single output template. If you want, you can extend these particular settings to support that. So if I go now to the static logger class, you will see that I leverage a lot this static global settings class, and based on it, if it's enabled, I am enabling, and I use those switches inside these if statements, and I check the serilog documentation, how I can enable, for example, the console logging. We're providing the output template. Again, this is a string for how we want to format that, and I'm just enabling the console, the debug, and the file. After that, I'm leveraging my private static variable to log information, and we use this syntax with the params object. By default, you don't need to provide any arguments, but this supports a format similar to string format that you can leverage placeholders to format the message. And that's it. After that, you just use logger.loginfo. This particular architecture, when we leverage, again, the Microsoft abstraction and this static utility class with the global settings, means that later, imagine that this open source project in a year is abandoned and nobody uses it or support it, or there is a critical security issue there, and for some reason you want to check and change the logger. That's fine. You'll go just to this particular class. You will update that. You want to change the signature of your static methods. You'll just, update how this internally works, but you won't need to update nothing else. The only reference to the serilog is here, and that's it. This is the benefit of having this core project, because you will leverage this particular abstraction in utility class, and we are going to utilize it later. And again, in our BDD handlers, let's see them again, that we have implemented right here. We are leveraging this logger walk-info. So I have one for the clicking. Again, for example, for the checkbox, I have implemented both of them, the checked event and the unchecked event. However, you're not forced to implement all of the event handlers or to call them all of them. You can pick whatever you want. For example, as you can see, for the validate exception event handlers, I have implemented all of them here. It's nothing more than just having these particular messages here formatted right. Now, for the toast messages, before we move to the actual implementation, you will notice that they work in a very similar manner, right? We are just, again, implementing those base classes here. We are overriding the event handlers, for example, for the checkbox. And we are just using the driver adapter. This comes from for our partial class about the browser service, where I implemented these toast messages. Just in a second, I'm going to show you how this works. But we have the messages here are the same, but just the logic how we trigger those toast messages is different. And we are using JavaScript, as you will notice in a minute. But before we move to that, let me show you how we actually integrate that into our tests, how everything connects together. The way this works is that if we open our tests, like this class and the method that I executed, everything happens inside our web test class. That, if you notice, comes from our web project. It's under the core namespace and unit, and you can do the same for MS Test, of course. So this is the place where we basically connected our observers to the plugin execution engine, yeah, I added many of those. I will explain later what those additional plugins are. But for now, the important part is these two methods, add BDD logging and toss messages. The way this works is that right here, I have two static methods, add BDD logging and add toss messages. You will notice that again, I leveraged the new static properties that I added to my web settings class, and whether the BDD logging is enabled and whether the toss messages are enabled, right? And the only thing that I do here is that I'm creating a new instance of all of those classes that I created here, and I'm calling their base subscribe to all method. Basically, for the BDD logging, this will subscribe this particular event to the button clicked event. And this is how we hook everything together. Again, this logic will be executed every time when we execute our tests. However, it will be based whether this will be executed or not based on the key here, whether this is enabled or not. And if you recall, we have a special class called Web Configuration Loader that based on the configuration we picked and switched through the CLI, we are going to load different set of settings. And for now, for the development, I added all of those settings here and I enabled everything, right? But, and again, I called here the global settings as well, as I said. We are using them all together. Now, in order these toss messages to work, I have created and extended our browser service. If you recall, the browser service is part of our driver adapter here. And this driver adapter, I have added new methods called error toss messages, warning toss messages, info toss messages. And as you can see here, yeah, actually I have an error here. So depending on whether the toss messages are enabled, we are going to execute a particular JavaScript. In this case, again, we have a method execute. Actually, the magic is happening inside the prepare script. In the prepare script, the whole thing is that we are waiting for this JGrow to be initialized and to be there. Then we're escaping the JavaScript. Why are we escaping it? Because otherwise, sometimes depending on the signs and the letters that you put into the messages, sometimes this won't be a correct JavaScript and we need to escape it. So I have a specific method called escape JavaScript string. And then we're just formatting everything. It's just a single line of code to trigger the JGrow toss message. Again, you can check that everything inside this documentation. Basically, if you do that inside the console, again, if you have the links, these two links into the head of your web page, after that, you just need to type $.jgrow, and then the message, and then the toss message will be displayed. Again, depending on whether you want, there are some settings here that you can utilize and you can check the documentation, but you can use it pretty easily. However, as I said, it's not the problem how we trigger and start these particular messages inside our framework. This is easy because you just execute a JavaScript, right? But first, we need these two scripts to be added to every page. In order to support that and execute that, we will leverage the WebDriver bidirectional script feature. Again, this was added in the Selenium 4.0 release. However, here the documentation is completely missing in some places. But we are going to utilize this Chrome Developer Tools protocol. So CDP in short is this Chrome Developer Tools protocol is a set of tools that provide the ability to instrument, inspect, and debug and profile Chromium-based browsers like Google Chrome and Edge, and it offers a way to interact with the browser at a deeper level. And in Selenium, CDP can be used to perform tasks that are not directly supported by WebDriver API, but again, some other libraries like Playwright, they utilize it quite extensively. So we are going to use this pin script feature to utilize that. So I have added a new interface to our driver adapter. It's called 𝐼DevToolsService. In future modules, we are going to extend much further that, adding a lot of features regarding performance, checking memory leaks, working with network, simulating network conditions, and more. Again, if you're curious, we have on the Lambda Test YouTube channel a whole course in Java about many of the specific features about Chrome Developer Tools protocol and bidirectional APIs. Right now we are going just to implement this at initialization script. In order to do that, in our driver adapter, where we get a reference to our wrapped adapter or the current iWebDriver, I'm checking if the WebDriver is not null, and if the WebDriver is implementing the 𝐼DevTools, again, for example, Firefox or Safari, they are not implementing this interface. This will work only for Chrome and Edge, so be careful. We're creating a new DevTools session with this particular method here. We are initializing these two properties that are part of the interface, and we're getting the specific version of the domains. Again, be careful because this will work only for a version of or a tool of the specific browser, and especially when you execute this code in Lambda test, you need to make sure to match the versions. Right now, I have eased that in our framework, and in our global using class here, I have added all of those global usings with the particular versions, right? In this case, this is version 125. For this feature with the pin script, we are going to utilize this particular global using that it's part of the page domain. Now, there one more specific thing in our driver factory. You need to make sure when you dispose the driver, not here, driver factory, but in web, right here at the bottom, when you implement the dispose method, you need to make sure to check if this is DevTools, then you need to close the DevTools session. Otherwise, there might be some problems. After that, I have created two plugins that are really important for the highlight and especially for the toast messages. So these two plugins, let's see them. Again, they're part of the plugins namespace here. So I have two plugins, initialize highlight script and initialize toast messages script plugin. I'm going to show you the initialize toast messages plugin. Again, this is something that we are going to subscribe in our base web test class. As you can see, this will be executed on before test initialize. And the thing that we do here is that we are checking are the toast messages enabled? If yes, then we are getting the DevTools service part of our driver adapter. We're getting the dev session domains, the page domain, and we are sending that we are enabling this particular domain, the page domain. And after that, this page domain, it contains this particular method add script to evaluate a new document. In the C# version, all of those methods, part of the CDP, they accept settings they're implementing the command design pattern, and the commands here are actually these command settings classes. In this case, this particular command class, it has just one property called source, and we're initializing this script to the source. The thing that we are doing here is that we are saying when we're subscribing to the onload event of the page, meaning that when you load the page, this script, this method will be executed, this anonymous method. Or basically we're checking, do we have jQuery? jQuery is required for JGrow, so we need to have both. If we don't have jQuery on our website, we're going to implement a script tag, then we're going to add jQuery to the script tag. After that, we are going to initialize the $, which is very like the main thing part of the jQuery library. And after that, we're going to load the script part of the JGrow here and its CSS. We are going to add it to the head as a link to the style sheet. After that, when we are here and we execute that, this method will be available for you. This method will be available for you, this JGrow, right? Otherwise, if you don't do that, the scripts won't be there and nothing will happen, right? I have implemented absolutely the same thing about our highlighting plugin. If you remember, we have this highlight element plugin that we implemented in the previous modules. It's responsible for highlighting for a short period of time the elements that we are clicking or typing text into. And before we were executing this whole script, I mean, it's fine to execute it every time, but this time I just wanted to show you one more instance in practice how we can utilize the pin script. So I pinned this whole thing inside another plugin. It's called Initialize Highlight Script plugin. In a second, I'm going to show you. So it's initializing this method for us every time, and this is why I can make much shorter our plugin now. We just execute here this script because I already have the highlight method. It's initialized, so I can execute that. It's excellent. So this initialize highlight plugin, it works the same way. We are getting the DevTools domain page domain. We're enabling it. We're again, be careful because most of the methods here are actually asynchronous. So we call wait to wait for them to be executed. And I'm doing the same thing here, but I moved the highlight logic here and we are pinning it on every particular page. And the way this works and the way this is hooked is, again, in our core project, I have added those plugins right here using our plugin execution engine. I added them to the whole execution chain. Now, what else? I wanted to show you, if we move to our presentation, the second point was about implementing the exception analysis, that it's implementing the chain of responsibility design pattern. Again, here I simplified a little bit. It's not like the full implementation, but I implemented it a little bit more simply. The whole point about the exception analysis is that when a test fails for some reason, we have some handlers for checking what is the actual, these handlers are here. So we have handlers for checking whether we have JavaScript console warnings, whether we have JavaScript errors. Later, when we implement the features about capturing all the requests, maybe we can capture all the requests and check the responses. If something fails, maybe we can fail the whole test. We can check for specific parts of the HTML, if it's server unavailable or something else, or particular exception URL. Maybe we can fail the test. So we have a handler, again, containing a detailed message explanation that will we are going to provide to this analyze test exception, custom exception. Again, it will format in a very friendly manner with new lines, with some dollar signs. It will just print a prettified message of the problem that the handler catched, and maybe we're going to print the URL as well. And all of those handlers are implementing this base class, whether it's applicable. If it's applicable, basically here, for example, for the no failed request handler, we're going to check later whether there are any error codes, right? Again, later we're going to fix that. Or if there are any JavaScript errors, again, this is something that we're going to add in a minute. Or whether there are some console errors, or whether something is available in the HTML source code, for example, 404, or service unavailable, like that, for example, HTML source, again. And the way everything works here, again, in the links below, you will find a very detailed video about this pattern, and this is why I'm just going a little bit quicker here. I have implemented the pattern in a more simplified way. Basically, we have a list of all of those handlers. We have a link to the adapter. We have methods for adding handlers to this list. And then the core logic is executed here in this analyze method. Again, it will just for each of the handlers, it will check whether the particular handler is applicable or not, providing the actual exception that our test failed or our framework throw. And then we're going to print the formatted exception if this exception handler is applicable. The way we hooked all of that, this exception analyzation, is that I created a plugin. Again, the important part is how we plug that into our framework. It's not, again, you can watch the specifics of how this pattern works. And the way this works is, again, if we open the plugin namespace here, the folder, I have a new plugin called exception analyzation plugin. It's very simple. On after test cleanup, we are implementing again the base class plugin. I'm checking, is the exception analysis enabled? If yes, I'm calling my static analyzer here that will start the analysis. It will start the for eaching and the chain of all the handlers. And maybe if some of the handlers is triggered, if it's applicable, we'll throw the prettified message, and this will ease the analysis of the failures. Again, in order to add all of the handlers inside our base class here, the web test about in-unit or MS test, I'm going to add those exception handlers in the handlers that we want, or whether we have custom handlers, we're going to add them here to our static class. And also I'm going to add this plugin, I'm going to enable it, adding it to the plugin execution engine. And one more thing, maybe lastly, if we want, in a few occasions I showed you how we can mark tests as passed or failed in Lambda test and send the exceptions to the Lambda test cloud. This is very interesting. We have this plugin, Lambda test results plugin. Again, I'm mentioning it again here because it's important for the whole suite of troubleshooting features. So after the test cleanup, we're checking, is this a Lambda test run? And if the test passed, then we're going to execute this particular JavaScript. Lambda test status, again, I checked that from the documentation, and we are marking the test as passed. If it's a Lambda test run, and if the test is failed, then we are going to create this list of strings containing all of the exception stack trace and messages. We are going to mark the test as failed, and we're going to do a second call called lambda test exceptions, and this will send this particular information to the lambda test cloud for this particular session and test. And later we're going to see that the way I showed you in the demo before, which is excellent and is definitely something that we need to integrate. Be careful though, when you add all of those plugins, the actual sequence of adding them to the execution engine matters, because we want this plugin to be registered before the execution of the browser lifecycle plugin. Otherwise, we're going to dispose the session, and later you won't be able to send this information to Lambda Test Cloud. This is really important. Lastly, we can again implement JavaScript errors plugin. Part of Chrome and Edge, actually we can get some browser logs from driver manage logs get log browser, and we can filter them to get just the errors of them. And if there are any errors, maybe we can fail the test printing a certified message. Again, you can do that with this JavaScript errors plugin, or you can utilize the exception analyzer. It will be up to you. Just don't forget that when you initialize the Chrome options and the Edge options, you need to set this logging preference to enable the logging before that. Otherwise, this won't work. And you can, when you download the code later, you can view, we already discussed in previous modules, the scroll into view. This is, again, part of this suite of troubleshooting features. This is important when you watch the videos on Lambda test. This will scroll the browser to the part, especially for bigger pages where something is not visible in the visible part of the viewport. This will scroll and make it visible for you on the video, and you will see the actual toast messages. This is something really useful, and I encourage you to enable such a plugin and have it. If you don't use a platform such as Lambda Test, maybe you can check later how I implemented a plugin called Web Screenshots plugin. This is something that basically we are going to make a screenshot with the native capabilities of WebDriver, and we're going to save that screenshot on a particular part of our drive on our local machine. Again, I will leave it here because we're talking right now in the context of the Lambda test execution. There, for each particular action, if you enable the visual logging, you will have a video and visual capture for everything. Maybe you won't need that. Later, if you create something like automatic bug creation or something similar, it might be useful for you to attach that to the bug reports or to upload it to Azure. It will be up to you. Or later when we implement and talk about result frameworks and portals. All right, very long module now, but it's very important. Why this is important? Again, the troubleshooting features, they're really the core of your framework, because our time as test automation engineers is not only spending time on writing tests, but actually a lot of times, like 1 hour, 2 hours per day, we're analyzing failures and logging bugs, etc. And it's really important to have such a suite of features inside your framework to help you to minimize that time and give you more time to write new tests instead of maintaining the rest of the test suite. So we saw how we built this design into the framework to support and leverage new features and plugins like the BDD logging, the toast messages that are really great for enabling to see what the test is doing inside the console or the book or in a file or inside the Lambda test in YouTube in videos of the test execution. Also, we integrated the previously developed during the design pattern course exception analyzer into our framework, and we utilize the Chrome Developer Tools protocol to ease the execution of the JavaScript to enable the support of these toss messages using the pin script, and later we are going to utilize that for other features in our framework. In the next module, we're going to start building the core components for API. We're going to leverage most of them for test data management, so check it out, it will be quite interesting. Thank you for watching. If you have any questions, put them in the comment section below. Also, don't forget to check the Lambda Test blog and the community website, and don't forget to acquire your free certification about JUnit, NUnit, WebDriver, APM, and many other technologies from the certification program of Lambda Test. Thank you for watching, and see you in the next module.